Good morning. Welcome to Google I/O Day 2. Welcome to our session on what's new in Android development tools. We are so glad you joined us today, and we're really excited to show you all the great things we've been working on to help you make great apps. As a reminder, we look forward to your feedback, so please fill the survey after the session. As far as introductions, we are part of the Android Developer Tools team. Myself, I'm Jamal. I'm the product manager on Android Studio.
Hello, I'm Xavier Ducroix. I'm the tech lead for the Android Developer Tools.
And I'm Tor Norby, and I'm the tech lead for Android Studio.
Last year, we announced an early preview of Android Studio, and we're continuing to invest in Android tools. Since launching the preview, we have had thousands of active users. We had great feedback, and today we're glad to announce Android Studio in beta. So Android Studio now helps you develop apps with all the great new development models introduced in the L Developer Preview, as well as supporting Android Wear and Android TV. We'll show you a few demos and some tips and tricks on how to make you more efficient. As you heard in the keynote, we also improved Android Studio to integrate Google Play Services and Google Cloud Services. Lastly, with the Android Studio beta, we have enhanced the Android Studio Gradle infrastructure. Building on top of the product flavors and build variants we introduced last year, the Android Studio build system now supports multiple APKs and supporting form factors like Android Wear. With that, Zav will dig deeper into the build system.
Thank you, Jay. All right, so our build system is based on Gradle. You may be familiar with it by now. If you're not, our strategy was really to create a unified build system so that whether you're building from inside Studio or from your CI server, it's always the same build, right? And we wanted to have a build system that was extremely flexible, that would, as Jay said, support the whole ecosystem, whether you're targeting a watch now or targeting multiple APKs, a paid version, a free version, or different APIs. So we wanted really a lot of flexibility. And we wanted also to enable a lot of code reusability. We heard a lot from people saying that they wanted to have a lot of libraries and split their code into various modules. And so Gradle is really the core strategy for that. But the biggest thing is that we wanted that whatever customization you need to do, it would always work inside the IDE. So this is really like the integration between Gradle and the IDE is really our strong focus. So when we look back on the last 12 months since the last I/O, we did a lot of features and bug fixes, a lot around variants and things like that. We did some performance improvements, and we focused a lot on IDE integration. And so it's not a surprise that our current focus is still the same. Variant support, again, being able to generate multiple versions of the same APK. A lot of customization and APIs for you to extend your build, create new plugins. There's already some plugins out there that are built on top of our plugin. We're really excited by that. We need to focus a lot on performance. We know a lot of you are not super happy with the current performance, and we're doing a lot of work there. And we're, again, focusing on IDE integration. The IDE integration is really important. Today, when we're announcing beta, it's because we spent the last 12 months doing a lot of work on making sure that the communication between Gradle and between Studio is as ready as, well, it's not really ready yet, but it's very close, right? And if you've been using beta for Studio for the last 12 months, you probably have had a lot of issues when you upgrade to a new version of Studio, and then it tells you, well, I need a new version of Gradle, and you upgrade to that new version of Gradle, and then your build script doesn't really work anymore, and you have to edit it, and it's really painful, right? And so today we're kind of like saying, OK, this is beta. We're committing to being a lot nicer to you guys and making sure that whenever you get an update, it won't be as bad, and we'll have deprecation period of time where we change things so that you have time to adapt to the new version. So let's talk a little bit about variants. For those not familiar with it, a variant is really a way of generating multiple versions of the same APK. And there's multiple ways of doing that. The first one is through a concept called build types, which controls how your application is packaged. Is it a debuggable version? Is it not a debuggable version? What is it signed with? Is it running ProGuard? Is it not running ProGuard? So it's the typical debug versus release, but you can create more than that. You can create new build types. Maybe you're accessing a server and you want to have a version that accesses your production server, a version that accesses a staging server, a version maybe that accesses a local, on your desktop server. So you can really control all of that. The second axis is product flavors, which really controls what your application is. And the typical use case is paid versus free or any other sort of differentiation that you want to do. And it's a very flexible mechanism. You can have custom manifests for each of those. You can have a lot of source code separation. And it's also something that you can use right now to do multiple APKs that the Play Store support, like per density or per ABI multiple APKs. So for example, you're publishing a game, you're going to want to have one version with the ARM code, one version with the x86 code, and one version with the MIPS code. Even though it's possible to do it that way, it's not super efficient because the flavors are really meant to be very separate. And when you split, for example, per ABI, what you really care about is just the final packaging to just have 3 different APKs, but everything else is the same. So we're going to introduce very soon a concept called multiple APK splits, which is a much more narrow and focused concept about really just doing density and ABI splits. And the benefit of it is that the build will be much faster because all the things that are not specific to that split, so anything that's not relative to building native code, for example, will be shared across all the variants. We also added some features in the last 12 months. We added variant filters. So variants are really a combination of build types and product flavor. So if you have a certain number of build types and a certain number of product flavor, we're going to make every possible combination of those. There are some cases where you don't want those combinations. For example, if you're splitting per density and you're supporting Gingerbread and ICS on different APKs, well, there was no Gingerbread extra high devices, so you don't care about that particular combination. So you should be able to say, I don't want this one, don't build it, so that you don't build things that you don't care about. Next, we improved a lot dependencies. So when you have product flavor, you're probably going to have different dependencies, right? So for example, let's say you're doing a paid and a free version. Your free version will probably maybe be ad supported, and so you're going to depend on a library providing your ads. To do that, you'll have a dependency only on that version. So the variant mechanism is, the dependency is like, for each variant, we combine all the dependencies coming from the different elements, like the main dependency, the build type dependency. You could have a debug-only dependency if you wanted, and then a free-only dependency if you wanted. And we combine all of that together. On top of that, we also have different types of dependencies now. That's something that we improved a lot recently. You used to have mostly a compile dependency. Now we have a provided dependency scope, which is only used at compile time, but is not packaged with it, with your application. We have a compile scope, which is the regular one. It gets both used at compile time and at packaging time. And then we have a packaging-only scope, which is called APK, actually, which is only used for packaging. So you could actually do something where you link against a particular version of a library, but you package a different version if you wanted to. And then finally, on the variant side, we have a new manifest merger. So this is really a very important part, because when you look at your variant, you could have some, for example, permissions that are very specific to your debug. For example, in order to have better crash reporting, maybe you want to use the read logs permission, which really you shouldn't be using on your final version. So you're going to have a manifest in your debug build type that includes that permission. On your flavor, you're probably going to have, if you have ad support, you may be needing the internet permission, so you only do that on the manifest of your free version. And then if you're depending on some libraries coming from somewhere, either your own or third party, those may also be needing permission, may be declaring activities, declaring services, and you really want to merge all of that together. So the old merger was pretty basic and didn't do much. It didn't do any merging of any nodes. So for example, if you had a library that defined an activity and you wanted to reuse that activity node coming from that manifest, but wanted to tweak it a little bit, you couldn't actually do that. So it was really a big problem. So the new one allows you to really merge nodes coming from other modules and to really have control over the merge and to really be able to do what you want to do. So for example, here, what you have is an activity So this would be in your application, and let's say that this particular activity, and the way to identify here is the class name, right, is coming from your library, and all you want to do is basically replace the label with a different resource. So here you say Android label, you put the label, and then you have this new tool replace attribute that says just replace the label. And we're very strict about it. Like you can't just replace it without telling us you want to replace it, and that's because if you say label, if the label is not defined in the library, you can set it in your application. But if suddenly, without you knowing, the library defined its own label, it needs to tell you, well, there is a problem, right? You did add it when it wasn't there before, but now it's there, so you should break. So we force you to explicitly say what you want to replace. Another feature we added to the manifest merger is the ability to inject values into it through placeholders. The big use case here is things like the provider authority, where it's very dependent on your package name. And we know that when you have a lot of variants, they can have all a different package name. And then you would have to basically duplicate that provider scope in each of those variants, and that just didn't really scale, right? So here you have a single provider in the main manifest, and you just inject the final package name for the given variant. OK, so another thing that we worked on variant is variant publishing, which is really so here's the issue. The variants, the libraries also have variants, and by default, they have debug and release. So of course, when in your application you want to build for debug, well, you kind of want to use the debug version, and that doesn't work currently with Gradle. And then when you introduce flavor, there's a lot of work that needs to happen there. And so we're working on that. It's not there yet. There's some changes that we're working with the Gradleware company, the company behind Gradle, to make that happen. But it's something that we're very aware of. I think it's one of our top-rated bugs on our bug tracker. And it's something that we're focusing a lot on. So things will happen there. Customization. So we did also a lot of work on helping you customize the build script as much as you want. So we have a bunch of new parameters here and there. I think the most interesting one is the build config, which is a class that was created automatically, and that added a debug version. So now we automatically inject the package name, which is especially important when it changes on each variant. We inject the version name, the version code. We inject which variant and which flavor and which build type you're using. And now you can even inject new versions. So it's very convenient if you just want to inject a few flags that you want to use. You can also do that with resources. It's very limited to value-based resources, so string, integers, and dimensions, and stuff like that. And if you want really full customization at the variant level, we have different source set also per variant. We used to only have the debug source set, the flavor source set. Now we have pet debug is a source set that you can use to do customization specifically for that variant. So for example, here's an example of a build config. So here we define two flags, feature 1 and feature 2, that are both false by default. And then in the ped flavor, we override just the feature 1 to be true. So that way, if you have some code that's not really variant aware yet, and you just want to put a quick switch saying, hey, if I'm in that flavor, do something, in that other flavor, do something else, you can do it easily here. APIs. So we did a lot of changes in the APIs. One thing that you need to be aware of is that as a developer, you're going to define your build types and your flavor. You're never saying, I want a particular variant, right? You only say, here's my build types, here's a dimension of flavor and the value in it, here's my other dimension of flavor, and here's the version in it. And from that, we do all the combination ourselves. And I mentioned earlier, we have that variant filter to at least be able to exclude some variant. So to be able to actually do work on a variant, we have an API that once we create all those combinations, you can go and query, go and look for variants. You can actually, right now, you can only loop on them. We do want to have a better query API to be able to query for a set of variants based on, for example, give me the debug variants only. But right now, you can only loop on them. And then you can do a lot of work on them. You can access all the tasks. So you can create new tasks for each variant and inject yourself in between existing tasks. You can change some parameters on some of those tasks. The build config things, all the things that you can do on the build type, you can also access the merged version of all of that and do per variant changes of all of those parameters. So there's a lot of work that's been done there. And we're also, some of those API are actually used by the plugins that I mentioned earlier, that go and do those manipulations for you. So we're super happy to have those plugins currently exist. There isn't that many of them. There's maybe like 2 or 3, but they're already providing some good features. And some of them, so there's an example. One of them is a annotation processor plugin. You just apply it, and then you can do annotation processor in your code. One of the things that it does is that it creates some new code for you, right, based on the annotation processor. And so it's creating that code into a new source folder somewhere. And well, we kind of need to tell the IDE that there's this new source folder that you need to use, right? So we created some APIs to be able to have that plugin go and tell the model that Gradle sent to the IDE that there's a new source folder. And that way, any plugin that's generating some new Java code can automatically be recognized by the IDE. And inside the IDE, you have code completion. It all works, even with the generated code by a third-party plugin. OK, so we have support for Android Wear now. So Android Wear, you probably saw the keynote yesterday. And you have that new micro app that you can run directly on the watch. And the way it's delivered is that it's packaged inside the main application. And Gradle will handle that for you. There's a couple of extra steps that need to happen, like creating an XML file that contains a description of what this app is, and then an entry in the manifest. And Gradle will take care of that all for you. All you have to do is that. So there's 2 options here. The first one is you just use the Wear app dependency, and you just link to another project. And that works fine if you use Gradle to build the final release version of your code, because it's going to basically call into that other project, have it built, take the output, and package it. So when you do the release version, Gradle needs to be able to do the release signing of your app. If you don't do that, then the second mode is something you can use, which you directly point to an APK. And here you would basically, on your CI server, instruct Gradle to build your micro app, do your custom signing, and then create a new job that inject the output of the first job into the second job. I mean, here I put a basic path, but you could inject that through a property, through an environment variable, or something like that. This is mostly done for release. For debug, by default, it doesn't package the app. And that's because the workflow for debugging is more, you deploy directly to the app from Studio, you deploy directly to the phone from Studio, and that works directly. So ID integration. So I mentioned that earlier. We have an updated model, right? We did a lot of work to make sure that the model sync works a lot. And we're going to keep working on that. We have improved sync. So sync is when we send the model from Gradle to the IDE. And we have done a lot of work also on improving the overhead of the build. There's still a lot of work to be done there, but we did a lot of improvements, so you should try it. And also, we know that there's a huge learning curve about Gradle, right? And so we're doing some work inside the IDE. We have a project structure UI. We have editor support, and we have a lot of link check to help you deal with creating Gradle stuff. So performance, we know it's very critical. We are looking a lot at build versus incremental, right? Incremental is the part that really we worry about from inside the IDE. And we did a lot of investigation, so we kind of know exactly what the bottlenecks are. And those bottlenecks there's really 3 of them. The first one is project evaluation, which is really a problem when you have a lot of modules. So we see people with like 200 modules, and it takes a lot for Gradle to really load all of those projects and start knowing what to do. And we're working again with Gradleware to, they're working a lot of work there, so we know exactly what's going to happen. Incremental support in task, it's making our task be more incremental. So APT is not incremental, Dex is not really incremental. So we're working on that as well. It will come in next few months. But and then finally, task parallelization. It's mostly important for CI server when you build a lot of variants. From inside the IDE, you build only one variant anyway, so it doesn't really matter too much. OK, and then finally, the road to 1.0. So we just announced beta today saying, this is going to be a lot more stable from now on. We're not saying there's not going to be any small breaking changes, but we're going to be a lot more careful, right? The bar has been raised for our changes to not break you guys. But in terms to get to 1.0, we need to finalize that IDE model, that exchange between Gradle and Studio, so that you can upgrade one without having to upgrade the other one. And DSL is like the format of build.gradle. We don't want to have you to rewrite your whole build.gradle every time there's an update. And then finally, those 2 other features, variant-aware dependency, that's the whole debug versus release for libraries. And the compatibility with the other Gradle plugin is something that we need to look at. It's going to have some impact on the internal infrastructure of the plugin, and we want to make sure that those destabilizing features happen sooner rather than after 1.0. OK, and with that, I will turn to Tor, who will give you a tour of Studio.
All right. Good morning, everyone. On the tools team, we like to think of this as the Thursday keynote. If you're coming from Eclipse, the first thing you'll want to do is import your project. So you just invoke import project, you point to your main application project, and then you tell us where you want to put it. And the reason for that is that this is not so much an import as a migration. So in Eclipse, we didn't have libraries with resources. So you had to do this. You had to, for example, drop in all of ActionBar Sherlock with the source code and the resources, because that's just what you had to do. So in our import, we try to reverse that process. So when the import is done, you get this summary where we tell you what we've done. So you can see that, for example, it found a jar file that it recognized as a dependency. So it just puts in the dependency instead. And that means that you no longer have just a jar file sitting in your file that you have to worry about. Gradle can check this out whenever anyone builds your project. Likewise, it recognized a source library project with all the sources and resources, and it got rid of it and just replaced it with a simple resource again. And last but not least, it tells you how it remapped the source files. So you can see here that it's moved, for example, the resources and the source folder into this main directory. So there's the new Gradle build system has a much deeper directory structure, and there's actually a good reason for it. So let me switch to a slightly more complicated project. So I'm going to invoke the project structure dialog. And here you can see I have several flavors. So I have a free version and a pro version, and I have different application IDs so that they can both coexist in the Play Store. I have different build types, and those can also have different application suffixes so that I can have them both on the same device at the same time. And dependencies. So the whole point, though, is that since I have these different source sets, I can actually do per source set overrides. So for example, I can have a debug manifest that gets merged in, so I can have, I can ask for a mock location only for my debug builds, or in my beta build, I can, change the string, for example, to say this is the beta version of the app. So that's why we have this new directory structure, but we do realize that it's a bit inconvenient to work with. So now I want to show you a feature we're working on that didn't make it into the first beta build, but it's going to help work with these deeper directory structures. So it turns out that you can actually choose how you want to view your project. And so we're adding this new Android-specific view. And when you invoke that, you can see we're putting all the build scripts in one place, so you can easily find them, all the manifests in one place, all the code in one place, and my favorite part. Wait. Wait, you haven't seen the next thing yet, because this is what I like. So if you've had any non-trivial Android projects, you probably had resource folders that look like this, right? 20 of them, the whole screen. And you had to look for a file. Well, look at the resource folder here. It's flattened. So for example, my drawable folder, I can instantly see that I have a launcher icon. It's shown as a single file, but if I expand it, you can see it actually have all the different icons. So this makes it a lot easier to find your files. Similarly, in the values folder, there's just one value folder. In here, I can see, well, all right, I have 9 different string files. I have 2 different style files per version, and I have a couple of different dimension files based on. So anyway, look for this in one of the next few Canary builds. All right, so that's the import flow. Let me show you the new project wizard. So one of the things we're doing now, which is simple but kind of useful, is we remember your domain name so you don't have to keep entering it. So we can sort of carry that forward for each new project that you create. And so on the second panel is where you choose your min SDK version. And we've added this help me choose link. So when you invoke that, you can click on the different API levels. And we're showing you the features that came in that API level. And we're also showing a recent distribution percentage for that version. So you can help decide your trade-off between features and distribution. So you can see also on this panel that we now have support for the new form factors. So I can add in TV, I can add in Wear and Glass. And as I walk through the wizard, I get to choose an activity template for each one of those form factors. So here is my TV activity. We have a sample that we're going to show you a little bit later on. Here's my Wear activity, and there's a couple of Glass activities. So let me show you the design time experience when you deal with Wear. So here is a layout that has been designed for Wear. And you can see that it's showing it with a square form factor. Later this summer, you may want to also try to switch to the round form factor, so you can sort of see what the layout looks like. Or better yet, you can show both at the same time. So now, when I'm making an edit here, let's see that I'm adding a little welcome label at the top. This might look good in square, but look what happened to round, right? No good. So this would need some more visual tweaks or maybe a per shape layout. So speaking of visual adjustments, Android has had bidirectional text support for a couple of releases now. And so we've added support for right-to-left text in the tools. So let me open up a layout that I believe is correct. This one should work in right-to-left locales. So let me now switch to this mode where I can see it simultaneously in right-to-left mode. So when I do that, I can see my layout left to right on the left, and then right to left over here on the right. And I can instantly see that while the name and email looks like it's OK, there's a problem with the phone number. So I could go and fix it, but we also have this refactoring that'll convert your entire project called add RTL support where possible. When I do that, it opens up this refactoring that basically goes through and fixes all the attributes in the correct way. So let's just do that. And you can see that it now updated my layout just to fix it. Now, if you're doing custom views, you probably have to do some work on your own. But certainly, if you're using the built-in widgets, it should just work. And by the way, if you're making edits in the layout editor, it should do the right thing to begin with, right? So I put a button on the left, it shows up right aligned properly. All right. So let me show you the action bar. So if you look at the action bar on the right here, up until this morning, the layout editor would only show you the title of the application. We just had some design time hacks to put that in there because it's very difficult for us to know what the activity is going to do. But when we know the activity, we can actually, as you can see, figure out what should go in the action bar and show you those icons right there. And in fact, I can even click on the overflow menu item and see the menu. And if I click on one of the menu items, actually, sorry, I clicked on the wrong thing. If I click on one of the menu items, it'll navigate to the corresponding menu file. So now I can obviously continue to edit in the menu file and see the visual effects there. And we're hoping to have some more graphical way of actually adding menus soon. All right, so let's talk about the new material design. So as you can see, this is not material design. This is hollow. And the reason for that is that this app has an application theme, and where we've explicitly asked to inherit from theme hollow. So let me go ahead and upgrade it. And the way you do that is to just inherit from material light instead. Quick tip, when you're doing code completion, press tab, not enter, and then it'll just replace the whole string. So when I do that, and I jump back to my layout, you can see it now does the new L preview rendering correctly. Now, if you look carefully, you'll see there was a red underline, and this is saying this is not safe because using this theme requires API 21, and you're trying to support API 9. So we now have a quick fix for this, which basically says, when lint says that there's an API violation, you can override it in the right folder. So I'm going to invoke that. And now you can see it's created a values21 folder with a file. And I'm just going to put hollow back in the V14 folder. And I'm going to put material in the V21 folder. So now I've arranged for this to work correctly. But how can I be sure? Right? So now I'm going to show you a different feature where I can actually ask for it to render this layout across different API versions. So when I do that, you can now see material design. Right. So you can see material design, and you can see the new navigation buttons, and you can see the hollow buttons over here, and of course, gingerbread without the action bar and without navigation buttons. So another cool thing in material design is that the theme lets you actually add color. So the way that works is that you go into the theme, and you can override a couple of attributes. So I think it's color primary, and I've already predefined a brand color. So this can be anything. There's actually two attributes I want to set, color accent. So when I set my own colors, but you can see in the gutter here, it's a shade of blue, bluish. When I go back, you can see we now get our own sort of branding. So this new theme makes it very easy to add your own splash of color. And it's not just for text. You can see that even the widget here is using this color. And more importantly, you can even do this for bitmaps. And the way that works is you can see we have a XML drawable here. I've already applied a tint. So this is what the image looks like to begin with. And I can apply a tint, which is the same color resource. So you can imagine you could set a few color resources in a few places and theme the entire app. You no longer have to go and generate bitmaps to get your own look. Since you're going to be working with themes, we've added a new really useful feature to the quick documentation. So quick reminder, quick documentation is F1. When you're in code, you can just press it on a method call to see what it does. If you're in a resource file, you can press F1 to see, for example, all the translations of a string. Well, themes are particularly useful. So quick reminder, when you have a resource URL that starts with an @ that's a normal sort of resource reference. When it starts with a question mark, that's a theme lookup. It looks up the resource in the current theme. And look what happens when I press F1 on this one. Let me make this larger. So here, it's telling me what this resolves to, the style. It's walking up the style inheritance, showing me which styles I'm picking up for which attributes at each level, and resolving all of those. So I can quickly see what text appearance medium will look like in the Holo theme. So this basically makes it a lot easier, I think, to work with themes. It's a bit like a DOM inspector in web design tools. All right, let's look at some code. So Studio is built on top of IntelliJ, and IntelliJ already has hundreds of code inspections. So it flags erroneous code in your various files. As you can see here, it's saying there's a possible null pointer problem here. There's some unused code and so forth. And on top of that, we've added some Android-specific checks. So here, for example, this is an integer parameter, but it's expecting an integer resource that represents a layout, and we're passing a string, which is clearly wrong. So when I fix that, it's happy. So we're making sure that you're calling the framework correctly. And that's all well and good. But wouldn't it be nice if you could check your own code? So now you can. Here's a method that I've added where I'm taking a couple of integers, one representing an ID and one representing a drawable. And let's add some annotations on this. So I'm going to say that I am expecting this integer to represent an ID. I'm expecting this one to represent a drawable. And now you can see it's flagging problems in the code where it looks like I've flipped the parameters. So the compiler was happy. So we basically have added some type checking to the resource system. And if you basically build a library, it also will export this metadata so that anyone using your library will also get the same types of warnings. So that's inspections. They basically, you can see, show up in your code as highlights both on the right as well as in the code. IntelliJ also has something called intentions, and they're invisible, right? So the trick to know is that in certain places, you can press Alt-Enter, and it'll offer to do certain things. So for example, here I have a string, and it'll offer to extract this as a string resource. Likewise, here I have this if statement. Inside the if, where there's a cast, I can invoke it, and it'll say, hey, do you want me to insert a declaration with a cast here? Right? Or I have some nested ifs, and I can merge those into a single, or maybe I can split them apart. You'll only discover this by either trying Alt-Enter everywhere, or you can open the options. And there's actually an intentions list here. I would like to encourage you all to read through it and click on each one. It'll tell you what to do, because you'll become a much more productive programmer with this editor. You'll find that you never have to sit and create methods. You just write the method call, press the right keys, and all of a sudden you have the method inserted. So this is a really, really powerful IDE that we're building on top of. And so you're going to be much more productive if you really get to learn all the ins and outs of it. So with that, I'm going to turn it back to Jamal, who's going to tell us about our future plans.
Great. So great tour. That was great. A lot of great, cool features. So the keynote yesterday, we talked about and introduced the L Developer Preview. With the preview, we give you a set of few extra tools, including a few tools to make you more efficient in making apps. On the Developer Tools website, you can now download system images for the Nexus 5 and Nexus 7. Also, we've enabled the Android emulator to support Android TV and Nexus device emulation. Let's switch over to the second demo. So in the emulator, now you can switch between the new lean-back experience. And as you're developing your Android TV apps, you can also try out the new lean-back discovery view as well. So switching over to the Nexus 5 emulator, we also talked about the new notifications. And so in the emulator, you can also try out the new notifications. You can swipe that away. We've also included inside the emulator the new calculator application. And here you can see the new sort of the material design, the new ripple effect as well. And lastly, I also included a new demonstration of the dialer. On the screen?
Bottom right.
Where is it?
Bottom right.
Yeah. Dialer. OK. And again, you can see sort of the new ripple effect on the different tabs and columns as you move around. And again, if you don't have a Nexus 5, Nexus 7, you can try the emulator. Also, you can download the images from the website as well. So great. Let's switch back to the slides. So as you can see, you can try out your new app and new design language on the Nexus 5 or Nexus 7. Or you can try it out on the emulator for the TV and for the Nexus 5. So what's next? So hopefully you enjoyed what we showed you. We showed you a lot of great tools and tricks from the LDeveloper preview. You can also still download Eclipse ADT. But as you can tell, we're spending most of our development effort on Android Studio. On Android Studio, we showed you a lot of new features to make all your great apps for these new form factors. But we actually didn't show you all the great things. There's still more stuff that you can actually try out yourself. So as far as next steps, we talked about a number of things about the build system. The goal is to focus on stability and performance. From the build backend to the IDE, we're looking at making the entire development experience faster and more efficient. You can check out the details of our work in progress on our roadmap on the tools.android.com website. As you try out Android Studio Beta and the LDeveloper preview, we welcome your feedback. And please let us know how it is. And that's it. For Q&A, please visit us at the Android booth on the second level at 10 o'clock.
We actually have a few minutes.
Yeah, we do have some minutes, I guess.
If anyone have any questions, come to the front.
And then lastly, so leave feedback on the QR code or with the I/O app. And thanks again for joining us. And we enjoy coming this morning. So Q&A.
Hi, my name is Conrad. I'm at University of Washington. And my group focuses on accessibility. And there's not that many tools to develop accessible smartphone applications. Are you working in that sphere at all, and making more support in the developer tools?
Well, we have some things. So Lint goes and looks at your code to make sure that you're not making mistakes. If it finds an image without a content description, it'll complain. I know a lot of support in the framework as well. Beyond that, I'm not sure if we have anything planned.
We should definitely do something, but I don't think we have a lot right now beside those lint checks.
OK.
I have two things. One is, are you planning on supporting multiple testing profiles? Like we use RoboElectric, and you have to kind of override the main one, but we also do integration testing. And secondly, are you going to support testing outside of an emulator or device so you can run it headless on a server?
I couldn't quite hear all the details. I heard RoboElectric.
OK, so basically, are you going to be able to support multiple testing profiles so that you could run both maybe an integration test and a unit test and have them separate?
Yes, we do want to allow you to have. There's two different things. We definitely want to help you with unit test. It's kind of difficult to. We want to improve the current situation because we understand that RoboElectric is not a perfect situation. It's very difficult. I was answering that question in the fireside chat yesterday. There is, pure unit test. If you're going to use any of the Android APIs or if you link against them, it's very difficult to run on a VM. There are some things that we can do that we're going to try to do. We also want to improve a lot like the deployment time, because it's really, where it runs doesn't really matter. What you want is quick turnaround, right? You want to be able to fix your test, do a change, run the test right away and get the result.
Right.
If we can get that on a device, then it should be good enough.
Well, it can also run headless because we'd run it on
right,
like
so
continuous.
we do also need to have, so that's the other part of it, right? We also need to make sure that on the CI server, you can run emulators there, start them just for that. And we have plans for CI features, we just don't have them yet, but it's our plan to do that, yeah.
Okay, thanks.
Okay.
Hi, my question is about training resources. I work at a community college where I teach Android programming, and I was wondering if you could recommend, it's a little bit difficult. Things are always changing. Textbooks are out of date. If you have any recommendations for people who are new to Android to point me towards certain resources.
Yeah, I mean, we're in a weird situation right now where, we're focusing a lot on Studio, but it's not 1.0, so the current website doesn't show a lot of Studio documentation because
I just read that there's a new course being offered that is using Studio.
Yeah,
a bunch of DevRel was working on.
Is that the one on Udacity?
Yes.
Yeah, okay, I saw that just went live, I think yesterday.
Yep.
Yeah. But we also, I think we have some new documentation about Studio going live today or yesterday with the website.
Yeah.
And on our way to 1.0, we are definitely going to improve the online documentation to talk more about Studio.
And if you can let us know what you find is lacking, that would also help, direct effort in the right places.
I'd love to get together with you guys. Will you be at the Android booth and be able to talk a little bit so we can talk about resources and things like that? Thank you very much.
Hi, I've got two sort of short questions. One is, do you plan on adding C++ NDK support to Android Studio, and how soon?
We are starting to work on it.
Okay. Will that include debugging support, C++ debug? Okay, great.
Yes.
Second is the import feature from Eclipse looks really nice, but I'm a little worried about how it's going to affect the directory restructuring is going to affect our Git history, because we've got a lot of Git history.
Git is actually pretty good about recognizing file moves, because unlike other version control systems, you don't have to tell it, I move this to that. It just looks at the file contents and figures out, hey, this looks like it corresponds to that. So, given that there's no other edits that it makes to the files other than move them, I'd be very surprised if Git didn't do a good job.
Yeah,
okay.
It should just work. Yeah, we're not touching the file, so it will work.
Great, thanks.
Hi, we have an app which has multiple DEX files, and some time back we had tried to use Gradle, but the support for building an APK with multiple DEX files was pretty limited then. Has it changed since in the last few months, or
no,
it's still? Are there any plans to add support for that?
I think so, but I don't know the detail really. But we know it's a problem, and we're aware of it. But I don't think we have any ETA or announcement at this time.
Is there any recommendations for workaround? What can we do to still use?
Yeah, I'm not super familiar with that part, so I'm not sure. But we can talk after if you want to get into more details.
Cool. Thank you.
You mentioned about the build config in your session, like feature 1 false, feature 2 true or something, right? So is that work as preprocessor directives in the C where I can escape from the compilation, or is it on the runtime it works?
No, well, so because it's a Boolean, right? It's a Boolean flag. Javac will just remove that code anyway. So in your code, if you have if feature, then do that, and you compile against a version of build config where that particular flag is false, the code is going to disappear. So it's not really preprocessor, but you won't have unused code in your code anyway.
Oh, that code will not be included in my build?
Because you make a final, right?
Yeah, it's fine. Yeah. Because it's just a constant Boolean, like a final Boolean, so it just, it's just being removed.
Oh, thank you.
Cool. Hey, I'm Lisa. I'm from Etsy. I really like using Gradle. It's awesome. So thanks for all the work you guys have done. I do have a kind of like a question/request. Gradleware does a great job on documenting all of their APIs. So figuring out how to use Gradle tasks is really easy. Do you guys have plans for similar API documentation for the Android plugin? Because right now it's been really hard to find stuff.
We definitely, that's similar to the previous answer about training and documentation. Things are changing a lot, so we don't want to spend a lot of time on the documentation right now. And also, there's I've seen like external plugin using a lot of the internal APIs, so we still need to figure out exactly what will be public and non-public. But we do want to have, because that's the goal, right, is to have a really extensible build system. So we need to document a lot of things. We need to have a lot of reference documentation. So long-term, yes, probably not before 1.0. We want to improve it because I think the current one is sort of out of date now. So we want to improve it.
But we do have a Google group where you can basically ask about things. So if something isn't clear, it might not be just lack of documentation. It might be an unintuitive API we should fix.
Yeah, sometimes it's hard to see when you do changes to the API. Like you have to know to follow the right group and like G+ or be on the
Well, we're hoping to stop breaking everybody.
Yeah, that's the goal of beta, right? It's to be more stable. I mean, there are some unintended breakage when we realize that people are using API. Maybe they shouldn't. So we can't do much about that. But the public APIs, I think, are more stable now and will deprecate rather than break them. So we can start documenting them.
So I'm sorry, we're basically out of time. So we're going to go to the booth on the second floor. So if you have questions, please join us there. Thank you, everyone.
Thank you, everyone.
Google I/O is just around the corner.
And we're really excited to show you what we've been cooking up. For the first time, in addition to our live streams, we are rolling out over 100 I/O Bytes.
Short videos to help developers like you dive in.
And experience I/O anytime, anywhere.
We're delivering more content.
And making it easier than ever to design,
develop, and distribute.
And making it even more accessible.
And it's all for you.
It's just for you.
It's all just for you.
Developing scalable apps, developed with Google, is your guide to the most efficient way to build scalable applications on Google App Engine. Learn how to architect and build highly scalable, reliable apps by leveraging Google Cloud Platform. This class covers concepts like platform as a service, infrastructure as a service, data storage, caching, cloud endpoints, and more to help you develop a highly scalable backend that works seamlessly with both web and native mobile apps. For more information, visit udacity.com/Google.
Hello, my name is Alok Chandel. I'm a user experience designer on Project Glass. Today we'll be talking about how to create some great experiences on Glass. We'll look at what are the great experiences on Glass, and then how do you go about creating some of those. Let's get right to it. What are the experiences which feel right at home on Glass? Keep the user in the moment. As a user of Glass, if I'm walking down a bridge, I have a question, I ask, get answered instantly. What's important on Glass is that you allow the user to stay in the physical world while still taking these short, small dips in the digital world and continue through the rest of their day. Voice first. Now this is really important because unlike other devices where voice may be just one of the ways the user interact with it, on Glass, voice is critical. It is also a fast and a natural way to interact. As a Glassware developer, you will have an opportunity to provide some voice commands. When you are doing such a thing, think about what are the actions your users are going to take to invoke your glassware. Something like, OK glass, take a picture is a great command. OK glass, start a camera, not so much. Just like any other wearable device, speed truly matters. If you can deliver amazing experiences in less than 5 seconds, they're just going to become perfect. If you have a feature-rich mobile or a web application, think about what are the specific nuggets of amazing experiences you can provide on glass. And then you can use voice or one-tap actions for users to access those. If you can reduce the amount of time between an intent that the user has and the action they need to take to fulfill that intent, you will be able to create brilliant glasswares. Keep things relevant. Now, on glass, you want to deliver experiences which are relevant right down to the moment users interacting with them. If I have a glassware which lists all of my shopping list and I walk into a grocery store, show me only the part of the shopping list which I can purchase in the grocery store. Something which I'm going to order online just doesn't belong on glass at that moment. Understand the context like a location, time of day of the week, even my personal preferences. Combine all of these to create some amazing experiences. The display of the glass sits so close to the user's eyes that you have a unique opportunity to create glassware which orient to the view that the user is having of the world. Now, it's important that when you are creating these experiences that you update the view the moment user is turning their head. Now, that's how you create good experiences. What makes these experiences even better are if you can use either voice or head gestures to free up the hands so that the users can interact with the world around them. Let's summarize what are the experiences which work great on glass. Those who keep the user in the moment. Those who use voice for quick and natural interactions. Make sure that experiences are delivering the right amount of information at just the right time. They orient to the view of the world around me. And finally, free up my hand so that I can interact with the world around me. In the next section, let's take a look at some of the recommendations on how to create some great experiences. Let's start with typography. On glass, the default system font is Roboto. We use two weights of this font, thin and light. When you look at all the templates, 40 pixel is the font size we use, almost as a regular or normal font size. You can increase it to 50, something like large, or 70 pixel, like an extra large font size. Anything larger than this may not give you enough space on glass to write full sentences. However, you may be able to use larger font sizes for very specific pieces of information, for example, temperature or sports score. Let's take a look at the other end of the spectrum. If you go down to 34 pixel font size, think of it as small. 30 pixel, extra small. Anything smaller than this in the body text, it's just not going to be legible for your user. So stay away from those sizes. Let's look at a very important facet of designing really good and legible glassware. Padding. You notice that all of our templates will have 40 pixel padding on all sides. Now this is important so that the content that you're putting in front of the user doesn't get clipped on the left or the right side. Similarly, this will allow some of the system UIs like scroll bar or a progress bar to easily occupy this 40 pixel space without interacting with the content that you're presenting to the user. The closer you can present the content to the center of the screen, the easier it will be for a user to focus on it. Let's take a look at some of the core templates that we provide. This is a basic template, really good for putting in a lot of text, which is still digestible on glass. One important thing that you will notice on all the templates is there is a space provided to put in metadata. Now this metadata allows the user to understand who is providing this content and also what is the context in which this content is being provided. Another template, we call it author. This is great for both providing who is the sender as well as the subject line, of course, in addition to the body of the message. There are tons of other templates which you can find at our developer website. They deal with things like lists, full bleed images, etc. Glanceable UIs. Now this is an important part. Glass is a device which is designed from grounds up to be used out and about. When you are presenting the user an information which is divided up into lots of small chunks, really start thinking that can you actually split this information across a couple of different screens? Can you reduce this information into something which is much more easily digestible? So for example, if I change this screen to something like this, all of a sudden it is much more easy for me to read this information even when I'm jogging. If you are able to reduce the number of chunks down to just one without diminishing the value of information, you may actually have a truly great glassware. Low density, high quality. Now, you may have created some great experiences on mobile and web using responsive design. If you want to scale down those designs on glass and expect that those experiences are going to work, you may not actually have that much luck. If you want to create experience on glass, think about creating them from grounds up. There are certain experiences which work especially beautiful, especially nice on glass. Things like full bleed images. Again, make use of the space provided for metadata to make sure that the user is understanding what is the context in which this image is being provided to them. The last point here, and this is really important, when you are creating experiences on glass, make sure that you are testing it both indoors and outdoors. Now it is important because some colors may look different on glass compared to how they look on your computer monitor. This happens because glass is a transparent display. A color like black may actually be just transparent. White may actually provide you with the maximum amount of contrast to improve the legibility of your text. Make sure that you are truly testing all of your UIs both indoors and outdoors. Let's recap some of the recommendations we talked about. Use proper typography. If you have your own brand related fonts, use them, but make sure that they are following the guidelines we talked about. Similarly, make sure that you are using the standard templates or at least using them as guidelines to create really rich, nice, legible content on glass. Make sure that the content you are presenting to your user is in small bite-sized chunks that they can easily digest. And lastly, make sure that every single interface you are creating on glass, you test both indoors and outdoors. As you go about creating some amazing glassware, think about what can you do on glass which can be done better on glass than any other device. At the same time, think about some of the things we talked about in this talk. Create the content which is relevant right down to the moment. Use voice for fast and natural interactions. Work with some of the standard patterns and styles to create truly useful glassware. And finally, the better you can do these things together, the better the experience for your users is going to be. We have some amazing documentation on our developer website, which you can take a look. At the same time, make sure that you continue exploring more and more ways in which you can create amazing experiences for your users. Thank you very much.
Hi, I'm Chris, and I work at the developer relations team at Google.
Good morning. Thank you all for joining us today. We'll just start with a couple of introductions and then dive right into the material. So I'm Rich Fulcher.
I'm Dave Chu.
I'm Zach Gibson.
And I'm Bethany Fong.
And we're all designers working from across Google, from Android to Chrome, concentrating on bringing material design to Google's apps. And we're just kind of personally, we're really thrilled to be here this morning to really get to show off this work that we've been working on for quite a while now, so thanks for coming. Yesterday's keynote introduced material design, which is a new visual language focused on creating bold, graphic interfaces. It takes the principles of typography, position, scale, and color, and uses those to build really wonderful interfaces. Material design combines these classic print design principles with the kind of innovation that you can achieve through the application of technology. It takes elements that were formerly static and makes them reactive and responsive. It receives energy from the user's finger, from their mouse click, and it directs that energy to power transformation and animation of the material itself. Material design is also one adaptive design. So it's a single design system that covers handheld and web devices. It covers a variety of different form factors. Now, this is important because it enables the user to leverage the mastery they gain in one context and apply it to another to get that sense of intuitiveness that comes from being able to do that. In this session, we're going to discuss how material design affects the way you design the interaction of your applications. We're going to cover three major topics today. We're going to start by talking about the materials themselves and the properties of those materials that guide how you use them. That will lead into a discussion of structure, which will cover both kind of the level of how do I structure individual scenes or views within my application, and then up to how do I structure my entire app. And finally, we'll end by looking at some of the standard components that are kind of novel for material design and go into a bit of detail about how you can apply them that are particularly important. So since material is the metaphor that powers this entire system, let's start by talking about two of the fundamental ones, paper and ink.
In material design, every pixel drawn by an app is a dot of ink on a piece of paper. Paper is on its own colorless. Ink can be any color. Each piece of paper wants to be a simple shape with rounded corners, a rectangle, a square, or a circle, which is, after all, just a square with extremely rounded corners. Paper does not want to be a star or a triangle or the shape of your app icon. Ink is much less restricted. It can flow into any shape. Measured in the x and y axes, both paper and ink can have any size. Paper can fill the entire display such that you can't see the edges, or it can be the size of a single button. The size of ink is limited only by its need to stay on paper. But paper has an absolute fixed thickness equal to 1 dip, or density-independent pixel. Now, why is that important? Because we must now consider the z-axis when laying out content. As a quick refresher, the z-axis is perpendicular to both the x and y axes, allowing us to position surfaces in front of or behind other surfaces. Paper surfaces are intuitive and natural, but to maintain that materiality, we layer and move them in ways that could plausibly fit within these devices. This means we constrain paper's behavior based on the perceived z-depth of the device. So for a phone, that's the distance between your thumb on the screen to the back of the phone against the palm of your hand. Monitors and televisions support perceived z-depth greater than their physical dimensions, in part because we don't physically handle the devices. The position of a piece of paper gives the user hints about how it relates to other paper. The dimensionality invites interaction. When the user sees a realistic shadow, they think there is a gap, we call it a step, between two pieces of paper, and they will behave and move independently. When there is no shadow between two coplanar pieces of paper, the edge they share is instead a seam, and the movement of those pieces of paper will be linked together. Paper always occupies a single z position. It is always flat, never tilted so that one edge is closer than another to the user, and it does not flip over to show the other side. The z position of paper is also a reflection of content hierarchy. Paper with a z position closer to the user typically contains content you want the user to focus on, such as a dialog box, or when you select a date in a calendar and it expands and moves forward from the grid. Paper with a z position that's higher also tends to affect underlying content. An obvious example is the navigation drawer, which appears above everything else because it changes the displayed content. App bars are another obvious example. With material design, rather than thinking of depth as ornament, so adding a few drop shadows here and there and calling it a day, use depth to help users understand how your app works, how content is organized, and the scope of actions. So let's talk about layout. How do we take all the possibilities of this system and present them in a coherent and consistent fashion?
In all of our material design layouts, we strive for consistency, a cohesive experience across all of our apps. This starts with the fundamental structure of how we build our applications and layouts. The history of graphic design has given us tools like keylines, baseline grids, aspect ratios, and the use of incremental spatial relationships in our designs. These tools are the building blocks that we use and we need to create consistency in our designs across mobile, tablet, and desktop. Historically, the best graphic design work has come from a deep understanding of a grid structure, so that when it's used to its full potential, or even when something breaks this grid structure, it can be done in exciting and innovative and delightful ways. So there's a visual design talk that's happening later today, and it's going to cover a bit more details about the grid structure. But for this presentation, it's just important to note that our grid system is based on an 8-dip increment. So it's nothing new, really. If you've been working for the web, these are very familiar and friendly numbers. You'll find that our headers, icons, paper elements, padding, margins, buttons, et cetera, are all numbers like 16, 24, 32, 96, 960, 1024, you get the idea. They're all familiar and friendly numbers to us. We're just baking this into the system for the sake of consistency and visual harmony across all of our screens. So with our grid now in place, I think we're ready to start designing some apps.
OK, so how do the properties of paper and ink affect the way that you actually structure your app? So when you construct any particular screen, we've found it best to start from paper. That's the material that's really going to define the architecture of any scene or view that you're going to construct. And it's going to call out what elements kind of are surfaced above or below or can move independently. You can always come back and do ink as kind of a second pass. You've got your paper laid out, then you can fill in, as you would just kind of draw it in, all of the controls, all of the content as a later action. We spent a lot of time actually cutting out pieces of paper and layering them and moving them until we came up within the system with views that made sense. I really got to hone my scissor and glue skills working on this project. We even use things like little wooden discs here to track the floating action button, which is a highlight component within material design that Bethany will go into more detail about in just a couple of minutes. So playing with paper is a great practice for just getting a sense of how this design system works. It really gives you a feel for how the surfaces will interact with each other when they kind of approach each other. Does one lift to get out of the way of the other? Do they move together as a group? And just kind of shuffling the paper around physically helps you just very quickly get an understanding of that. It's a really fast, really cheap, even kind of fun way of designing. So when we're talking about just the structural possibilities for your app at the high level, all of the possibilities that you're used to seeing are still there. If your app wants to use tabs, that's great. We support that, no worries. If you occasionally indulge in using a left side navigation drawer, that's covered too, that pattern's there. If your app is all about search, we like search too, that's a pattern that you can support as well. As a designer or developer of your application, you are responsible for picking the most appropriate pattern that's going to best serve your users and their goals. So be sure to consider all the possibilities. Now, each of those will have its own set of advantages and disadvantages. I'll pick on the left navigation drawer for just a moment here. And this is a really suitable pattern if you have a large number of high-level views. It becomes effectively this very convenient table of contents to your application that the user can quickly access and scan and jump to a section. It can also be really valuable if your app has kind of deep paths through its hierarchy where the user can go down, down, down to deeper levels, because they can use the drawer as a rapid mechanism for kind of pivoting back and going to a different top level without having to go up, up, up first to do that. On the other hand, there are drawbacks to the drawer. It's clearly not as obvious as something like tabs, which are immediately visible on the screen all of the time. It also may not be ideal if the contents of the drawer are heterogeneous, if it's not kind of a standard list of categories or labels, because in that case, the user is going to need to spend a little bit more time using your app to familiarize themselves with what the content of that drawer is, because they're not seeing it all the time. On the other hand, that could be valuable if you're trying to demote some of that content. If those are less frequently visited destinations that you kind of want to politely steer the user away from, but make accessible in certain situations. So as every designer always says, it depends.
So the previous examples that Rich showed, and a lot of the screens that we've been looking at are all mobile, but the basic structure of our applications applies to mobile, tablet, and desktop layouts. The tools that we have at our disposal are all here. There's an app bar, there's a canvas area with a floating action button, there's an occasional bottom bar, and side navs that can be accessed temporarily. From a structural standpoint, we keep this stuff around no matter what the screen size is. So as we move up into tablet, the app bar can absorb elements that couldn't fit into the mobile screens, and the side nav bars can still be accessed temporarily as they were a mobile, or they can be pinned. Additionally, in our desktop structure, the side nav bar as well as content canvas area can have secondary toolbars for things like tabs or palettes or just secondary actions. As you'll notice in material design, these structural elements are all extremely flexible. They can move and react to screen sizes and different contexts in magical ways. So let's take a look at some of the family shots that we have to see what's happening. In this example of a file browser, you can see a lot of the stuff that we talked about in action. The header is extended based on a default height of the app bar. And this is really just to create a little bit of visual hierarchy in the layout for the tiles and the list. As you can see on the desktop screen here, the right nav is pinned while browsing. In the mobile screen here, we add intentional negative space between the line items just to separate the items with something other than a rule. And a similar app structure is maintained throughout our layouts. And you can see that here by the left nav being opened. Our responsive solutions combine fixed, fluid, and sticky elements that should be able to adapt to the way that people use their devices. You can see that here by the mobile screen. The density of information that's being shown relates to the amount of information that people want to interact with on their phone. On tablet, we can add illustrations, we can add photographs to make a more immersive and playful experience. And then when the screen grows, we can add intentional negative space, again, to separate content areas. The toolbar that's being shown here is also extremely flexible. It can rest on a background, it can be transparent over an image, or it can fit within any defined space. Our designs show a lot of variations in the toolbars to make them generally more useful and flexible. Sometimes we extend the top bar just to add a splash of color to our screens. We can use cards to keep text line lengths at digestible sizes when the screen gets bigger. Primary content can be higher in Z-depth or closer to the glass. In this contact screen, you can see that a left nav also might be pinned and scroll under the toolbar, while primary content in a card might scroll over the toolbar. You can also see here that what was full width on a mobile screen is now a floating card or a floating surface on desktop. You can also see one of our designers. In this music example, we're using a bottom bar for the player. We're using large photographs in the background and dynamic color choices. We're also using a floating action button, this little blue play button in some of the screens here, just to add a pop of color to the screen. Bethany's going to talk a little bit more about that. There's a lot of structural nuance that's happening in this screen. Our toolbars can have all types of content in them, from photographs to input fields. And we can use typographic scale by having dynamic type. Menus that generate from toolbars, they can come above other elements in Z-depth. And this plays into our story of real materials in real space that can do magical things. And not all of our toolbars are pinned to the top in a colored bar. They can be associated with a surface that's currently in focus. So if you imagine this toolbar here associated with this list view, when it scrolls down, that toolbar might come with it. So how does all of this content move? There's going to be a lot more details covered in the motion talk that's happening later today. But let's talk a little bit about scrolling. This is a common scrolling pattern that's happening here, right? Content moves up, the app bar scrolls off, and the status bar picks up a little bit of the color of the application and sticks around, which is something new with Material. Also, when a user scrolls back here, the toolbar can come back at a little bit of a different pace than the content. In this example, you can see how we think of the top toolbar in blocks. There's one block that contains the search field and another that contains tabs. On scroll, these are handled independently. So here we're pushing off the top search bar and keeping the tabs. And this is dependent on the context of the application. You can also see that on the slightest downward pull, the search bar comes back, right? This is where things get really exciting, right? We can have photographs that morph into colored bars in our toolbars. We can have a dynamic UI that removes itself from the screen in different ways. Our typography can scale and move. Scrolling and the way that things move is very much dependent on content and the context and the containers that hold our content. So with that in mind, Dave's going to talk more about components.
So now that we've covered Material and how it's structured, let's take a closer look at some of the bits and pieces that make up an interface and some of the best practices for implementing them. At a high level, one key thing you typically want to do is organize information to help your users make decisions. We support the expected forms of content organization, lists, grids, and now formally cards. Lists and grids are familiar and well understood. Lists are great for text, and grids are great for images. But the question of why and when to use cards has been a point of some uncertainty in the past. So here's some more concrete guidelines. Cards are great for displaying a set of data with different content types. Google Now is a perfect example. Stock quotes, weather, directions, World Cup scores. As a little aside here, any spontaneous booing or cheering during our talk will not be taken personally. Each card can have a dramatically different presentation, so making them separate pieces of paper makes sense. Cards are malleable and can easily handle data sets where content varies in length from item to item. In comparison, lists and grids have a natural bias towards regularity, making them best for consistently structured data. Each card can contain a heterogeneous mix of media, text, controls, and actions related to a single subject. Cards give you the flexibility to combine and create complex compositions of content and actions, such as +1 buttons, sliders, and comments in a way that lists and grids aren't simply designed to handle. But just because you can use cards does not mean you should use them. When deciding between lists, grids, or cards, first ask yourself, how can I best support my users' goals? Are they trying to find a specific thing, like a photo or a file? Grids and lists have a consistent rhythm and composition that makes them easy to scan and well-suited for quick comparison. In contrast, cards are harder to scan through because of their irregular cadence, but they are great for browsing diverse content and layouts. As these examples show, adding more pieces of paper, more ink, and more shadows to the screen increases noise and distraction without increasing clarity. Remember, you can always split an item into its own piece of paper the instant it's needed. So that's a brief overview of containers and some guidelines around when to use each type. Bethany will now cover more of the components and best practices to use when building material design interfaces.
So we looked at all of the standard UI elements like buttons, text fields, and switches from a material design perspective so that they too will help you create one adaptive design for your app. And these goals of moderating complexity and of reacting appropriately extend into all of our elements. Our controls are designed to be consistent with the larger visual story. We use simple geometric shapes to build more complex but still cohesive components. And by building with paper and ink, our components have an enhanced ability to react to the user. For example, as elements come into focus, they become alive, hinting at what's to come by ebbing and flowing between the rest and the press state through diffusing ink and traveling through the Z-space. Element states have been simplified to help as you design across form factors. All of the element states are coordinated so that the same element will function correctly in a design that is being used with different input methods. You can see that each input method works nicely with the others without having to duplicate your control states. And as you create custom controls for your own app, you may want to follow a similar approach for quicker adaptability. I'm going to talk in more detail about buttons. There are 3 styles of buttons, and each is appropriate for different circumstances. The floating action button is known by its shorthand, the fab. The fab is the newest and has the most unique characteristics, while the others are more familiar. Both the fab and the raised buttons are made of paper in material design, and the flat button is made of ink. This pyramid illustrates the frequency of use of different button styles. The fab is the strongest in the visual hierarchy and is most rarely used. It's special. The raised button is used more commonly, but still sparingly. It's quite visible, but because it doesn't float, means it doesn't respond to Z-space changes in the same way that the fab does. And finally, there's the flat button, a very commonly used control. So I heard in the session yesterday there's a really good question that was basically, what are all the circles on the screen? And here it is. It's the fab. So it represents the single hallmark action for a screen. It's a tool for you to call out the key parts of your app's product story. It should be used for actions that are strongly characteristic of your app. Pausing or resuming playback tells me that this is a music app, or driving directions tells me that this is a maps app. Not every screen should use a fab because not every screen has an action with this importance or doesn't really have the right type of data. It's a natural cue for telling users what to do next also. So in user research, we found that users understood it as a wayfinding tool. Research showed that when faced with an onslaught of unfamiliar screens, as many users do on a regular basis, like when they install your app for the first time, they started using the fab to navigate. And users discovered that it was really useful as a signpost of what's important. And here the fab is being used in a variety of different types of apps. You can see how it highlights a hallmark action for each app. Compose for a messaging app, Add Files for a storage app, and so on. And you probably noticed that it can be placed around the screen. And we have a few recommended places that work pretty well, like in the lower right-hand corner. The fab is also the first element that is allowed to straddle a seam or allowed to hang over a paper edge, such as in the screen for people. And also note that there's only one fab per screen. There should never be multiple on screen at one time, as that confuses our visual hierarchy goal. You can use your app's accent color for your fab. Just make sure that you retain adequate contrast from the background. Because the fab is characterful, it's generally a positive action, like create, favorite, share, navigate, explore, and so on. And unless it's truly the hallmark of an app, fab shouldn't be destructive actions like archive or trash. They also shouldn't be unspecific or alerts, limited actions like cutting and pasting text, or stuff that should really be in a toolbar like changing the volume. Basically, the function should be an action that makes a user feel really positive about using the fab and never worried it's going to do something wrong. So it's not just a round button. It has some transformative properties that you'll be able to use to help ease your users from screen to screen. It can expand, morph, and react. The fab can replace itself with a sequence of more specific sub-actions. This helps surface a set that don't really belong at the top, but are still important. And you can design them to be contextual to your users. Imagine a user tapping the fab and their favorite people expanding out as contacts. And these do need to be tightly related actions, as well as ones which can be understood through the simple initial icon. So for example, if an add fab hides a search function, users won't naturally think to look there for search. And lastly, don't turn your fab into an action overflow. Those still belong in the app bar. So because the fab is made of floating paper, it can morph into a new surface that allows for richer interactions. For example, you can have a new post fab, which enlarges directly into a composition field or into an open camera viewfinder. It's not just a fancier drop-down menu. You're making your hero action even more heroic and reinforcing the sense that this is a core usage of your app. As you recall, fabs can be positioned along steps or seams of paper. And as that paper moves, the fab can transfer its anchor point. Reactions can be simple, as shifting a fab's position in response to other paper moving, like in Zach's example. Or as a user scrolls down a page, the fab can hop locations from seam to seam, or even off to a floating position so that users don't lose sight of that important fab function. So with that, you should have a picture of what the new material design elements are like and what the fab can do for your app.
So we've covered kind of the basics of material design, how the materials behave. We talked about layout. We've talked about structure. We highlighted a couple of key components. But as developers and designers who already have apps, the question on your mind is probably, what's next? How do I take these material design principles, this new system, and apply it to my apps? The good news is we haven't thrown out anything you already know. So all of the components that you're used to using, they're still there, they're still supported. We've given them a little bit of a refresh to make them more reactive, more alive. But they're still there, and you can still count on them. As announced yesterday, there is a preview release of our new UI guidelines available at www.google.com/design. And this covers all of the standard components that we didn't kind of address today that haven't changed. So you can see all of those elements. You can get all the updated guidance on those. It's also packed with examples. So you may see kind of in those examples something that inspires you to think about the design of your app or part of your app in a slightly different way. Here's a screenshot from the spec covering the layout chapter, just kind of showing a few wireframes, and it kind of clearly shows the application of the 8-dip grid that Zach talked about, and you can see some of the key lines called out. All of these guides have been responsively designed so that they'll work well on desktop, on tablet, on phone. You can check them on any of the devices that you're designing for. I wouldn't read them on your new fancy Android Wear. But everything else we've got covered. So this site will continue to evolve as our frameworks update. There are also a lot of really helpful resources, particularly for interaction designers on this site. So we offer a bunch of layout templates for the standard views. We have sticker sheets of all of the component types. And if you're thinking Android, they're in light and dark theme available there. And then there are also color palettes, icon sets, advice for animation, lots and lots of content there. But we'd like to leave you with a challenge. And that is to think about not just how you can make your app more attractive, more delightful by applying material design to it, but how can you use these principles to actually make your app easier to use? And one way to start on that is to question some of the design decisions you may have already made. So let's start with the biggest one, the question of how do I structure my application? We talked about structuring based on hierarchy in this talk. But another way of thinking about it might be to structure based on motion, kind of planning for all the different surfaces that you want to have moving between the different views within your application. And what are those elements that should be lifted up, that are important, that want to get that signature treatment? Motion provides meaning to the user. It is a form of feedback which focuses the user's attention, and it builds a sense of continuity between different states within your application. So relatedly, how do you move to a model that is, it's kind of the old model we've been building in is this kind of screen, screen, screen style of design, where I start at the top of my app, and then I build all the intermediary screens till I get to the bottom of the app, and we just kind of realize those one at a time. We can do something much more fluid now. We can use transitions to give the user the sense that they can do more work in fewer places within the app by just kind of transforming the context slightly for them. So we can use animation to guide the user here, rather than just dropping them into some new context where they have to reorient themselves after they've landed from the teleport. You can guide them more easily, build up more that sense of direction and connection between these different conditions. And think about what you would do for the fab if it's appropriate for your screen. What is that hallmark application or that hallmark action that you'd want affiliated with your application? Or think of it this way. What's that action that you want to clearly show in the screenshot promoting your app that shows up in the detail page of a store listing? And what's the thing anybody looking at that should take away and say, oh, this app does this? And in general, how can you lean into the frameworks more? Are there things that you're doing currently in a custom way that no longer need to be custom, that can take advantage of some of the new APIs that are present? Can you make your code base faster, smaller, easier to maintain by relying on the framework more? There are 3 more excellent sessions today covering different aspects of material design. There's one starting at the top of the hour, and then later today we have sessions specifically on visual design and on motion design. We also have the sandbox space. If you've come by there, you've seen the new UI guidelines projected on giant touchscreens. We'll have a couple of small, short talks there. I'll give a talk at 2 o'clock on a little bit more detail about using paper and ink and how those work. But all of the designers here, as well as others, will be in that space. It's a really great opportunity to ask any questions you might have and just to come by and say hi. We're happy to meet you. And with that, thank you very much for your interest and for your attention today. And we'll happily take some few questions in the time that remains.
Hello, I'm Akil from University of Maryland, and I just had a question about the navigation drawer. What were the reasons behind moving the hamburger icon from the halfway beyond the edge to into the screen?
Okay, I think this question maybe relates most to Android. So kind of formally in Android, you'd have the application icon and then kind of a hint of the drawer indicator icon beside it. Part of Material has moved away from using the app icon as kind of the visual identifier of where you are. And we try to encourage developers to express the app's identity more through kind of those standards of color and typography and treatment to kind of make each view more characterful and more immediately recognizable. So as we moved away from using the application icon, we wanted to give a full width affordance in that space for opening the drawer.
Thank you.
Sure.
Hi. This is essentially paper, but I haven't seen any folding. Is there any specific reason for that?
So one of the things I talked about was this notion of perceived z-depth. And so when you're handling a phone, you have the sense of the thickness of that between the glass and the back of the phone. So we want to preserve the notion that there's a finite amount of space to use. And so if you start folding things, then that would sort of break the plane. That's something potentially you could explore maybe on deeper z-depth environments like televisions when you start thinking about 3 dimensions. But for now, we're really focusing on keeping things in a single z position and sort of moving things laterally.
OK, makes sense. Thanks.
Hi. So mainly I wanted to ask about, for one, backwards compatibility to getting these new patterns into, like if as far back as like gingerbread, is that possible? And then also for low-end devices with all these new animations, what are things that, like, is it just better not to use those, or what are good guidelines?
Sure. I think kind of my take on the best practice is you want to kind of design for material design first and foremost. We found that the translation exercise of taking something that's designed for material and kind of simplifying it downward has been a reasonably straightforward one. I mean, most of the same elements are still there. You still have things like action bars and toolbars. You can make them less transformative as the design kind of goes down to earlier versions. And some of these changes will actually be supported through the support library as well. So I think you kind of start with the highest end, you simplify to pare it down, and then you still have a design that feels very coherent. Material has a unique theme on Android, so you can target that theme and build against it, and you can kind of see what happens on that right away. The second part of your question was, sorry, just remind me quickly.
Low-end devices.
Low-end devices, yes. So the animation framework will actually be aware of kind of the capabilities. It will basically shorten or remove animations in some cases to make sure that instead of just getting like a very janky or stuttery animation, you just sometimes just get a clean cut or crossfade instead of more elaborate one. So it's not as full of an experience, but it still feels kind of complete for that device.
Okay, thanks.
Sure.
Hi, I have the skeuomorphism question.
Okay.
Wondering how that went internally, and do you guys consider this skeuomorph?
So skeuomorphism. So that's the notion of sort of introducing really kind of like ornament and unnecessary elements into design. And I would say that in this case, we're trying to use paper as an inspiration, but it's an interesting question because I guess the most amount of skeuomorphism that you could potentially call skeuomorphism is effectively shadowing, because effectively they're just pieces of paper that are moving about. There's no additional ornament beyond it's a blank piece of paper that you're adding ink to. The idea there is that we're trying to add additional affordances so people can more intelligently understand sort of what's going on. There's conversations if you're in the design world talking about flat design and post-flat design. Arguably, this is kind of post-flat design because we're trying to take the direction of flat design, which is kind of the answer or the response to skeuomorphism. That's at sort of one extreme end of the spectrum. We're trying to pull it back and say that we do kind of need to introduce a little bit more affordance here and give people, users, guidance as to like how things work, how they relate to each other, what to expect.
Yeah, just to add to that, I think we're at a place that's kind of in between the flat and skeuomorphism. There's a lot of our stuff is flat on first appearance, but it's tangible and you can touch it. And when you do touch it and interact with it, it feels real. And I think that's a kind of place that's in between pure flat design and skeuomorphic stuff.
Cool.
Yeah.
Thank you.
Yeah.
Sure.
Hi. You'll have to forgive me if this is a basic design question because I'm a developer, but you mentioned that it's important to have the fab's primary color work well with the image content behind it. I'm just wondering if there's sort of a way that you determine what that is dynamically based on the content, and if so, is that available in Polymer and Android?
Yeah, The library is called palette. It is a way of extracting the dominant color value from an image and then using that to select the complementary color that's appropriate. I think there are a few cases where the fab would want to do that. I think the fab in particular often wants to be kind of a known fixed color for just kind of easy identifiability kind of within your app. That said, there are a couple of contexts where it makes sense to do that, but it is supported, and palette is the name of that library.
Thank you.
Sure.
Hi. Fab definitely stands out for me in this talk, and I think through the whole conference, designing for cross-platform is one of the main themes this year. So I'm just wondering, any thoughts on how to apply Fab in TV space, like in a TV UI? Because for most of TV, remote doesn't have a touch screen, and it still operates on D-pad. So I'm just wondering, any thoughts on that?
Yeah, so the Fab is a raised button, which still has a focus state, and I know that a lot of our TV UI relies on moving the focus state around the screen. And in a lot of our apps on Android TV, we've actually used the Fab very successfully using focus to pull it out. So it still works.
Okay, thanks.
Hi, my question is kind of related. So I love what you've done to, I guess, facilitate design cross-platform. So I'm wondering if you're working on a product that is still primarily desktop and might, it's still kind of becoming responsive, but it's still desktop. Do you feel like some of these things, like the new animations or the metaphors of paper and ink, is that still appropriate for a primarily desktop application, or does it require interaction via touch?
Yeah, I think it's still appropriate. A lot of the Polymer stuff that we've been working on implements some of these touch ripples and animations, and you can kind of get some of that stuff for free by using Polymer elements in desktop. But I think it totally still applies, and there's definitely, on mobile there's no hover states, and there's definitely differences, and I think we're trying to respect those differences in the different form factors, but just from a structural standpoint, keeping all of the same stuff around is how we're keeping consistent across form factors.
And as Bethany and I both sort of discussed the notion of the Fab transforming and also just paper hierarchy, I mean, some of those things still apply to desktop, so you can start talking about how the Fab transforms into new paper, and that helps cue users that there's a new activity or a new action being, when you're composing a new email or a note or something, that can turn into a new piece of paper and helps give them some sense of relationship with that new surface with the work that they've been previously doing.
Have you found that users, that their relationship with the mouse in the screen is kind of similar with the relationship to just clicking on a screen? Have you kind of explored that?
There's a bit more difference. I mean, I don't think any of us are too close to that work specifically, but I know from the development of the Pixel that kind of users sometimes move between those modes of engagement. Like when a touchscreen is available, that's appropriate for some kind of lighter browsing-oriented activities. But kind of for the more precise targeting and more kind of work active, I'm alternating between keyboard and mouse. They tend to bias towards that affordance.
Okay, thank you.
Sure.
No, not me.
All right. Well, thank you all again.
Thank you.
Thanks.
Learning to develop on Android is much more than learning APIs or shortcuts. It's training your brain to think like a mobile developer. Android Fundamentals, developed with Google, tells the story of Android's history while you build a real app, exposing you to current APIs and battlefield experience that will help you think and code like a seasoned Android developer. For more information, visit udacity.com/Google.
Would you like to learn more about kiosk apps? I'm Vidya, and I'll help you explore what kiosk apps can do and how you can build them. Hang on tight and enjoy the ride. Unleash the power of kiosk apps with me. First, let's see some single-purpose devices in action. Although you might not even realize it, these devices are all around you. Here is a restaurant cafe with an interactive display showing the menu and specials for the day. A customer can walk up to the display and scan the QR code for a chance to win a meal. You might also find a device at a doctor's office where patients check in and wait their turn. Many grocery stores now support self-serve point-of-sale kiosks where customers can scan items and pay for them. Self-serve kiosks are also appearing at movie theaters where guests can purchase tickets. An innovative application is an integrated library catalog and Wayfinder kiosk showing the map of the library building. A guest can browse the collection, determine if a book is available, and locate the section that contains the book. These devices are also used in educational environments. Here is a 5th grade class where students are taking online tests in a lockdown secured environment. All of the single-purpose use cases you just saw could be powered by kiosk apps running on Chromeboxes. The possibilities are limitless. Gaming consoles, photo booths, displays in public transportation, billboards, ATM machines, all of this can be powered by kiosk apps. Did you know that the displays and registration kiosks at Google I/O have also been powered by kiosk apps on Chromeboxes? You may ask, why would a Chromebox be the best choice to run a kiosk? Well, there are many reasons. Chromeboxes are fast and secure. You no longer have to worry about OS patches or install antivirus software. OS updates are taken care of automatically for you. Further, the OS and the kiosk app running on it have independent update cycles. So as an app developer, you only have to update your app and Chrome OS keeps the rest fresh. And with the Chrome Management Console, you can easily deploy and remotely manage a fleet of Chromeboxes that may be distributed around the world. A kiosk app is just a Chrome app with HTML, CSS, and JavaScript. You can build powerful apps that interact with network and hardware devices, media tools, and much more. You can enhance the user experience through touch with virtual keyboard support and by listening for mouse and touch events. For example, you can build a point-of-sale kiosk app that uses the Chrome USB API to communicate with USB devices like barcode scanners, credit card readers, and printers. You can also use the Bluetooth API to talk to Bluetooth devices. However, there are indeed some differences between kiosk and regular Chrome apps. Now consider the display at an airport terminal using an interactive kiosk app. The app is set to auto-launch when the Chromebox first boots up and always runs in full screen, providing a dedicated user experience. Here, I check on the status of the flight from Minneapolis on one of the displays and click on Southwest Flight SWA 3236 for more information. The app updates the flight tracker with the route map of that flight. I realize that the flight has been delayed and want to get something to eat. I can scan the QR code on the display and grab the flight information for me to look at on my phone while I'm in transit. I now click on Dining, which brings up a map with the nearest places to eat along with restaurant ratings. I decide to go to Fresh Roll Vietnamese as it's got the best ratings and is close by. Google Maps gives me directions to help me get to the restaurant. As a bonus, I can also redeem a coupon for a combo meal if I scan the QR code on the display with my phone. I can also click on Weather, get the 5-day local weather forecast, and get some fast facts about the airport. It's interesting that there were 31,000 check-ins today. Lots of travel indeed. You might have noticed that when this app is running, the user cannot exit the app or switch to another task. However, the app could offer a logout button that allows the user to close all windows and terminate the session. To convert a Chrome app into a kiosk app, all you need to do is add the attributes kiosk enabled and kiosk only to the manifest.json file to ensure that the app will only run in full screen using single app kiosk mode. After writing a kiosk app, you can publish it to the Chrome Web Store. You can either monetize the app or just use the app in-house. You can also test the app in single app kiosk mode by firing up a browser and add the kiosk app at the Chrome extensions page. Installed kiosk apps will now appear in the tray under Apps in the login screen. You can then manually launch the app from the tray and test the app. As an app developer, you can choose to download and cache any assets you need, so that the next time your user launches the app, the cached assets are available immediately, even when offline. The Chrome Management Console can then be used to deploy an app to a fleet of Chromeboxes. There is also an option to automatically launch the app on the Chromebox when the device first boots up. We're excited to see what kind of apps you will build. You can take it for a spin today by going to the links here. There are sample kiosk apps that you can play with. Let us know what you think, and thanks for watching.
So let's say that you got some awesome Android game with hundreds of thousands of downloads, but it seems like you can't break that million user mark. The reason? Users are unhappy with your game's performance. You see, users notice bad performance before any other feature in your game, before your item stats or your UI interfaces, or how in level 3 one of your characters is actually speaking Klingon. And guess what? Users unhappy with performance give bad reviews at a higher percentage than any other problem in your game. So you want to break the million user mark? You're going to have to fix the perf problems in your game. And for modern Android games, that starts with understanding that there exists a delicate dance, a tango, if you will, of interaction between the CPU and GPU in your game that can have a drastic impact on your performance. And the dance works a little something like this. Modern graphics APIs don't allow the CPU to talk directly to the GPU hardware. Instead, it uses an intermediate process known as a graphics driver to handle communication between the two. Drawing calls from the CPU are cached by the driver in a message queue, and when the GPU hardware is ready for work, it will start consuming commands from the same resource and begin executing on them. The existence of the message queue process in the driver means the CPU can be pushing messages into the driver at a different rate than the GPU is reading from it. And as such, your GPU can be consuming, processing, and drawing data that's around 1 to 2 frames behind the CPU. Now, while alarming, don't worry, this is actually really typical of modern hardware architectures. But with this in mind, understand that hitting 60 frames a second in your game requires both your CPU frame and your GPU frame to both complete their work in around 16 milliseconds. When either of these two systems starts to go out of sync and take longer than that, bad things happen to your frame rate. For example, what if your GPU has more work to do than your CPU? This means that your CPU is going to be submitting frames into the driver at a faster frequency than the GPU is actually going to be consuming them. Eventually, the driver queue is going to get filled, and anytime the CPU wants to submit a driver call, it'll have to block, wait for the GPU to clear up some commands in order to free up space, at which point the CPU can then carry on and submit its new commands. On the other hand, if you're CPU bound, then you're inserting bubbles into your GPU pipeline. Every time the CPU submits a frame, the GPU will consume it immediately, process it, and sit around waiting for the next frame where it can do work again. The straightforward way to fix this is to simply do less work on the CPU. But in this case, it may be that the GPU simply doesn't have enough work to do, and the correct action is actually to give it more work in order to fully maximize the GPU throughput. There's a great opportunity to put like 200 extra zombies on the screen for your designers. You can get a general estimate of where the problem lies by taking a good look at your CPU frame time for a couple seconds of simulation. For example, if your CPU frame time is around 16 milliseconds, then your game is running pretty well. Now, while your goal is to keep things under the 16 millisecond mark, some frames your CPU load changes and you expect slight variances in the time. If, however, your frame time starts to spike suddenly and your CPU computation load hasn't changed, you haven't put 200 zombies on the screen, then there's a high probability that this is due to the GPU getting backed up, forcing your CPU time to stall in the driver. These tall spikes are actually pretty telling, since they're around 11 to 15 milliseconds in time, which would be exactly how long the GPU would need to flush a frame or so. In order to figure out what the culprit really is, it's time to sit down and get proficient with mobile profiling tools. Some of the nuances of the GPU performance require dedicated tools to discover, but thankfully, each Android chip manufacturer provides a great suite of tools to give you more information on how to optimize your game for their hardware. Understanding and optimizing the dance between the CPU and GPU is the first step in maximizing your game's performance, which of course results in happier users, which could result in better transactions, and that's the whole point, right? So keep calm, profile your code, and as always remember, perf matters.
Hi, I'm Dennis Huo, and I just want to show you how simple, smooth, and effective running open source big data software can be on Google Cloud Platform. Now let's just begin by considering what we might expect out of any modern programming language. It seems it's not quite enough to be Turing complete, but we probably at least expect some standard libraries for common things like, say, sorting a 1 megabyte list in memory. Well, nowadays it seems like everybody has a lot more data lying around, so what if it could be just as easy to sort a terabyte of data using hundreds or even thousands of machines? More recently, programming languages have had to incorporate much stronger support for things like threads and synchronization as we all moved on to multiprocessor, multi-core systems. Nowadays, it's pretty easy to distribute work onto hundreds of threads. What if it could be just as easy to distribute work onto hundreds of machines? Nowadays, it's also pretty common to find some fairly sophisticated packages for all sorts of things like cryptography, number theory, and graphics in our standard libraries. What if we could also have state-of-the-art distributed machine learning packages as part of our standard libraries? Well, if you've been watching the code snippets over here the last few slides, you may have noticed that none of what I just said is hypothetical. It's all already possible right now, today. Which is fortunate, because just as we spent the last decade finally getting the hang of programming for multi-threaded systems on a single machine, nowadays it seems more and more common to find yourself developing for a massively distributed system of hundreds of machines. And with these changes in the landscape, it's pretty easy to imagine that big data could be a perfect match for cloud. All the key strengths of cloud, like on-demand provisioning, seamless scaling, the separation of storage from computation, and of course, just having such easy access to such a wide variety of services and tools. These all contribute to opening up a whole new universe of possibilities with countless ways to assemble these building blocks into something new and unique. And through this shared evolution of big data and distributed computing, big data has become a very core ingredient of innovation for companies big and small, old and new alike. Take, for example, how streaming media companies like Netflix, Pandora, and Last.fm have contributed to changing the way that consumers expect content to be presented. They've applied large-scale distributed machine learning techniques to power these personalized recommendation engines. Millions of users around the world now expect tailor-made entertainment as the norm. As another example, just taking a look at our Google's roots in web search, and alongside a multitude of other search engines, news aggregators, social media, and e-commerce sites, we've all long grappled with applying big data technologies just to tackle the sheer magnitude of ever-growing web content. Users now expect to find a needle in a haystack hundreds of thousands of times every second of every day. And amidst this rise of big data, it's not that the data or the tools have suddenly become magical. All these innovations ultimately come from developers just like you, always finding new ways to put it all together so that big data can still mean something completely different to each person or entrepreneur. On Google Cloud Platform, through a combination of cloud services and a wealth of open source technologies like Apache Hadoop and Apache Spark, you'll have everything you need to focus on making real impact instead of having to worry about all the grungy little details just to get started. Now, for an idea of what this all might look like, let's follow a data set in the cloud on its journey through a series of processing and analytic steps, and we'll watch as it undergoes its transformation from raw data into crucial insights. Now, what I have here is a set of CSV files from the Center of Disease Control containing summary birth data for the United States between 1969 and 2008. These files are just sitting here in Google Cloud Storage, and as you can see, it's pretty easy to peek here and there just using gsutil-cat. Now, suppose we want to answer some questions by analyzing this data, like, for example, whether there's a correlation between cigarette usage and birth weight. At more than 100 million rows, it turns out we have at least 100 times too much data to fit in any normal spreadsheet program. So that means it's time to bring out the heavy machinery. With our command line tool, bdutil, and just these two simple commands, you can have your very own 100 VM cluster fully loaded up with Apache Hadoop, Spark, and Shark, ready to go just 5 minutes or so after kicking it off. Once it's done, bdutil will print out a command for SSHing into your cluster. Once we're logged into the cluster, one easy way to get started here is just to spin up a Shark shell. We just type Shark, and this prompt will appear. Now, what we'll be doing here is creating what's known as an external table. So we'll just provide this location parameter to Shark and point it at
Hello and welcome to Material Science, or what you might also call, no, let's do that again. Hello and Material Design for Android Developers. The point of this session is to try to get into some of the technical details and the overview of what it actually looks like from an engineer's perspective. There's a lot of design sessions this week, including one right before this session, where they talk about some of the ideas behind material design. What we wanted to do is talk about what that means in terms of the actual APIs we're exposing, or where you hook into this stuff as an Android developer to create material design applications. There's a hashtag if you like to do that thing. There's a feedback URL if you have absolutely stunning and glowing comments about the session. Please feel free to go there. If you want to know what we look like, you could actually just look up at the stage, or there's pictures of us. I am Chet Haas.
And I am Adam Powell.
And we are both on the Android UI Toolkit team. This is the team that basically handles the UI Toolkit widgets down through the graphics that render them, with animations that move them around, and spitting out the GPU commands to actually hardware accelerate all this stuff and get it onto the screen as fast as possible. That's what the team does. Which means that all the stuff that we need to implement for material design also needs to run really fast, because the same team is handling the functionality as well as the performance aspects, which is an interesting trade-off.
Right. So the first question that you might be asking is why? So we've already seen the keynote videos. We see a lot of flashy effects. We see high-minded design. We see performance challenges. And we see a way to really bloat our UIs. So we don't actually want to take that sort of negative view of this. We want to make sure that this is something that really sort of matters to our users. And if there's one big takeaway from all of the material design material that you're going to see over the rest of the day, and for probably until the L release here as everyone starts getting their apps ready, is that motion matters. Movement can teach a user what something can do and where it came from. If you've ever seen in a UI something just pop out of nowhere, something disappears from under your finger, that's a really frustrating experience. So by using motion, we can go ahead and teach users how the system behaves and what they can expect from that system. So this is cues. We can give cues about what can be touched and moved by making things that look tangible. This is one of the things that cards really give us. And these sorts of virtual objects that can morph and move around in ways that don't quite simulate real-world objects can still hint at that tangibility. These are your cards, paper and ink, all of these things that you've seen in the videos so far. So the takeaway really is motion plus tangibility equals a more understandable UI for your users.
So I wanted to give you a brief mental model of what this release and this process of actually implementing material design was to me. Actually making this work within our team, getting the pixels actually showing up on the screen that represents the design. The process is basically taking the ideas that UX has, that the design team has, where there are these grand ideas, and there's paradigms, and there's systems, and there's languages, and there's all this nice stuff that they come up with, and then actually translating into the technical details of the functionality that engineers actually need to write applications that are going to deliver that. So the way I picture it, so we have this huge design team, so we have access to great artists, and we could ask them to come up with art that sort of represents this, or I could actually just draw it myself. This obviously is an artist waving his hands furiously and coming up with beautiful rainbows and wonderful things. You can tell it's an artist because there's a beret involved. Either that or they're French. So we take the design ideas that are sort of floating up in the air and incredibly vague when engineers get in the room and get a really puzzled look on their face, kind of wondering what all this stuff is. When they say language in the context of applications, it doesn't make sense. So then
that means Java, right?
I think so. I think it means the Java programming language. We'll talk to the UX team after this and sort of nail that down. But the idea really is to take the concrete elements and figure out what they actually mean by all the hand waving when they're talking about floating action buttons, when they're talking about ink and paper, and actually translating it into the particular elements that we need in the platform to give you those capabilities. The way I think of it is, I think it's like the Nyquist sampling theorem says that there's a frequency at which you can sample a curve such that you can then reconstruct the original curve. And I won't get into technical details because I don't understand them. But it's the same idea here. If UX is creating this beautiful spatial curve of the design language and the pattern they're coming up with, and what you want to do is implement enough functionality that they actually get what they wanted, even though they had a hard time sort of describing it in terms of the crisp elements that you needed. So what we did on the toolkit team was to translate that into the features and the functionality that we needed to expose those capabilities. And this boiled down to the features that we're going to talk about in the next few minutes. We have the ability to do real-time shadows. We have activity transitions with shared hero elements. We have circular reveals. We saw some of that in the design talks as the floating action buttons are revealing into larger morphed content. We have recycler view widgets for more animated and rich list capabilities. Touch feedback, so the user has constant feedback about what's going on in the UI as they're interacting with it. And then obviously, we're working on performance all the time as well.
So from all of this, how do you actually write a material app? Well, the first step is something that you're probably already familiar with in writing Android apps, is your theme for your activities. So theme.material is the first step. Choose this, inherit from it if you've already got a custom theme that you're using other elements in, and just take a look. How does your app look with this just simple switch flipped? And you're going to need to make some spot fixes to that. Pretty much every major app that's non-trivial at this point has done a lot of work to try to match either a hollow theme or a very custom theme that's been implemented in the past, and you're going to need to update those individual elements as you go. So you'll want to go ahead and implement the design guidelines. So this is going to be new ways of dealing with layouts and colors, new metrics, new measurements, and use of the grid. From there, it's really mostly standard Android programming. You're going to be using a lot of the tools that you're already familiar with there. We've got some new APIs to assist with motion and alignment of certain elements on screen that you traditionally haven't had a lot of control over in the past, such as where things are positioned in the action bar. And then, of course, you can use the support library as needed. Most of you are familiar with this already. We've got things like drawer layout, view pager, all of these widgets that developers know and love at this point. We're adding in some more. We've got recycler view, which we're going to talk a little bit more about shortly, and card view, which basically wraps up a few of these pieces of new functionality in L and gives you a nice fallback for a particular use case on older platform versions. So then, as needed, you can go ahead and use some of the exclusive L APIs for newer platform versions as well. This is stuff like newer graphics APIs around shadows and clipping, setting elevation on your views so that they can pop out into space. We've got the touch feedback ink ripples that you've seen in some of the videos so far. We've got icons and other drawables. You can animate state changes. If you're already used to pressed states and focus states, so on and so forth, you can define animated transitions between those states now. And as for general animations, we've got view reveals. We have new ways of dealing with animation curves, and of course, the activity transitions that you've seen. So at this point, most of you are asking, what about compatibility? Because no one has the luxury of targeting only L and above right now if you want to have some users when this thing ships. So for apps on previous releases, use the app compat themes. You may already be familiar with these from using the compatibility action bar in the support library. We're going to be expanding this out to also cover the material design components in L. You can, of course, still use the new support library widgets regardless, like recycler view, card view, and the others that you know and love.
So now let's talk about some of the new APIs and functionality that we exposed in the UI toolkit. One of the important points that Adam was talking about is you can get a lot of the functionality of the design that you're trying to achieve just through standard Android programming, by which we mean the APIs that you're already using, standard layout and measurement stuff, standard drawing stuff. We did add new APIs. Most of the reason they're there is actually for our internal use. So we have the ability to pop a view up to give it elevation above the view hierarchy plane. But we use this for some of the standard widgets. You don't necessarily need to use these for your application, but they are there for your use if you want them. So one of those areas is actually widgets, which this is not new L APIs. It's, in fact, even better than that. It's new support lib APIs.
Right. So again, you have access to this from everything from API 7 and above. We have both recycler view and card view available for you to take a look at early in the preview. So what is recycler view? You've heard a lot about this now. It's a base class for new adapter-backed views. Basically, anyone who's tried to do anything remotely interesting or complicated with a list view at this point has banged their head against a lot of walls, hanging beams, sharp objects, whatever you might want to use as your metaphor for that. And basically, list view is set up to take complete and total control over the layout of items pretty much any time at once. So you look at it funny and everything relays out, all your animations are lost, views that were halfway through an animation are now halfway off screen, bound to some other data item. And it's really frustrating as a developer to try and use that to get any sort of really rich experience. It's really outgrown its complexity budget in a lot of ways. So Recycler View is meant to have more flexible views into these large data sets that you would traditionally use a list view for. We've already built in functionality to allow an adapter to tell the widget a bit more about what's going on with a data set. When items are specifically added or removed, or when ranges of items are specifically added or removed, rather than just saying, hey, my data set changed. Well, what changed? I don't know, you figure it out. So in this way, we're able to give you a few more things automatically, such as animations when items are added or removed from the set.
If I could avoid creating one more tutorial on how to animate something in an adapter view, I will be happy.
So that's the idea here. So we also allow you to do custom layouts in this framework. Many of you have said, OK, well, list view is great, but what if I want it to scroll horizontally? What if I want the dividers to behave just a little bit different? What if I want a staggered grid that doesn't necessarily line up along particular lines? Also, so we offer that. We offer multi-directional scrolling. Basically, you as the developer can plug in your own layout manager to define how item views get laid out. This sort of speaks to the general theme of Recycler View, which is to make it extensible in all the ways that list view really wasn't. We also have card view. Now, card view takes a little bit of a different approach from Recycler View. Recycler View is meant to be a very generalized component that you can go ahead and build on, whereas card view is meant to be something that solves a very particular use case in a way that is compatible and gives you a best effort approximation of the design intent on different platform versions. So in this case, we'll give you a standard consistent look. You get the real soft shadows and customized rounded view clipping for your rounded corners and such on L. And we'll go ahead and give you a best effort faked version and shaped background pre-L. But as you can see from the slides up here, these actually look pretty similar in terms of giving you the general intent of the design. So this type of tool is the sort of thing that we want to provide more of to allow you to express material design on older platform versions.
So now let's talk about the other side, the APIs and functionality that's actually in the L platform. The previous stuff was in support library. Feel free to use it wherever it makes sense for your application. If you're targeting certain functionality for your application specifically at L, then you have access to the new APIs that we introduced. First of all, let's talk about shadows. So here's an early video that the UX group did as they were exploring the space of what they wanted the shadows to actually be like. So we can watch this. Let's see if it runs. So we have the light source. Notice it's an area light source. We have an orthographic projection for the camera looking straight down. And then we have cards doing complicated things, casting these nice real-time dynamic shadows. And all the engineers responsible for implementing something like this at 60 frames a second just had a heart attack.
Or sometimes laughed. Much.
So here's my favorite video mock that came out of the design team during the entire release. A couple of the engineers that were working on early prototypes of the shadow stuff went over to talk to the design team. And as they were talking to them about the requirement for having this area light source, and maybe it should be rounded, maybe it should be rectangular, and we definitely want rounded corners and soft shadows and all this stuff. And obviously, it has to perform at the 60 frames a second rate. In the background was a high-end workstation running high-end animation software rendering this. One single frame in 30 seconds. And they want it 60 frames a second on a phone. It's just so painful. Just that you can even tell where the shadows are there, and it's still taken this long to render the thing. And we're wondering how to actually do that in real time. And then I guess we figured it out. So the idea behind shadows is to allow you to elevate your views, to post those views above the view hierarchy plane. So you can think of everything prior to L living in a volume, if you will, except that everything was at z equals 0, right? Everything is in that same plane. It's basically the flatland of Android. Well, in the L release, we allow you to then boost some of those views at your option with an elevation or a translation z value or a z value to basically give them a z value that puts them above the plane of everyone else in that flatland. And that allows them to then automatically cast the shadow from the area light source that we have positioned locally above that world. One other advantage of doing it this way, instead of just trying to figure out, okay, well, how can we quickly draw this shadow image behind this thing and make it look approximately correct? One advantage of doing it correctly in this sort of view volume approach is that views can also draw outside of their container bounds. I don't know if you've ever tried to draw a view, like cast a shadow or you scale the view up and all of a sudden it scales or it casts outside of its containment hierarchy, then it gets clipped. And then you have to play around with this API called set clip children false, and things kind of go not the way you expected them to. And it's all horrible hacks. So instead of doing hacks, we're actually doing it physically correctly. We're creating this 3D volume. You can boost views up there, and they can draw wherever they want to in that volume. And they're correct, ordered in Z. They draw in the correct order, and the shadows draw in the correct order below them on top of the view hierarchy itself.
So in addition to that, many of you have probably run into cases where you really do want to have a proper Z order for your views when you start stacking them. In the past, you've had to override the child ordering parameters for drawing. In the past, you may have also just sort of abused the general child ordering within a view group in order to achieve the desired effect. And this gives you a very easy way to skip all of that hassle.
So we can look at some of the APIs involved with doing this. There's the basically elevation property. This is where that thing lives. You can think of this as its permanent Z location. And we have a couple of other properties that are similar to the translation X and translation Y properties that we already had. These are more for use in animation, sort of transient post-layout state where you're animating to and from different Z values. So for instance, if you have a view that you want to pop up, you want that shadow to enlarge, when it's in a press state, then you would animate the translation Z property, whether or not it had a positive elevation value. There's also other APIs that we're not showing on the slide about clipping. So you can set the shape of the shadow itself. So you can think of floating action buttons as being this circular shape. Well, they want to cast a circular shadow. Otherwise, the illusion kind of breaks down, right? So there are APIs to allow you to set the shape that it casts a shadow from. There are also APIs to allow you to set an outline that it's actually clipped to. Some of this necessarily, given the constraints that we're operating under, are very limited. You can't clip to arbitrary path shapes. So some of the details are in the SDK docs, and also the APIs around clipping and specifically are probably apt to change as we go toward the full release, but you can see where we're at in the preview release in the meantime. Let's run a demo so we can see how this thing works. So if we can switch to the demo, here we go. You can see next to my very red finger, I can drag this card around. And I can actually enable tilt. And you can get a subtle tilt on this thing. I think there's even a little bit of shading, which is probably way too subtle for these projectors. So you can see, yay. This, in fact, is not an artist rendering, and it's not taking 30 seconds of frames. We got 60 frames a second on, this is a Nexus 5. Actually, a lot of the early work was done on older and slower devices. I think the original Nexus 7 was used as a prototype device just to make sure the things were actually going to be fast enough. And again, this is an area light source. For any of the graphics geeks in the room, area light source, local, right? There's a lot of assumptions you could make if it was a point source and it was infinite, and we're not making those assumptions here. We're actually creating these meshes in real time to cast shadows with soft boundaries because that's the effect that they wanted. So works reasonably well. There's another one I was going to show. Let's see, shadow card stack. So you can see these stacking elements as they're popped up to different Z values, and they cast larger or smaller shadows, just as you would expect in this physically correct volume.
And this demo really illustrates some of the other effects that you may have seen during the keynote demo as well, which is you can have elements that are part of the same merged plane split and take on more of a three-dimensional character as you interact with them.
If we can switch back to the slides. Hey, there it is. Yeah, let's talk about touch feedback. Sure. Let's talk about ripples. So one of the things that we wanted to do in the UI in general, actually we were thinking about it in the engineering space before we were faced with the overall design language changes for material design, is the ability to tell the user more of what's going on with their UI interactions. In particular, when they press a button, there is that immediate atomic interaction where the button is in a press state, so they get the press state color. That's nice, but wouldn't it be nice if we could animate some of those changes so they get information about the changing state, sort of a time-based change in state, as well as more information about where that state actually changed. So ripples do that. The touch feedback interaction on the standard widgets and on your custom widgets, if you choose to enable it, gives you feedback about a press state happening or other states happening. So the ripple will sort of emanate, not only that, but it will emanate optionally from the point of contact. So you can get a ripple that actually starts from where the finger pressed. So much more interaction information for the user to actually understand what's going on.
And again, just to speak again to the principle of motion and how that's really sort of helping understand the UI, this eliminates a lot of the really disruptive flashing that you see in UIs today, where you get the entire rect of the touch area lighting up very harshly as soon as you touch the slightest corner of it. This sort of softens that out a little bit for your users.
So there's a new class called Ripple Drawable that enables this, and this basically wraps the content that you want to display, and then reveals that content over time with the ripple. And then you optionally have a color that you can set as well to change the properties of the ripple. This comes automatically built into a lot of the standard widgets like buttons. You'll see this in the applications that are enabled with material design already. Or you can use Ripple Drawable directly, either from code you can instantiate it, or you can do this in XML resources. Or an easy way to do it is you can set the foreground or background of something to be a selectable item background, and that will automatically ripple that selection interaction. So we had some changes in icons. We had some new stuff added. There were a couple of these. One was state animation drawable, which is the ability to actually animate through different PNGs. You can think of this as keyframe animation, where we're just flipping through different images along the way. The checkbox and the radio button, I think, in the L preview release represent this. So if you've seen any of the demos of that so far, if you want to actually flash the system image, you'll see those widgets interacting through this. It's basically a way for us to animate from state to state through this series of images along the way. And the other one was State List Animator, the ability to say, OK, when this widget goes from this state to that state, here's this arbitrary animation that I want to run. In general, you would create, you would give it object animator animations, as you see here. We're stacking up 3 of them in an animator set, and we're saying, OK, I want to animate the following properties on my object when I go from the pressed to the unpressed state, and back and forth and to different state combinations. So a much more flexible way of saying, here's the behavior that I want this widget to go through as it goes from state A to state B.
So what's an example of where someone might use that?
For instance, popping a button up. If you want to have a press state for when you click on the button, that sounded like a canned question. It wasn't. I wasn't expecting you to ask that. Like, why are you making me think up here? So if you want a button to raise, to set its elevation property when someone presses on it, then you can set an animation to do that. So when it gets into the press state, it says, I'm going to the press state. Here's an animation that I need to run, and then you would animate the translation Z property from, say, 0 to 20. And then when it goes back to its base state, you would animate from 20 back to 0. Animation, let's talk about animation. So there were various things introduced in the preview release, which you'll see in completely different areas, and we'll sort of build up to the largest one. The reveal animation that we've seen in some of the floating action button demos in the previous talk, for instance, as well as other interactions that are up to you in your application, is the ability to define an expanding shape that reveals the content underneath it, like a circular reveal, or you can combine this animated circular shape with a more complex shape of your view to get sort of a rounded rect effect or whatever. Basically, you say, create this animation that is a circular reveal. It's going to be centered here, and the radius is going to animate from this value to that value. And then you start the animation, and you go. So very simple way to create an animator. It's kind of an opaque interface. There's not a lot of flexibility there. Again, given the constraints that we're under, actually make these things performant on the types of hardware that we have. We limit these capabilities to the specific use cases that we find are important. So you can do what you need to, but it's going to be limited to this set of capabilities for now. The important thing to realize, though, is that some of these things can be expensive. So one of the things that we wanted to do was not make it super easy for you to just create this arbitrary clip on your shape and leave it there all the time, because that is incredibly expensive. The way that we implement this stuff through the GPU is not trivial. So we're going to run an animation over time, and then it's going to be done, and we can just be back to rectangular views, because frankly, that's easier. So it is expensive. We expect you to use these in very transient situations where you're just animating a thing, and then you back out of the animation. You can get a similar effect on previous releases. If you've used the search on the Nexus 5 and the KitKat release did this, they had a circular reveal to show some of the search results. There are ways to do this already. Again, there are performance issues there, and you need to figure out whether that actually works for your application and your situation. But you can already do it with drawing shapes with bitmap shaders. Animation curves. So one of the things that the designers as well as the engineers wanted in this release was the ability to have more arbitrary time interpolation. So we already have the ability, in fact, the default behavior of all animations is ease in, ease out. So we have a subtle acceleration and then a subtle deceleration out of it, and you can tweak how magnified those effects are. And there's other things you can accelerate all the way in, you can decelerate all the way out. But once you get past those, that's kind of it. And designers really like to think of things in terms of curves instead, quadratic and cubic Bezier curves, and the ability to tweak the parameters to get exactly the kind of timing behavior they need. So that's what we implemented in the platform. And in particular, there's 3 animation timing curves that they recommend as part of material design. And you can see these here. They define these with particular curve parameters, and we then define them. I put the file names down at the bottom. So these are resources that you can simply refer to as interpolators in your animations. Or you can actually set the parameters arbitrarily. So you can see that here. There's an XML resource that you can define to do this, or you can access the code directly. You're basically working with a unit square. This is sort of a traditional animation and graphics way of defining things. You have a unit square from 0, 0 to 1, 1. You can think of the control points being at 2 corners of that square. Those are the anchor points, sorry. And then you define where the control points are to vary that curve along the way. In fact, you can have a much more arbitrary path, because we're actually doing a full-on path in there. It's not even just a single curve. You can define a complex path. I don't know why you would, but you can. We also have the ability to curve motion now. You could already do this. I wrote a blog post, I don't know, 2 or 3 years ago, talking about how you could use type evaluators to move things along in a spatial curve. It was not easy, which is why I wrote a blog post around it and explained it, and you can certainly still use that approach. But we also wanted to enable an easier way to do this through the API. And now you can. There are new constructors in Object Animator that will allow you to specify the path that you want an object to follow as it moves along, animating both X and Y as part of the same animation. So there's a path animations demo in API demo. So if you check out the SDK, check out that demo, and it'll show you different variations on that theme. Activity transitions. So this was a fairly big effort that built on the transitions API that was introduced in KitKat. The idea behind transitions is to make animations much more easy and automatic. They're still customizable, but the big idea is I'd like to know what state my UI was in, and then I want to know what state it's going to be in, and I want you to animate everything in there instead of me creating custom animations for everything, right? So you snapshot where things are at, and then you run layout, and right before it draws things, you figure out where things are going to be, and then you roll everything back and you animate those changes instead. That's the way transitions works, and that's the API that came out in KitKat. And this is the way that activity transitions now work as well. It builds on that same model, but allows you to have that same way of specifying animations between activities. And not only that, not only does it figure out how to animate these things out from the launching activity and how to animate the items in on the launched activity, but you can also specify a set of shared hero elements that are then basically thrown over the wire and said, OK, this image was here, and now it's going to be there, and it's going to be this different size, and animate that change automatically. So we came up with a protocol for defining, OK, here's the name that we're defining for this thing, and then the activity on the other side, if it knows what that name is, can make some assumptions about that being the same element. Then that element is shared across and animated automatically through activity transitions.
So the summary for that is essentially that this now gives you a way of establishing a protocol between different activities that may or may not be part of the same application to share a particular element in a transition from one to the other.
So you can already do this in your own application. Like if you have a sub-activity, say a details view for some thumbnails, there is already a technique for doing this. What we're doing is making that less of a hack and more codified in the framework APIs to allow you to do that more easily inside your application. Not only that, but through the protocol we've established with the names of these shared hero elements, you could actually do that across processes. You could end up launching somebody else's activity, and if they know what to do with that shared hero element, then they can take part in that activity transition animation. If you want to know how to do it on previous releases, if you're trying to do this everywhere, there's a dev byte on it called custom activity animations. And you can think about the technique that's used there as basically being sort of baked more into the framework as a first-class citizen of how to do it for real.
Right, and this will take care of a lot of the really tricky bits around the activity lifecycle itself. If your activity gets restarted, make sure that you're not replaying another intro transition animation that you don't want to see again, so on and so forth.
So here's some of the code. There's actually a lot more APIs and code involved, especially when you start customizing things. But just to give you an introduction to how you enable these things and how you actually start these animations. So you can put this item in your theme. You define a style that says, I want to enable these window content transitions, or you can do it in code, very similar. And then you can either just use the default animations, which are going to cross-fade between activities, just a simple fade out, fade in. Or you can set custom transitions, either ones that you define or ones that the platform gives you. Like, I want an explode transition, which shoves everything out off the top and the bottom or the sides of the screen. And so you can set these customs for the exiting activity as well as the entering activity. And then finally, you can define what the shared element set is that you're passing over the wire, give it names, pass it over, and then define what the transition animation is that happens on those elements as well. And I think, we have a demo in a minute. Finally, I wanted to mention that there are new transitions that were written as part of this work. These are available for transitions in general. There's the ability to move image. It's a lot more flexible. Image view can be a little bit cranky when you're trying to sort of resize it along the way, and this has some capabilities to allow you to do things in ways that you probably want to if you're scaling or moving images around on the screen as part of these transitions. Sliding effects to slide things in and out to the right and left. Exploding is sort of exploding the items out with this staggered delay, so you get a nice effect of things sort of gradually moving off the screen. And a couple other transitions as well, but let's take a look at a quick demo. If we can switch to the demo device. Back out of here. So this is in API demos. This is just a simple demo that shows some of the how-tos. So the items that I'm clicking on, obviously, are the thumbnail images that then end up launching this other activity you're going into. They share that as the shared element. You can see the other images animating out, and then the list items, the text animating in on the other activity. And then, this is a demo that was written as part of another talk. At 2 o'clock, we'll go into more of the details and some of these graphics goodies. And again, you can see as we press on this thing, then it launches this other activity. And we go into the second activity, sharing the thumbnail, sharing that bitmap image is the data that's being passed over for the shared hero element. If we can go back to the slides. Take it away.
Take it away. So the takeaway for this talk is that we're going to provide you with the material look and feel for all the basic parts of the framework, all the buttons and checkboxes and everything else that you know and love. We'll give you the ability to theme these, so you can go ahead and apply your branding colors to these without having to auto-generate a lot of extra assets within your application. But that's really not enough. what you really need to do is to work with your designers, work with the design guide itself, and you're still going to be writing a lot of custom code in your application, because the parts that make your application really stand out and be different are the parts that we can't write for you, or else they're going to be the exact same things that every other application does. What we want to do is make sure that you have the tools available in order to make those really unique experiences for your users. So, resources.
So there's a few resources that are worth mentioning. You've probably seen this one already. There is a design spec. Is it there? There's also there's a link off the d.android.com to a bunch of this information. And you certainly want to check out the preview site itself. Get the SDK, build against it, get the system images, flash it onto your device, play around with it. I would also suggest, if you're interested, especially in the graphics and animation parts of what we talked about, you come to a talk at 2 p.m. that coincidentally has me on stage again with Romain Guy. And we'll go into a lot more technical details about how some of this stuff works and how it might be used to create these kinds of applications. And finally, oh, there's a feedback URL again, and we actually have some time for questions. So there are a couple of mics. Find a mic out there and fire your question at us.
Come on up. Yes?
So a quick question. I want to know how we're going to be able to access this in previous versions of Android. I know I can look that up, obviously, but I want to know how much of this is supported in the support library and which version of the support library.
So there's a new version of the support library out with the Preview SDK right now that's going to make some of this available. But really, the Preview SDK is more about showing you some of the new APIs in their natural habitat. And for a lot of other reasons, you're probably not going to want to let some of the apps linked against the Preview SDK out into the wild, just because it's going to be involving a lot of other pre-release API. That being said, once the final SDK version is available, you'll see that the AppCompat library and others will have some of the backports of some of the visual styling that's available. And we're going to continue offering things along the lines of card view to do very specific use cases, and then things like recycler view that will allow you to bring that kind of motion everywhere. Now, things like the activity transitions that Chet spent some time talking about, that you're probably not going to have available. So we're probably going to just go ahead and have some simple fallbacks that you probably already know and love there.
It's also important to note, as it came up earlier in the talk, that a lot of what we're talking about is an approach to design that you can then implement using standard Android programming, right? So yeah, some of the new animation capabilities, if they're not part of the APIs on the earlier platforms, you can't use them. But there are other ways to achieve those kinds of effects in many cases. And some of the measurement, the layout, the colors, that stuff, you can get stuff to look very similar. It's just going to be a little different approach for some of the new animation capabilities in particular.
That's right. The microphone in the back?
Can you hear me?
Yeah.
Yes.
Good. So in the keynote and in some demos that I've been seeing, I've noticed that there's been a movement to circular image views. Is that going to be an available widget for us to use?
Yes. I don't remember if we made it just a simple drawable or an actual view, but we've got a component in the support library that will go ahead and apply that circular clip to your images.
Oh, there's a rounded bitmap drawable in the support library.
Yeah, I think that was
what
it.
you're talking about?
Yeah.
Yeah, I mean, it's fairly simple. We did not create a floating action button or a fab widget because it's pretty darn simple. It's basically an image view where the thing that you're drawing is a circular image. Fairly straightforward. You set an elevation on that, you tell us what the outline is, and we do the right thing with it. It's similar for card view, actually. I wanted to mention this, that it's very easy to actually get a card view effect. In fact, the demo that we're going to show in the talk later today, I just implemented using a standard view that I clipped and I shadowed appropriately. It was straightforward. The advantage of us baking it into a specific widget is at least we have standard padding and layout, and also the ability to have that similar look and feel on earlier releases. So that seemed worth creating a widget for. The fab, not so much.
Okay. Thanks.
So the activity transactions and everything are really nice and definitely solve a common pain point. What I wanted to know is if there's any support for that for fragment transactions and things going across fragment boundaries.
Yes, I don't believe it made it into the preview SDK.
Yes, not yet, but yes. As soon as we solved the really hard problem, which was activity transitions, the next step was fragment transitions. So I would look for that.
Thank you.
Yep.
In the back?
Oh, he had the same question I did for
Oh, okay.
activity trend. So, but we can expect to see that in another preview release, maybe? It's in the
I don't know what the timing is of other bits coming out. I would just say expect to see that in L.
Okay, but you're working on it. Awesome. Thanks.
So now that we're having these elevation transitions for objects, kind of implies manipulability of things on the screen. Are there any improvements to drag and drop coming in L as well?
What kind of drag and drop are you looking for specifically?
Oh, reordering collections kind of arbitrarily, you know.
Oh, I see.
Nice event interface.
Yeah, so one of the things that Recycler View lets you do is it lets you apply some item touch listeners that basically lets you it lets you handle touch at the level of the collection rather than the level of specific item views. So you don't have to perform a lot of the translation back up to the parent and then back down to specific points in space for that. So hopefully that'll be much easier.
Yeah, that's exactly what I was hoping for. Thanks.
Great. In back?
Does it make sense, or is it even possible in existing code to change list views to recycler views?
So they're largely compatible. There's just one mostly, well, two key differences. First is that if you're used to cursor adapter and the way that it splits out create and bind view into two different steps, this is the default state of being in Recycler View. So as long as you can sort of split out those components of your get view from your list view adapters right now, then that's one easy thing to do. The next piece is, like I mentioned before, being able to supply richer notifications about the nature of a data set change. So without getting those sorts of signals rather than just a very coarse-grained notify data set change call, then we're not going to be able to do quite as much with the animations.
Is that the only benefit then?
Which, the animations?
The richer notifications.
It's newer, it's cooler.
It should be obvious, right? No, I guess I don't quite understand the question. So from some of the stuff that we had talked about before, we've got, do you mean benefits of switching over the
Yes.
adapters or switching from like a list view to a recycler view?
Yeah,
For what's essentially the same UI?
Yes.
Okay. Yeah, if list view is still meeting your needs, then by all means, don't do any more work than you already have to. This is mostly to address the needs of any sort of UIs where you really want to be able to do much more intricate motion and intricate touch interaction with your items, or if you want to do custom layouts.
Great, thanks.
What do you guys think about the relationship between these new styles and basically how it relates to overdraw and battling overdraw? Because from my point of view, it seems not overdraw friendly.
Do you want to talk about some of the work that we were doing with some of the drawing command reordering? Because I think that some of that comes in.
Yeah, I mean, we wear many hats in the toolkit team, and one of them is all about performance. So there was a lot of work done in previous releases about optimizing display lists and eliminating overdraw as much as we can automatically, actually in the framework. So it used to be the case that if you had, let's say, a view that was completely obscured by another view that was larger than it and completely opaque, we're going to overdraw that thing because we don't know what's going on. If you want to draw that, okay, we'll draw it for you. And all of a sudden, you've got 2x overdraw without doing anything. So now we can actually eliminate that because we do some post-processing on the display list so that we don't draw the thing that's completely obscured. So there's a lot of intelligence going into the display list optimizations already to avoid some of those situations. I would agree that more animations and more rich graphics on the screen probably means that you need to be aware of what's going on. If you're having fading and translucent effects all over the screen all the time, then yes, we will be drawing more pixels than if you didn't do that. It's kind of a standard Android programming technique, like be aware of what's going on the screen, use the tools that are there, like the overdraw detector, to actually show what's going on at the pixel level and make sure that you're not tripping over those hazards.
Right, in practice, we've seen a lot of teams start building their material UIs so far, and by and large, their overdraw situation hasn't changed a whole lot from their previous designs. Again, as soon as you start introducing fully opaque backgrounds, sliding over other things, if you start doing a lot of stacking, then yes, there's cases where you're going to want to start thinking about the overdraw a little bit more and what you can do to avoid the clipping. We're definitely trying to do as much as we can in the framework to do that automatically.
I guess from my perspective, it's more of the design principles of everything feels like it's stacked. And in order to accomplish that, you're going to have to stack things sometimes. And is there a good way to get around that?
I definitely say limit
hopefully
how deep
stacking is more of a transient state. I haven't seen a lot of UIs where the things are full-time stacked on top of one another.
Well, there's some of the things in like the Google Now cards that'll stack on top of one another, so on and so forth. But even some of those, what they've started to do is you'll notice that some of the cards start merging together into a single card if it's part of a collection that then breaks out into some of their detail views. And I think that some of that was shown in some of the demos as well.
Okay, thank you.
And it looks like we have 2 seconds left for questions, which means that we're all out of time. Thank you very much.
We'll be over here if you want to ask some other questions afterwards.
Google I/O is just around the corner.
And we're really excited to show you what we've been cooking up.
For the first time, in addition to our live streams, we are rolling out over 100 I/O Bytes.
Short videos to help developers like you dive in.
And experience I/O anytime, anywhere.
We're delivering more content.
And making it easier than ever to design,
develop, and distribute.
And making it even more accessible.
And it's all for you.
It's just for you.
It's all just for you.
At Udacity, we're reimagining education by teaming up with industry leaders like Google to create courses on the cutting edge of technology. Today, we're announcing 4 new courses developed with Google in Android, Cloud, Web Performance, and UX Design. For more information, visit udacity.com/Google.
Hey, I'm John McCutcheon, a software engineer working on the Dart virtual machine. In this talk, I'm going to introduce the Dart Observatory, a powerful tool for profiling and analyzing Dart applications. Finally, I will explain how to use the CPU profiler to guide you while optimizing Dart code. This talk is aimed at an intermediate Dart programmer who wants to make her programs fly. Observatory is a powerful tool for analyzing and profiling running Dart programs. It's a new type of tool which gives you an always live, hyperlinked view into the running state of your program. Presently, Observatory consists of 6 tools. The first is View and Evaluate. You can view any object inside the VM, an isolate, a library, a class, or in any instance of a class. You can also evaluate expressions in the context of these objects, including expressions that modify the object that you're looking at. There's code coverage, which you can view alongside the source directly in Observatory. The CPU profiler is always on, always sampling the running program, collecting statistics about where it's executing. The allocation profile collects statistics for each class, allowing you to figure out how many instances your program allocates of each one. Now, we can give you a stack trace at any time, and this is a snapshot of the call stack, including local stack variables, which you can view and manipulate even after the program has continued running. And if you're interested, you can even visualize the heap. Code coverage is an important tool when testing your program. That is, if there are code paths that are never executed by your tests, you don't really know if those code paths are correct or not. Now, Observatory gives you up-to-date code coverage on demand. Now, code coverage is displayed next to your program source lines. A green box indicates that the code is executable and has executed, whereas a red box indicates the code is executable but hasn't executed. And this is not a good thing. If you see a lot of red boxes after you've run your test suite, you don't have the coverage necessary to really know for certain that your program is correct. Now, lines without a green or red box are not executable. Typically, these are comments or other white space inside your program. Remember, code coverage can be refreshed on demand, so even in the middle of running your test suite, you can go ahead and just take a peek and see how much coverage you've got already. Observatory's allocation profile gives you live, up-to-date statistics about what type of objects your program is allocating. The allocation profile displays information about both old and new space, and this information is displayed the same for each, so we're just going to focus on new space. So you can see on the slide we have a pie chart showing how much of the space is used and how much of it is free. And alongside the pie chart we have a table of statistics about collections that have occurred in this space. The total number of collections that have occurred since the program started, the average time each collection took, that's the amount of time that your program is paused for when we're doing a GC pause, and the cumulative time that all of the GCs in this space has taken out of your program's execution time. Now below the pie chart is a table showing for each class how many instances your program is allocated, how many are live at the moment, and how many of them have survived the last GC. Remember, in the allocation profiler, you can go ahead and manually trigger a GC, so you can be certain that you're looking at up-to-date memory usage information. Reducing the number of allocations your program performs can have a big impact on performance, because by allocating fewer objects, you're going to incur shorter and less frequent GC pauses, which is always good for your program's performance. Now let's take a quick look at an observatory CPU profile capture of a game that uses the popular 2D physics library Box2D. Now, Dart's profiler aggregates samples into buckets that we call tags, and the root of this tree is the default tag that is set automatically when your program begins executing. Now, if we expanded the default tag, and we see the VM tags, and the VM tags are categories of execution that the VM sets while your program is running. So sometimes the VM has to transition over and compile some functions that have never been executed before, and so you'll see the compile tags show up. But we can see from this profile that 95% of the time the script tag is set, and that's good because the script tag is set when we're actually executing Dart code. Now, below script we see that the next highest tag is 3%, and that's GC new space. So right away we can see that this program is spending 95% of its time executing and only 3% of its time garbage collecting new space, and they're spending little time elsewhere. Now, expanding script shows us the hot functions in Box2D. We see at the top solve velocity constraints, solve position constraints, sine and cos. Now the 7 functions highlighted on the slide account for more than 40% of all CPU time used. These are some pretty hot functions. But sometimes you're going to look at a profile and there won't be any hot functions, and we call this a flat profile. Now in this case you can use custom tags to help aggregate and reveal where you're spending time. Now, if we want to see who called solve velocity constraints, we can expand its node and we can see that 100% of the time it is called from island.solve. And further, if we want to see who called island.solve, we can expand its node and we can see that 100% of the time it's called from world.solve. So we can already see that Box2D is spending most of its time solving the world's velocity and position constraints. And if your game was suffering from a performance problem, looking at the constraints you use is the obvious next step. With only a few clicks, we've been able to gain a high-level understanding of how the program is running inside the VM and what functions are hot. Now that we've done a quick overview, let's take a slightly deeper look at the data displayed by the profiler. The observatory profiler is structured as a tree, rooted with the categories of execution, which we call tags, followed by functions. Now you can configure how the tree is displayed, putting VM tags before user tags, or the other way around, or you can hide either set of tags if you're not interested. Now above the profile tree you'll notice a summary is displayed. In this case, the samples were collected over 2 minutes and 11 seconds of wall clock time. We collected 120,000 samples at 1,000 Hertz. This is also where you configure how the tags are displayed. Below the summary, you'll see the profiler tree. Now each row in the tree is either a tag or a function whose name is displayed in the center of the tree. For each tag or function, there's 2 numbers associated with it. The first number displayed to the left of the name is the percentage of its parent's node, and the second number displayed on the right of the table is the global exclusive CPU usage. Here, we've expanded the default tag and the script tag, and you can see that solve velocity constraints is 8.92% of all script execution and 8.6% of global CPU usage. Now, because the script tag is so close to 100% of the program's execution time, these 2 numbers are really close. Otherwise, there might be a larger discrepancy between the 2. This screenshot shows the call tree expanded to show more of the call chain to solve velocity constraints. Note that the exclusive column for the callers is close to 0%. Intuitively, this makes sense because these functions do very little work themselves other than call to other functions that do the real work, all the way up to solve velocity constraints, which is a hot function in this program. Now, optimizing programs is an art and a science. The science is understanding exactly what your profiler is measuring, which we just covered. The art is making effective optimizations, which often requires intuition about your own program and the system it is running on. Now let's talk about the cycle of optimization in general. The cycle begins with measuring using your profiler. And at first you're measuring to identify the hotspots in your program. These hotspots are the functions that you're spending a lot of time in or the tags that you're spending a lot of time in. Now, once you've identified the hotspot, you want to create a representative benchmark. This benchmark executes the hotspot with typical inputs. Now, technically, this step is optional, but it can really help with your iteration times if you have a canned program that exercises the slow path of your program. Now, using this representative benchmark, measure again with a profiler. This is going to give you a baseline to measure your optimizations against. Without a good baseline, you can't tell if the changes you've made things better or worse. So with your baseline, you're ready to optimize. This is where your own intuition comes into play. Your goal is to minimize the amount of time in the hotspots, and there are many different approaches here. You can experiment with reducing the amount of work done, caching results, or using different algorithms entirely. Now that you've made a change that you think will speed your program up, prove it by measuring again and comparing with your baseline. And that way you can say definitively that you've made your program 5% faster, 10% faster, or it's had no effect at all. You repeat this cycle until you're happy with the performance of your program. Before I go, I'd like to leave you with a couple tips on optimizing your Dart programs. In the profiler tree, optimized Dart functions are prefixed with an asterisk. Now, if your hot functions aren't optimized, you've got a problem. You're probably triggering excessive de-optimizations or prohibiting optimizations from occurring in the first place. And you need to understand why that is, because optimized code executes much faster than unoptimized code, and so you want to make sure that your hot functions can and are staying optimized. Now, you can get a high-level idea of how your program is running simply by looking at the VM tags, and there are certain patterns that you should come to expect. For applications which do lots of computation, you should see script very high up there. Now, you're probably allocating too much if GC is high, in which case, hop over to the allocation profiler to help understand what you're allocating so you can minimize that. Now, applications that do lots of file and network I/O should have a hot native tag because the actual I/O is done by calling out to the operating system. So for server applications, you want to see a hot native tag. I'm John McCutcheon, and you just learned about Observatory and the Dart CPU Profiler. You can learn more about Dart and Observatory by following the links on the slide. Thanks for watching.
Hello!
Hi!
Oh, hi! Today we are talking about YouTube and design. You know, YouTube's grown tremendously over the last 9 years and now has a global community of users, and that is a really interesting design problem.
I mean, if you're gonna have a problem, that's a good kind of problem to have, right?
Oh, yes, but it presents a challenge. And that challenge is, how do you design a product that looks and feels consistent when it means something different to everyone who uses it? You know, most brands have a pretty clear idea of how they want to be represented. But at YouTube, our challenge is that YouTube represents everything from delightful and silly content to serious and sensitive stuff.
That sounds like a pretty crazy challenge.
Exactly, exactly.
So why don't we share the story of how we took on that challenge and captured YouTube's brand?
Yes, sounds good to me. Everybody, this is Josh, and he's a product designer at YouTube.
Hi, and this is Michael. He's a marketing designer.
Yes. We work together on YouTube's user experience team. And Josh, let's tell these folks what they can expect in this video.
Sounds like a good plan. So in the next few minutes, we're going to cover a few things. The first is how a traditional style guide can actually be something much, much more than a style guide. The second is understanding your brand's identity through its community of users.
And then we can wrap up with some tips and tricks for how you can use this in your own work.
Cool. So we represent a collaboration between UX design and marketing, and we actually started building a traditional style guide, and then we kind of decided that we needed to do something different, and we ended up with something much, much more useful to our team. So here's just one page from what the style guide looks like.
Right. The guide we created lets teams at YouTube jam together on product design and content creation by speaking a common language. We can't go through the entire resource in this video, but we're going to share some of the content and process that went into turning YouTube style guide into a thought guide.
A thought guide? What's a thought guide?
Well, what do you think I'm thinking right now?
What are you thinking right now?
Yeah.
I think you're thinking that when YouTube first started, it was a video dating site. Am I right?
Yes, you are right, and
All
that
right.
blows my mind every time. I love it. Good job.
Yeah, so since then, the site has evolved into an entire service, a huge service, and the video content on the service has grown up too.
YouTube is a platform for community movements like It Gets Better Project, memes like the Harlem Shake, and serious subjects like political uprisings captured on mobile phones.
And obviously YouTube gets all of its content from its users, so that means that our users are kind of designing our product with us. So why wouldn't our style guide actually reflect that?
Exactly what I was thinking. So we think it's way cooler to design with our community than for our community. I mean, not that we're not designing for our users, we are, but I mean, you know, like with them, like we feel like family, like the Brady Bunch.
Yeah, but that kind of presents a second question, doesn't it? Like, who makes up YouTube's community?
Well, you might think it's just people watching videos, but it's more complex than that.
So complex, actually, that we spent about a year doing research with users to learn how they interact with and relate to YouTube's brand.
Yes, here's some of that research. Here's a page from a diary study, and that looks like somebody using their tablet on the toilet. Is that accurate?
I am afraid it is.
Well, that's fantastic because we can use that. We like data. You know, sometimes research and analytics are used to solve a really specific problem, like how to improve task completion or click-through rates.
We were actually curious about larger communities and their needs on our platform, not just a specific persona and not just the people that are watching videos. So going back to that question, like who really is everyone on YouTube?
Right. The YouTube community is really complex and diverse. There's a lot of people viewing videos, but that's not everyone. You know, there's also people making really interesting content, creating original videos, vlogs, shows, music, all of that stuff.
Yeah, and actually another thing that we found interesting is that advertisers were uploading amazing content and collaborating with our creators to make commercials and ads that people really loved to watch and actually wanted to share.
Right, so the research and digging into experiments, data, and YouTube's history revealed that there's real tribes of people collaborating on the platform. And that information is so much more interesting and valuable than it is for us to invent personas or to design for just one kind of user.
Yeah, so a style guide is usually there to document a brand in one direction. It's like a photo from one perspective. And we wanted something a little bit more dynamic, something that was more like a mirror that reflected principles back on the community.
Right, so if we had a mirror like that, we could use it to determine the success of our design solutions or campaign creative, the new metric being authenticity.
And it was that idea that started to turn our style guide into more of a thought guide. And it began by curating words that described our brand that would reflect the personality of YouTube's tribes, and then it actually guided product design, and it also helped craft marketing efforts.
Yes, the words. The words are connected, human, spirited, and simple.
Awesome, words!
Woohoo!
Words!
Words.
So we have these words, what do we do with these words?
Right, okay, so words are good, they're well-meaning words, but we need actionable principles, right, that we can actually work with. So let's take connected as an example. We've identified our tribes, right, creators, advertisers, viewers, and individually on connected, they're just floating out there in space like little stars. But say we do something, right, we create a product or an experience, and we try to solve two of their needs and connect those groups. Well, that's great, because now we've got a line, and that's good, right? But you still got one kind of floating out there.
But what if we actually connected all three and we made a constellation, which conveniently looks like a play button, right? Gorgeous. Whenever you have 3 points connected, connecting your community together, you can actually triangulate your position, you know where you are, you know who you are, and you kind of know where you're going to go next.
Yes, exactly. And you know, chances are if you've done all those and you've connected them, you're probably making work that meets the needs of more user tribes, and that's a good thing. So we shifted the way that we evaluate our work by adding the metric of connectedness too. So we aim for beautiful constellations, not just solutions that serve one group, you know?
Yeah.
The more the merrier.
Yeah, and I think if we look back, this principle is actually happening already on YouTube. We had lots of advertisers that were already working with creators to create great commercials and ads for users. So a lot of this was already happening, and all we did on our end was we started observing this, and then we assembled a team of designers from product and marketing all together, and we started to think about the brand voice end to end on YouTube and came up with those words.
Yes. And those words, again, connected, human, spirited, simple, they became principles that helped us create a common language. That was the real thing that evolved, a common language for product and marketing to collaborate together.
Yeah.
So let's look at some of the ways we work to deliver on those attributes and principles. What comes to mind is the YouTube Music Awards. That's in a way that we ran with the idea of connected, right? So we streamed a live event from Seoul, Moscow, London, Rio, New York, so that the entire world could celebrate music on YouTube at the same time.
Very cool. And actually on the product side, I think I have a good example of connected.
Oh, all right, let me hear it.
So we discovered that creators really wanted to connect more with their viewers, and we built this tool that lets those creators see who their top fans are, and now they can actually reach out to their most engaged subscribers and start a conversation with them, or just say thanks.
I love that, like humans connecting with other humans.
Yeah,
Speaking of human, let's talk about LGBT creators on YouTube who made it a safe space to come out and speak their minds. We thought that was so awesome that we wanted to make a video celebrating their work in those moments. So we did, and then we asked people in that video to upload their own and join in using the hashtag #ProudToLove. And they did. It was an awesome response, and so nice to connect with the community in that way.
And now there's Proud to Play, right?
Yes, there's Proud to Play too. You can search for that video on YouTube. It's lovely.
Cool.
You know what? Tell them about that secret Harlem Shake Easter egg, because that is a good example of spirited, I think.
Yeah, it's very spirited. So if you go to YouTube and you type in "do the Harlem Shake" into the search field, the site actually does the Harlem Shake. It's pretty cool.
I love that. So this is the still image. You really have to go to the site to try it and see it for yourself. It's awesome. But you know, we wanted to express our spirit just like the original creators of the Harlem Shake and everybody who joined in with them.
Cool. So we also want YouTube to feel simple and easy to use. It's one of our biggest ongoing efforts.
Yep, that is true, and it's one of the hardest. One of the ways we tried to solve that was with an app called YouTube Capture, and it made it a lot simpler to upload videos to YouTube from your iPhone.
I think the original flow took almost a dozen steps, and we were able to reduce it down to just 2 steps and also include editing and enhancement capabilities. That's pretty simple.
Love that. Amazing. Yeah. So I think, you know, when we look back at all these things, one of the things we learned was that no matter what we're doing, whether it's an app or a campaign creative, we can find ways to embody the brand attributes in our work.
And depending on the specific user tribe or the context, we can dial those attributes up or down. So they're really flexible. And I think now is a good time that we show a chart so this presentation actually feels official, right? You have to have a chart.
Yes, that would make this very official. All right, I think we've got a chart and it's called Find the Right Balance. Here it is.
So for a product feature, we look for solutions that feel connected and simple predominantly, and that's the blue and the purple on this chart. And then we throw in a dash of spirited and human. We always have all 4 attributes present.
Yes. So take the marketing campaign. All 4 are present again, but we want like a supersized helping of spirited and human. That's the yellow and the red pieces of the pie. And then connected and simple are there, but they might be side dishes, but they're still at the table.
Right. So these are actionable brand principles. That's awesome. Now, how about, what do you think we should do next?
I think we should wrap this video up with a bulleted list of takeaways.
Oh my gosh, you read my mind. I love bulleted lists, the best way to wrap up a presentation.
Okay.
So when you're designing your own thought guide, here's some things that we learned that we wanted to share with you. The first thing is it's hard to make good decisions with incomplete data or just one kind of persona. So if you can research real users and especially think about entire tribes of users, dig into that and identify your community.
Nice. Love that. All right, so once you've got your community identified, you know, those people are full of passion and personality. So why not look to them to help define your product and your brand?
And next, if you've identified your community, it's way, way, way more fun to design with them instead of just for them. So engage with the tribes on your platform as often as you can. Talk to your users and communities.
Okay, love that. And when it comes to brand attributes, I got a tip for you. You ready?
Yes.
Okay, so it's flex and fit. So choose words that are flexible in their definition, yet specific enough to actually work and be useful. And then once you get them, you can dial them up or dial them down depending on the context of your project or your work or the problem you're trying to solve.
Cool. And last but not least, think principles before pixels. Stay true to your community by turning those brand attributes into actionable principles that you measure all of your design work against. A thought guide can actually help any size company, large or small, with any type of community make better decisions. It's been a huge change for us in how we design and work.
Yeah, definitely. So thank you guys for watching. Thank you for your time. Check out some of the videos we went over and shared today on youtube.com. That's the website. And we hope you have a great, great I.O.
Hello there, my name is Subir and I lead the cloud messaging team at Google. Today I'm going to talk about some of the awesome APIs that Google Cloud Messaging or GCM provides. GCM provides a rich set of APIs to send messages from a server to an application efficiently and reliably. I want to thank all the developers using Google Cloud Messaging because it really helps the ecosystem by minimizing the impact your application has on battery life, radio wake-ups, and network signaling. Let's quickly look at some of the APIs required to use GCM. To use GCM, an application needs a registration ID. Use this registration ID to send messages to a particular device. Multicast lets you send messages to up to 1,000 recipients with a single request. And you can set time to live on each request to tell GCM when to expire the message. So what's new in 2014? Today I'll cover 3 key features that GCM provides: XMPP-based Cloud Connection Server, upstream messaging, and user notifications. In 2013, we opened these APIs to a limited set of developers. Since then, we've added a bunch of new features with these APIs and made them faster and more robust. We saw a tremendous response and interest from developers around these APIs, and I'm really excited to announce that these services are now open for all developers. Let's talk about GCM's XMPP endpoint, also known as Cloud Connection Server. Cloud Connection Server, or CCS, provides a persistent, asynchronous, bidirectional connection to our GCM servers. This is a very powerful service, as it provides a virtual connection between your server and your user's GCM-connected devices. This connection can be used to reliably send and receive messages. Here's how you can connect to CCS. I'm using a simple XMPP library in Python to connect to CCS. As you can see, gcm.googleapis.com is the URL, and 5235 is the port. You simply need to connect to this endpoint and authenticate using your project's API key. Next step is to start sending messages. These messages include a JSON payload that contains the target, application data, and a message ID. Since sending via XMPP is asynchronous, this ID uniquely identifies an XMPP connection. So when CCS sends an ACK back to your server, it will use this message ID to identify the message. Therefore, it is important that this message ID is not only unique, but also present in the request. Let's take a look at what an ACK or an ACK for this message looks like. Message type would indicate an ACK or an ACK. In case of an ACK, there is an error code to describe what went wrong. So when you're implementing a CCS connection, here is what you need to know. We allow a maximum of 100 connections per sender, and the maximum outstanding messages per connection is also 100. Our improved error handling lets you know more precisely what went wrong. Here's an example of a control message describing that a connection is draining. What this message means is that the sender should not send any more messages on this connection. Any new messages on this connection will get back a NAC with an error code indicating that the connection is draining. We have also added new codes for other types of errors like JSON parsing, etc. So what we learned so far is that with XMPP endpoint, GCM provides the ability to have a persistent bidirectional connection to your servers. We also saw how to send messages down to a device using this connection. Next, we will take a look at our awesome upstream messaging API that lets you send messages from the application on a device to your server. We have made a lot of changes to make upstream messaging fast and reliable, and I'm happy to say that it's now open to all developers. So let's take a look. Since the connection between the device and GCM already exists, it's a low latency send as no new handshake is needed. These messages are saved locally if the device is offline and are sent when we have a connection. We use the same reliable message queue technology that we use for downstream messages. So if we lose a connection to your server, we will deliver the messages once the connection is reestablished. We will delete your messages once we get an ACK from your server. In order to receive an upstream message, your server should be connected to CCS. Here's an example on how to send an upstream message using Google Cloud Messaging APIs. Just set the project ID as a destination, and we will deliver the message to your server. You can also set time to live in the API call. This is what an ACK looks like. Once again, since the response is asynchronous, message ID is used to identify the message. Here are some things to keep in mind when using upstream messaging. No pending messages on a connection more than 100. We will delete your upstream messages if your server fails to connect for more than 24 hours. We will also allow a maximum of 20 unacked upstream messages from a single device, so ACKing is required. And similar to downstream messages, the maximum payload size allowed for upstream is 4K. Okay, here is one of my favorite new APIs in GCM, delivery receipts. When sending messages to a device, a common request from developers is to get more insight into the state of the message and to know if the message was delivered. For example, you are writing a messaging app and would like to show your sender if their message was delivered. With CCS, you can do that now. We are adding this new feature called delivery receipts. Here is an example on how you can request a receipt for a message. In the JSON payload of the message, you just set the new field delivery receipt requested to true. By default, the value is false. Here is a receipt message. This message will have a new message ID. From will be set to gcm.googleapis.com and type as receipt. There are 4 fields that we add in the response data: message status, original message ID, time of send, and the registration ID of the original message. Nowadays, users have multiple devices and hence receive notifications multiple times. This can reduce notifications from a useful feature to an annoyance. Thankfully, GCM provides a convenient way called user notifications to reach all devices for a user and help you synchronize notifications, including dismissals. I'll talk more about dismissals in a bit. With user notifications, you can target all devices belonging to a user with a single request. This is a very powerful API and allows you to be smarter about your notifications. I'll give you a couple of examples. You can set a short TTL so the notification will only be sent to a device that is currently connected. Another example is to use option of delay while idle. Imagine your user has a phone that they use all day and a tablet that sits idle at home. By setting the delay while idle and a TTL, you can send the notification only to the phone that is actively used. Pretty useful, right? To send messages to all devices for a user, you need a notification key. The application server can get a key by adding or removing registration to the notification key name. Let's see how you can get a notification key. Here is the endpoint to get a key and the HTTP header. The request is authenticated using your project's API key. So first time you add a registration to a notification key, you can do a create. And then if a user installs the app on another device, you can use an add. An important field is the notification key name. For us, it's just a unique identifier that you use to identify this user. The actual username is not relevant, so please use a hash. It needs to be unique for a user. Here's an example on how you can send a message to all devices for a user. The only difference is that instead of sending a message to a registration ID, we now send it to a notification key. Now let's assume a user on one device acts on the notification, and we want to dismiss this from all other devices. How do we do it? With upstream messaging, we can send a message to a notification key, and GCM will deliver the message to all other registrations in this key. This way, you can tell other devices to dismiss a notification as it is already handled on one device. In addition, you can also send this message to your application server by sending it to a project ID in a separate upstream message. Here's an example. As you can see, the to field in the upstream message is set to a notification key. This will make GCM send this message to all other devices that are part of this key. User notifications is available on both HTTP and XMPP. It allows a max of 20 registrations per notification key. And of course, the key name in the request should be unique to a user. Before we end, I'd like you to please check out our updated documentation for all GCM APIs and services. As always, it's available at this link here. Thank you for watching, and I hope you are excited to use these new APIs and services and enjoyed this video.
Mobile developers and designers use different approaches to achieve the same goal. creating 5-star apps that users love. While both development and design approaches are essential, they are usually considered separately. In User Experience Design for Mobile Developers, you'll learn how to integrate design approaches and techniques into your mobile development to build world-class apps. This is a design course for developers who want to give their users a great experience. For more information, visit udacity.com/Google.
Hi, this is Amin from the Glass team, and I'm going to show you how to create voice-driven GDK glassware. I'll show you the available APIs and how to use each of them. First, let's demonstrate how to get directions on Glass using Google Maps. OK Glass, get directions to San Francisco. OK Glass, show route overview. This glassware uses two voice APIs. First, the Voice Trigger API links the Get Directions to Voice command to the Google Maps navigation activity. Second, the Contextual Voice Menu API defines a custom OK Glass menu within this activity. Let's dive deeper into both of these APIs. To launch your glassware from the Voice Main menu, the first thing you need to do is define a Voice Trigger XML file. This trigger specifies which command launches your glassware, what constraints your activity requires, as well as whether your glassware needs open-ended voice input. Here, navigation trigger.xml uses the Get Directions to command, requires a network connection, and needs open-ended voice input when launching. Next, you'll need to refer to this voice trigger in the activity definition of your Android manifest file. Here's the Android manifest for the Google Maps navigation glassware. You can see that the navigation activity references the navigation trigger resource we just defined in its metadata section. And that's it! The next time you install your APK, you'll be able to launch your glassware from both the voice and touch main menus from the home screen. Now we'll move on to contextual voice menus. Adding this menu to your activity is straightforward, especially if you are familiar with how Android menus work. The in-app OK Glass menu is a window feature. When you request this window feature, the Glass platform takes care of enabling voice recognition and showing the OK Glass guard phrase on the screen. When voice commands are triggered, the platform then calls menu-specific methods on your activity. Just like standard Android menus, voice menus can also be inflated from XML. Here, navigation trigger activity inflates the voice menu XML in onCreatePanel menu and then handles voice commands and on-menu items selected. In addition to these two Glass-specific APIs, GDK Glassware can also use the Recognizer Intent and Speech Recognizer APIs from the Android SDK to collect open-ended voice input from the user at any time. With Recognizer Intent, you can launch an activity in the Glass platform that prompts the user for open-ended input. This activity will look and feel just like other open-ended UIs you've seen on Glass. Here, main activity launches a recognizer intent and then processes the recognized text in on-activity result. If you want even more control over voice input, you can work directly with the voice recognition service via the Speech Recognizer API. Your glassware can define a recognition listener that will receive transcription results in real time while the user is speaking. Here, main activity creates a speech recognizer and implements some of the callback methods of recognition listener. With these Android APIs allowing fine-grained control over voice input, along with the Glass-specific invocation and contextual APIs, you can create a compelling, voice-driven experience to power your GDK glassware. To find out more, make sure to visit our website and check out the Google Developers YouTube channel for more Glass videos. Thank you for watching.
Are we on? We're on? Okay. Well, hi. Hi. I'm Pete Monster, a developer advocate at Google, and I think the internet is for forms! Forms are a pain to fill out, especially on mobile. Keyboards are small, you have to switch between them, monsters are impatient, and with our furry thumbs, it's hard to hit the right key. It isn't a surprise that almost 97% of mobile shopping carts are abandoned. I've got a few tips to improve your forms, reducing the pain for your monsters and increasing the chances that they'll get it right. Take the pain out of forms by reducing the number of questions that you ask and be sure to label and name your inputs properly. Use the label element to provide direction to monsters, telling them what information is needed. Each label is associated with an input by placing it inside the label element or by using the for attribute. Using labels also helps to improve touch target sizes. Monsters can either touch the label or the input and immediately start typing. Yay! Placeholders give hints about the expected input. Adding a placeholder attribute will display its value as light text until the element gets focus. Best of all, it's all done auto-magically by the browser with no extra JavaScript required. Yay! But you know what's even better than an input with a large tap target? Well, do you? Tell me. I'm waiting. Still waiting. Okay, fine. I'll tell you. Having the browser do it for you. Yay! Don't use random values for input names or IDs. Instead, use standard naming conventions. For example, want the monster's first name? Name the input fname. In cases where the browser can't fill it in auto-magically, that makes monster mad. Tell the browser which keyboard will be the most useful by using the correct input type. These new input types give hints to the browser about what type of keyboard layout to use. That makes it easier to enter information without having to change the keyboard, and monsters only see the appropriate keys for that input type. Monsters and humans love feedback, so keep them up to date as they fill the form in. And before they submit it, make sure everything is A-OK. Don't make them wait until the form has been submitted to tell them they forgot something. Tell them right away. There are several attributes that you can use to provide monster-side validation. The pattern attribute specifies a regular expression used to validate an input field. If the required attribute is present, then the field must contain a value before the form can be submitted. For numeric input types like numbers, ranges, dates, times, you can specify the minimum and maximum values, as well as how much they should each increment or decrement as they're adjusted by the sliders or spinners. The max length attribute can be used to specify the maximum input length and is useful when you want to limit the length of information provided by the monster. But when built-in validation and regular expressions aren't enough, you can use the Constraint Validation API, a powerful tool for handling custom validation. To make sure the form is valid before it's submitted, catch the submit event and then use the check validity function to make sure that everything is A-OK. If not, prevent the form from being submitted and tell the monster about all the problems. Otherwise, submit away. Yay! The best forms have the fewest inputs, are easy to understand, have large tap targets, use the right keyboards, and give monsters lots of feedback. Do your forms follow all these best practices? If not, get on it. And once you've done that, check out this other video on how Request Autocomplete can help eliminate checkout forms completely. Thanks for watching. Bye! Are we off? Are we done yet? Why are you still watching? I'm done. I don't have anything more to say. Honest. You can go now. This isn't like one of those movies where there's a surprise ending. We're done. Okay, I'm just gonna leave now. See ya.
In the last few years, we've seen a staggering increase in video consumption, while worldwide internet bandwidth hasn't kept the same pace. My name is Ranganathan, and I'm here to talk to you about how the WebM project is solving this problem today. Video accounts for over 50% of the peak internet bandwidth and over 2/3 in certain parts of the world, and it's growing fast. The WebM project is a collection of open source media codecs and technologies aimed to address this problem. How well does this work? VP9 can halve the bitrate compared to H.264 for the same quality settings. This has massive implications for the web, especially YouTube, who now serve billions of VP9 playbacks to their users. This is because YouTube is seeing both a decrease in average bit rates and an improvement in quality over 264. So what does this mean to YouTube customers? VP9 provides a better streaming experience, reducing rebuffers by 25% in developed markets and a whopping 100% in emerging markets. This means videos to more places. In fact, because of VP9, we are able to serve an additional 25% of videos in HD worldwide, and they load 15% faster, which you will notice is giving YouTube the ability to add a checkbox to stream 4K videos. And the truth is, working at YouTube scale has allowed us to dramatically improve VP9 in this past year. For starters, we've improved the encoding speed by 40x. To meet the demands of YouTube, we've added 3 new controls to the encoding process. The first is variable bitrate, controlled by the target bitrate parameter, allows you to hit specific bitrate values. Constant quality, controlled with the CQ level parameter, allows you to hit specific quality values for your encode, while the constrained quality is a hybrid mode that allows you to balance between the two, allowing you to conserve bitrate after hitting a quality goal. To provide even more control of your encodes, especially trade-off between computational complexity and compression efficiency, you can use the CPU speed parameter to navigate. We are also providing an additional trade-off point between speed and encodes with a functional 1-pass encode option. Quality-wise, this is usually within a few percentage points of a 2-pass encode with similar settings. Next up, VP9 has 3 adaptive quantization experiments to adjust bit expenditure within a frame to give better psycho-visual quality. If you look in more detail at the large 64 by 64 blocks in the top center, at a fixed quantization, we're spending only a few bits for the whole region. In contrast, for some of the regions down on the tracks, we're spending several thousand bits. The AQ modes try and correct the balance a little by reducing expenditure in these expensive areas, while where taking a few bits won't visually hurt much, and increasing the expenditure in the easy sections like the sky and hillside, and can overall improve the visual quality. Now, these are set using the AQ mode command line parameter, and for more information on how to control adaptive quantization, check out webmproject.org. Now, video on demand is a significant proportion of the video on the internet, but real-time communication and screen sharing are very important to us as well. I'm happy to announce that VP9 now has a functioning real-time encode option for video conferencing and screen sharing. At the start of the year, measured against speed -5 of VP8 for HD content, VP9 encode was 25 times too slow. With the addition of a non-RD path and many other optimizations, this is now down to about 2x, but delivering about 40% compression gains, or about 1.4x, delivering about 20% compression gains. Now, real-time enables screen sharing applications to use VP9. However, screen sharing requires high-fidelity text and color space rendering. Towards this, we are also announcing experimental support for 444 and 422 color profiles to VP9. Now, we heard you loud and clear that you needed simpler tools to encode videos into WebM. So we announced a few open source tools to make these processes better. Check out Demystifying WebM Encodes and Decodes for tips, tricks, and tools to encode and playback WebM files. The team has been hard at work making decode better, especially on mobile, with a strong focus on multi-core performance and improvements to battery life. We've made VP9 decode over 7 times faster since June 2013. In fact, we can do consistent, continuous 1080p playback on your Nexus 5. And over 10 companies have licensed the VP9 RTL for adding fixed function hardware decode, including MediaTek and NVIDIA. Now, this means that you have low power 2160p, 60 frames per second decode in devices in 2015. Finally, we began work on a new high bit depth profile for VP9, which will support both 10-bit and 12-bit video. You can follow its progress on webmproject.org, and we are doing this work in 2 phases. In the first phase, all internal buffers will be upgraded to 16 bits along with all filtering. but your input and output would still be 8 bits. With the higher internal precision, we expect some huge coding gains. In the second phase, we will increase the precision of the transform coefficients to add extra 2 or 4 bits of precision and make other changes as appropriate for the bitstream syntax. We anticipate that work on the HBD profile will be concluded by the fall of 2014. Now, we worked very hard to make VP9 an open project and to help you provide a great video experience through the web across many of these devices. Now it's your turn to start telling great video stories on the internet. For more information on creating and playing back WebM videos, check out Demystifying WebM Encodes and Decodes, and as always, we are here to help.
It's undeniable. Website speed is a feature. Web performance optimization, developed with Google, explores performance patterns for world-class site speed. Dive into the critical rendering path, uncovering how browsers convert HTML, CSS, and JavaScript into actual pixels on the screen. You'll learn how to leverage recommendations from PageSpeed Insights and data from Google Chrome's developer tools to immediately boost website performance. For more information, visit udacity.com/Google.
Hello, I'm Jake Archibald, off of the Chrome Developer Relations team, and I want to show you something pretty incredible. Now don't adjust your set. What we're looking at here is the browser establishing a connection. It's an incredible feat of technology. Data is being sent through the air, despite low signal, then through cabling to the other side of the world. And yep, here comes the response, making that final leap through the air. Oh, it didn't work. Network connectivity is a single point of failure when it comes to user experience on the web. When connectivity is bad, user experience is bad. When connectivity is gone, user experience is gone. Native apps can overcome this. Well-built native apps get cache stuff on the screen straight away, and then they go to the network. And if that fails, sometimes they don't even need to tell the user something went wrong. This pattern is offline first, and I want to tell you about a new API that brings it to the web.
Isn't that what app cache is for?
Yes, good point. Thanks, Paul. App cache did try and fix this problem. It used a This is your bit done. You're good now. You can go. It used a manifest format that was really simple, but resulted in complex changes to the networking and caching behavior of your pages. Well, I say complex. As developers, we deal with complex code all the time, but in App Cache's case, it feels like magic, because there's little to link the lines in the manifest to the bits of this behavior it triggers. The specific problems with App Cache are pretty well documented, but here's a quick recap. Well, we should all be on the same page now, but it's a shame about App Cache, because there's some powerful stuff in there. Caching, routing, updating, offline first, online first, handling failure. But those tools can only be used in very particular ways. There's no expression of intent in the manifest. This makes it really easy to be caught out by unexpected behavior, and your only line of defense is to read the spec. Read it until your eyes bleed, and then wipe the blood from your eyes and read the spec again. The solution to this is the service worker. This is a new spec developed by Google, Mozilla, Samsung, and others. There's the spec. You can see why I went for the fireworks instead. But the service worker breaks App Cache down into a set of primitives that you can reason about and use independently, and no behaviors change until you change them using JavaScript. Google and Mozilla are aggressively working on implementations of Service Worker. Some of the things I cover may be buggy or not yet implemented. Check out this site for the current status in each browser. Right, let's take a look at a real-world use case. This is Trained to Frill, a simple website I threw together. It delivers you the very latest in hot railway action straight from Flickr. I'm going to add it to my home screen because it feels like the kind of thing I might need urgent access to, and it gives it that native app feel. It's all on GitHub, so you can check out and run the final implementation. I don't know why I made something about trains. It just came to me as I was standing outside admiring some trees. Unfortunately, this is our current offline experience. Things are great online, but without a connection, we get total failure. Let's do something about that. In our site's code, we'll register for a service worker. I'm using feature detection here so I don't get errors in browsers that don't yet support service workers. This is the URL to the script that will control our pages, and this is the range of pages it will control. Register returns a promise, so you can call .then and pass in success and failure callbacks. Promises are a really powerful way to control async operations. To learn more about promises, check out this article on HTML5 Rocks. Because of the control you get with a service worker, you can only register for them on pages that are served over HTTPS. GitHub does this, so it's a great place to host experiments and little apps. So what happens to sw.js? Well, it runs in a different thread and it has no DOM access. It's a place we can run code outside of pages and control their loading. One service worker can control many pages. You can think of it as like a proxy server sitting on the client, able to reroute requests or satisfy them from its own cache. Let's do some of that. The first thing we care about is the install event. This fires when the browser sees this version of the service worker for the first time. Passing a promise to wait until defines the length of the installation process. If the promise rejects, the install fails and this worker won't do anything else. If that happens, don't worry about it. You'll get another shot at it next time you call serviceworker.register. We're going to use the install event to cache everything we need to load the page. Cache is a new storage API provided by the service worker. It's basically a programmable HTTP cache, but things never expire. They're only gone when you remove them. We'll create a new cache and add it to the caches object to give it persistence. The caches object is a global within service worker. Then we'll add items to the cache, everything we need to load the site. These methods return promises, so they can be used to feed wait until. If any of these things fail to cache, the promise rejects and the install fails. So if the install succeeds, we know we have all of these items in the cache. Although we've cached a load of stuff, the browser won't use any of it until we tell it to. You can listen for the fetch event. This fires for every page request within the service worker's scope, but also for requests made by those pages, even if they're to other domains. You get a lot of information about the request, such as URL, method, headers. However, the most interesting bit is you can hijack the event and respond to the request yourself. Respond with takes a response object or a promise for a response. You could create the response yourself from scratch using the response constructor, but it just so happens we've got a cache full of stuff we can use. Caches.match takes a request and gives us a promise for a response that matches the request. The matching is done by URL, method, and vary headers, just like the HTTP cache. Let's see how that runs. Oh, we've broken it. See, connectivity derailed because it's trains. Even with full connectivity, it's broken. In fact, if we take connectivity away, we get exactly the same result. Our page is working offline, but all communication with Flickr is failing, even online. This is because our request to Flickr, like all in-page requests, hit the fetch event. Then it tries to get a response from the cache, doesn't find one, the promise rejects, and we get back what looks like a connection failure. You see, we've told it to satisfy all requests from the cache, and we didn't cache anything from Flickr. Thankfully, promises let us recover from this. If our cache lookup fails, we can use event.default, which goes to the network to fetch the resource. That might fail as well, of course, in which case we can catch again and serve a fallback. And that will never fail because we depended on fallback.html in our install step. Now everything works again, well, as long as you've got a connection. If we disable connectivity, we're back here. So we're pretty close. We just have to cater for Flickr's absence when we're offline. But to do that, before we do that, let's take a step back. This is what we have so far, and it just so happens that we're still roughly within AppCache's capabilities. But to do this in AppCache, our manifest would look like this. It looks a lot simpler, but it's not actually simpler. It's just fewer characters. This doesn't involve us in all the behaviors it's created, the caching, the routing, the fallbacks. If this service worker does something we don't expect, if it behaves in a way we don't understand, what can we do? Well, it's JavaScript. We can use console.log, we can open DevTools, set breakpoints, see the state of everything as it goes through the worker. If this does something we don't expect, and it probably will, we're back to reading the spec again, crying blood. But enough about AppCache. Let's do something it can't. Let's make that Flickr data and imagery work offline. Here's what our page is currently doing. We request photo data from Flickr, and if that works, we update the page with that data. Otherwise, we show an error. Either way, we stop that spinner spinning around. We want this to work without a connection, which obviously means caching Flickr's API response and images. However, if the user's online, we want them to get the very latest locomotive delights Flickr has to offer. It's tempting then to go for something like this, where we try to get trained photo data online, and if that fails, we go for the cache stuff. For some apps, this is the best approach, but it's not good enough for our trains. You see, this works fine when you're in a big city with full signal. Stuff arrives fast. It works fine when you're on the underground with no signal. In fact, it's even faster than before because we fail straight away and go straight to the cache. This is the problem case. Your phone sorta, kinda maybe has a connection, possibly. It'll either take ages to get the data or take ages to decide it can't. In fact, signal bars aren't even a good predictor of this behavior. We can have full signal, but we're still beholden to all of the internet pipes that sit between us and Flickr. Prediction is really inaccurate when it comes to the network. Take navigator.online, which is available within service workers as well as pages, but it's not all that useful. You see, it tries to be predictive. When you have absolutely no connectivity, it will be false. When you have some connectivity, it will be true. Even if the router you're connected to is just plugged into some soil, it'll be true. Network prediction is flawed. Be wary of it. With this code, the network needs to succeed or fail before we do anything. Instead, let's get stuff from the cache straight away and then go to the network. This isn't a revolutionary idea. Native apps often do this, but now we can do it on the web. First, we change how we fetch live data slightly. We stop handling errors, and we set a variable to true if and when it completes. And we make this request race with another, one that's only going to go to the cache. It sounds unbelievable that the network might beat the cache, but some virus scanners make disk access like wading through mud, so we should prepare for that. In terms of error handling, we only want to show a connection error if both the cache and the network fail to deliver. If the network fails but the cache delivers, that's okay. We can fail silently. That's a good offline experience in this case. But how do we make one request to the cache and another to the network? Here's how we make a network request. The Flickr search function is just going to use XHR to make a GET request to Flickr. Getting cache data is a little bit different. It fails if Service Worker isn't supported or if there isn't one being used by this page. The Flickr search is almost the same, the only difference is this additional header. It looks like magic, but it isn't. In fact, it doesn't do anything. Yet. But it's something we'll see as part of the request to the Service Worker. And we'll add our own magic in there. Back in the Service Worker, let's do some extra stuff in our fetch listener. If the request URL is to Flickr's API, we'll do something special. If the request URL is to Flickr's image servers, we'll do something else special. First, let's look at how we handle API requests. If the request has that header, the one that we set before, we'll send back a match from the cache only. If there's no match, the request will fail. That's fine, that's exactly what we want. If that header isn't there, we'll create a new cache for our Flickr content and add it to our caches object. Then, we'll pipe the request to our cache, but also back to the browser. The fetch method takes a request and returns a promise for a response. Although we're using this request object twice, the browser is smart enough to only make one request under the hood. This dynamic handling of requests and caches is something AppCache simply cannot do. So that's API requests sorted, but what about the requests to Flickr's image servers? First up, we'll try and serve the images directly from the cache. But if that fails, we'll get hold of our content cache, and we'll add this new image to it, but we'll also respond with it, send it straight back to the browser. This exposes another interesting feature of service workers. Images from Flickr do not have cause headers. You can't fetch them with XHR. Service workers don't have this restriction. You'll get back an opaque response. You can't query its content with JavaScript, but you can add it to caches and use it in responses. And that's it. Now we have an app that loads blindingly fast and updates with the latest content if the user has a connection, but also works entirely without one. They'll just get the last set of images they saw. It's fully offline first. We assume nothing of the network. We render with what we've got, and then we try the network and deal with the outcome. Mission accomplished. And that's just one example. Service Worker gives you the primitives to do what's best for your app. It doesn't force you down a particular path. This is a very new feature, but we're already seeing other specifications extend it to make it even more powerful. For example, background sync. It adds a sync event to service workers. This allows a service worker to spin up even when the user isn't at your site, giving it an opportunity to update caches. Ideal for sending that message that failed to send, or updating a set of train photos from Flickr. And push. Push allows the service worker to spin up in reaction to a server push message. You can use this to update caches and notify the user they have a new message. Or, I don't know, something to do with trains. Anyway, Service Worker isn't limited to trains. Hopefully you've got better ideas. The W3 Web Mobile group are currently compiling examples and they're looking for contributors. If you want to start writing demos or coming up with use cases, this is a great place to do it. Making stuff work offline is just one possibility. You can also use service workers to fine-tune performance or polyfill network APIs such as client hints. If you're building with service workers, remember to use this page to see what's actually working. See what you can build in Chrome today. Of course, there will probably be bugs. Please, file tickets as you find them. Filing bugs and making examples will improve our implementation and steer the direction of the API. We're crazily excited about the performance benefits and new features this brings to the web. Let's build some cool stuff with it. Thanks for listening.
Hi, I'm Shazia Makhdoumi from the Google Play for Education team. I work with developers like yourselves who are building great EDU apps and help them be successful on Android. So you know that idea you have for an amazing educational app, the one that'll change how kids think, empower them to build totally new things, or even revolutionize how a school is structured. I've got some good news about your idea. Its time has come. So in this video, I want to share learnings and best practices from other EDU app developers that'll help you get started on building a great educational app. Today, we're at a disruptive moment in the evolution of education content in school and tools, as you know well. It used to be near impossible for small developers to get an educational app into a school, no matter how amazing or transformative it was. But with the Google Play for Education marketplace, we've actually made it easy to get your app into the hands of educators that want to use it, and for those educators to get into the hands of their students. And for the record, that's a lot of hands we're talking about. Currently, over 30 million teachers and students worldwide use Google Apps for Education, which means that Google can help you have a huge presence. So as you can tell, our team is really excited about this opportunity. But more importantly, educators are really excited about what we're doing with Google Play for Education, especially about the access to enriching content for students, as well as the tools that help them be more productive in the classroom so they can focus on teaching. Google Play for Education already includes thousands of apps, ranging from curriculum supplements to help students learn math and English and science, as well as how to create videos, make a book, annotate notes. Teachers find tools that help them poll students, create presentations, and even manage classroom behavior. So thousands of apps in Google Play for Education means thousands of developers have built great educational apps on Android, and they have a lot of nuggets to share. So what we did was we distilled those into the top 5 tips that developers consider the most important when building an education app. Their experience is your advantage. Tip number 1, users will pay for quality, so get testers to submit ratings and reviews early. One of the primary metrics that users judge an app with is quality, and they use app star rating to measure quality. When the star rating increases, the purchase rate increases. And as you can see, 4-star apps earn almost 3 times what 3-star apps are earning. So to make sure that your app's quality is reflected in this rating, ask early evaluators of your app, especially the educators, to submit their ratings and reviews for it. Teachers really care about what other teachers specifically think about an app, because that is a big factor in their purchase decision. Tip number 2, alpha and beta test groups, as well as stage rollouts, help you collect user feedback quickly. So instead of simply publishing your newest app to the entire world, Google Play allows developers to test the app with small groups of alpha testers or beta testers. And this is a great opportunity for you to get feedback on your app without it affecting its current rating. The folks who built Book Creator invited 20 teachers to try the beta app in the classroom. This gave them early visibility into issues and also allowed them to test on a wide variety of devices but within a classroom environment. And they recommend for paid apps like theirs, create a separate free version just for the beta phase. Why? So that teachers don't have to pay to test your app. Also, consider using staged rollouts in Google Play to gradually push new features and updates to a small percentage of the user base and get their feedback. So if your rating stays the same, great. Roll it out to more users and repeat. But what this does, it helps you catch problems early before they can have a huge impact on your ratings. Tip number 3. We've all heard the expression, you only get one chance to make a first impression. So optimizing for tablets from the start helps you make a good first impression with your users. Given the growth of tablets in schools, it's really important that educational apps work well on tablets, since that directly impacts user experience, which then impacts purchase rates. So friends, StudyBlue, an online flashcard creation app, did not initially test the app on 10-inch devices. And what they found was they had a lot of bugs, especially related to tablet-specific issues around orientation and rotation, and the usability was poor. So now that they know that, they're actually using responsive layout techniques, such as fragments, to build a multi-pane layout for their tablet app, which allows them to make additional use of the additional tablet real estate to minimize the number of screens and also to improve usability. They wish they had known this and done this from the beginning. So learn from their mistake. Use core tablet guidelines early and often. Make sure that your app is optimized for tablets from the start. Tip number 4. Designing for Android allows you actually to stay engaged with users even when the app is not open. So Google Play offers a lot of Android-specific design elements, such as rich notifications and widgets and live wallpapers. And what these do is allows a user to be engaged with your app even without them opening it. It's like unlocking marketing channels for your app, but without spending a dime on expensive marketing. Class Dojo, which is a classroom management app, actually took advantage of notifications for Class Dojo messaging, and they found it increased the number of read messages. And now they're experimenting with Jelly Bean's expanded notifications and actions to make the app even more useful to their core audience, teachers, students, and parents. Similarly, developers at Wunderlist for Education, which is an app for managing to-do lists, integrated location reminders to remind students to do their homework when they're getting home. Not sure how much students like that, but what they had found was reminders help keep the pace of work, and location reminders especially adapt to a student's routine. Tip number 5, something that you probably know, but your app listing is really important, maybe even more important than you realize. Because remember, your app listing is what helps attract users and helps them understand how to use your app. So, create a compelling listing with a clear title and descriptions. Use high-res shots and previews. A picture is worth 1,000 words. Use a great icon, because that's what users will see first and remember about your app. It helps build your brand. But if a picture is worth 1,000 words, a video is actually worth 1,000 screenshots. StudyBlue found using good videos in the listing to demo your app features actually leads to better conversions, since these days users are very attuned to watching videos to learn how an app or a game works. So, where possible, include a video, especially one of your app being used in a classroom setting, because that's what's going to get students and educators excited about your app. Okay, I know I said 5 tips, but I have a bonus tip, or self-evident truth. Be patient and be prepared to dig in for the long haul. And as most of you have probably discovered, the EDU app space is not for the faint of heart. Ignitus, which is an adaptive learning system for kids, cautions that EDU app development needs time and resources and stamina and commitment. Understand your customer, both the one paying for the app as well as the one consuming the app. Understand curriculum, data, and analytics. Think about scalability, both on the data structure side and on the database side. IntelliJoy, a company that makes math and English apps for kids, says to developers, resist the temptation to appify a lot of textbook content. Instead, focus on making a quality app or game, because as tablet penetration ramps up in schools, quality apps will rise to the top. So, building a solid EDU app will take significant planning and multiple types of resources, including education, engineering, domain, and design. But we've given you all this information to make it as easy as possible for you to bring your idea to fruition sooner. So now that you know what to do, what are you waiting for? Get started now. Visit developer.android.com/edu to get more information on the program, as well as access to helpful resources. We're really excited to see how the apps you build will help educators and students and really enable this next generation of learning. Thank you.
Hi, I'm Philip from the Google Chrome Apps team. Chrome apps and extensions use familiar web technologies and can be installed on the desktop or any Chrome OS device. These client apps have access to additional APIs not available to ordinary web pages. A common problem developers face is how to get the latest data from their server to the client app. Say you're building an application to track play-by-play stats for the World Cup. One way to get an update is by polling. Your client can periodically check with the server to get the latest data. But it doesn't know when new data is available, so sometimes it will come back with nothing, while sometimes it will get the update long after the data is actually available. That's not great. It needlessly consumes network bandwidth, runs down the device's battery, and delivers a poor experience to the user who wants the game updates as they happen. Good news! Chrome GCM API allows you to access Google Cloud Messaging Service to solve that problem. So, how can you do it better? You can tell your World Cup Tracker server which clients need to be notified as data becomes available, and use GCM to push that data to the right clients. And how is that done? Through GCM downstream messaging. First, your app registers with GCM, indicating the sender ID of application server from which it wants to receive the messages. It receives a registration ID in return. Next, your application sends the registration ID to the server, followed by information about teams or games the user is interested in. As games progress, your server sends messages with the right registration ID to GCM, and GCM does the rest. Your app or extension does not even need to be running at the time the message is sent, because once the message is received by Chrome, it will start your app and trigger Chrome GCM on message event. That's how you can make sure your users are not going to miss that big game. And if Chrome is offline when your server sends the message, that's not a problem either, because when GCM receives messages from your server, it stores them in a queue. Once the device is back online, GCM delivers the queued messages, and Chrome fires Chrome GCM on message event in your app. If Chrome cannot be reached for a long period of time, the messages could be dropped, either because they exceeded their time to live, or the queue size limit was hit. In the latter case, a special message will be sent to the application, triggering Chrome GCM on messages deleted event to let you know that it happened and allow you to handle that situation. Okay, that's downstream messaging. Now, let's talk about delivering messages from your client app to the server. Without GCM, your client app might be contacting the app server through XML HTTP requests. But if the user doesn't have a network connection at the moment, that request may have to be repeated many times. Again, that's a very inefficient use of resources. Luckily, Chrome GCM API offers the ability to send upstream messages from your app to your application server, using the same cloud messaging infrastructure. If your user wants to follow games of Italy's national team, you can simply call Chrome GCM send function to send a message to the server. The message can contain up to 4 kilobytes of data and must specify the address of the recipient, which should be the sender ID of your application server. Before sending the message to GCM, Chrome stores it locally to make sure it can be retransmitted upon failure, which can happen when the user does not have network access or the connection is spotty. Once Chrome is online, it attempts to send all queued messages. And when GCM server confirms the receipt of a message, Chrome removes it from the local store, while Google Cloud Messaging infrastructure delivers the message to the application server. As a result, you get the same benefits of energy savings and delivery regardless of network connection state at the time of sending, as with downstream messaging. You can find more details on how to configure your server to enable upstream messaging online. Just like with downstream messages, you can make upstream messages more time-sensitive using a time-to-live parameter. For instance, if your user does not get online within a few minutes or hours, Chrome can simply expire and drop the message. Setting time to live for upstream messages has two benefits. It allows you to manage your application's queue size on the Chrome side, and there is a queue size limit, and when delivery times out, Chrome will raise Chrome GCM onSend error event, which will indicate that the message was not delivered, allowing your application to respond accordingly. So this all looks great, but I'm sure you're wondering what's the price. Google doesn't charge anything for GCM, and you can start using it today. To learn more about Chrome GCM API, please check out our documentation page. And remember, Google Cloud Messaging makes building efficient real-time apps a breeze. Give it a try.
Developing scalable apps, developed with Google, is your guide to the most efficient way to build scalable applications on Google App Engine. Learn how to architect and build highly scalable, reliable apps by leveraging Google Cloud Platform. This class covers concepts like platform as a service, infrastructure as a service, data storage, caching, cloud endpoints, and more to help you develop a highly scalable backend that works seamlessly with both web and native mobile apps. For more information, visit udacity.com/Google.
Hi, I'm Pete, a developer advocate at Google. Images play an integral part of almost every web page and often account for the most number of downloaded bytes. I'm going to show you a few techniques that you can use today to serve the right image to the right device on your pages without too much extra work. First, let's take a look at background images served via CSS. One technique that you can easily use today is to combine the background property with media queries for conditional image loading based on screen resolution, viewport size, and more. On the previous example, when the browser width was less than 500 pixels, it only used the image of the phone. But when the window was more than 500 pixels, the media query kicked in, adding an image of New York City to the background, and instead of showing the image of a phone, it showed the image of a tablet. Media queries can also apply styles based on device pixel ratio, making it possible to display different images for 1x and 2x displays. Chrome, Firefox, and Opera all support the standard min-resolution 2dppx syntax. Say that 10 times fast. While Safari and Android browser both require the older vendor prefix syntax without the dppx unit. Remember, these styles are only loaded when the device matches the media query, so you always need to provide a fallback. This ensures that an image is always loaded. Recently, Chrome and Safari both landed the new CSS image set function, making it easy to provide multiple image files. This allows the browser to choose the best image depending on device characteristics. For example, a 2x image for a 2x display, or a 1x image for a 1x display. The syntax is fairly straightforward. A comma-separated list of image declarations, which consists of a URL string followed by an image resolution. Support for the image set function is still new, and for the time being requires the WebKit vendor prefix. In addition to loading the correct image, the browser will scale it accordingly. The browser assumes that 2x images are twice as large as 1x images, and will scale the 2x image so that it appears the right size on screen. Now, for images in markup, there aren't as many options yet. The picture element is coming but hasn't landed. In Safari and Chrome, you can use the new source set attribute. The source set attribute enhances the behavior of the image element, making it easy to provide multiple image files for different device characteristics. The syntax for source set is almost identical to the CSS image set function, taking a comma-separated list of image declarations, which consists of a URL string followed by the image resolution. Because SourceSet simply adds a new attribute to the image element, if a browser doesn't know how to support SourceSet, it simply ignores it and uses the source attribute. That also makes it easy to build a polyfill, and there are plenty available. In some cases, images can be replaced with CSS or other browser capabilities. Rounded corners, gradients, text shadows, box shadows, even reflections can all be done with CSS without the need to download an image. And when someone finally does ship a 16 or 20 or 30 or whatever new display, you won't need to create another new image file. Adding responsive images to your site is easy. For background images, I've shown you how you can use media queries or the recently landed image set function. For images and markup, picture is coming soon, but today you can use the source set attribute, and there are more capabilities coming soon. To learn more about responsive images, check out the Images section on the Web Fundamentals site, or just click on that link on screen. Yeah, that one right there. Perfect. Thanks for watching. Go build something awesome.
Hi, I'm Adi Osmani. I'm a Senior Developer Relations Engineer working on Polymer. Today we're going to take a look at how to save you time building components for the web in fewer lines of code. Before we dive in, let's talk about web components. They're still pretty new to a lot of people, so let's make sure we're all on the same page before we go and build something. Web components are an emerging set of standards that allow you to build new HTML elements. The APIs are template, custom elements, shadow DOM, and HTML imports. Each one of these APIs is useful individually, but when used together, they enable developers to be really productive. So Polymer helps developers stay more productive. What do we mean by productivity? Well, take a component like tabs, a pretty commonplace component on the web. You've probably used a tab component at some point. Writing a tab component on the web has changed over time. Years ago, we started off in markup with a little bit of JavaScript. But since then, we've piled more, and more, and more, and even more of our logic into JavaScript. Maybe this isn't the best approach. Look at the suffering it causes. Perhaps there's a better way of doing this. Using web components with Polymer, we can rewrite those nasty-looking widgets using a custom HTML element, which is much more readable. So here's what tabs would look like if they were just HTML. It's much easier to see what's going on. The code is declarative, it's legible, and it's descriptive. Simple, right? My tabs is just an element, something componentized that's readable, semantic, and describes exactly what it offers. Components are awesome because they force us to think about constructing web apps as a composition of components, rather than a mess of tightly coupled pieces. We're no longer looking at a soup of divs and script. Now this is where Polymer comes in. Polymer is a new type of library for the web that allows you to easily build applications based on web components. It includes a set of polyfills for the native APIs, so you can start using them today. What Polymer really does is it provides a convenient and opinionated layer on top of vanilla web components, with features like two-way data binding, declarative event handlers, property observation, and touch gestures to help you quickly build powerful apps. Great, so let's build a tabs element using Polymer. Let's first take a look at our completed element. Our control is both beautiful and quite functional. We begin building our first element using Seed Element, a boilerplate project providing sample code and structure to help you get off the ground quickly. The boilerplate is available on GitHub at the following link. Great. Once you're on the page for the repository, click the Download Zip button to download the boilerplate to your machine. Next, create a new directory called Development and a subdirectory called My Tabs. Extract the contents of the zip file to your My Tabs folder. Next, we'll rename the files from the boilerplate, replacing seed element with mytabs. It should look like this. So mytabs.css and mytabs.html. Great. Next, let's talk about dependencies for creating our element. So this is Bower. It's a package manager that can be used to install and manage front-end dependencies. Before you can begin working on your element, you'll want to make sure you have Bower installed. Follow the instructions on the Bower site for installing the tool. If you have Node.js installed, this can typically be done by running this command. Bower will install all the different modules we'll need. You can now install the dependencies needed by Untitled Element by running Bower install from the mytabs directory. Navigating back a level, this will add a few dependencies to your development directory. Polymer, the web component polyfills, and one or two others we'll be using for docs. You're now ready to begin working on the mytabs element. So here's what the boilerplate seed element ships with looks right out of the box. For mytabs, we won't directly be using JavaScript, so you can add the no-script attribute to our element. This informs Polymer that we won't want to interact with JavaScript for this particular element. Now, a tab element can actually be built using a number of existing Polymer elements, and this is pretty powerful. You can compose whole elements and apps from elements written by other people. You can find our existing elements over on the Polymer site at the following address. For example, CoreSelector is an element that manages a list of items that can be selected. They can be divs, spans, or something else. Here's a quick example of it in action. You can select items in a list and trigger an active state on them. Magical. So, you can install this element for use in mytabs using the following line. It'll then go and fetch our dependency from Bower. Once installed, you can reference this new import inside of mytabs, so CoreSelector can now be used in this page. Next, inside of your element definition, add the line extends equals CoreSelector. This tells Polymer that you'd like to extend the functionality of the selector element. This lets us get its functionality for free. Quick note, styles defined within your element get scoped, meaning they don't leak into the rest of the page. Shadow DOM lets us let in as much or as little of the outside world as we choose. In this case, our styles are scoped within the confines of the mytabs element. We can use this fact to apply a little bit of Flexbox magic inside our element. Now, we're going to add in one more import called layout.html, which is basically going to allow our element to be a flex container. A flex container is basically an element that might contain children, in our case, tabs, that we'd like to make flexible. One thing the Polymer team believe in this brave new world of web components, is that everything is an element. That's one reason we're implementing these concepts as elements. It's pretty powerful when you're just configuring components using attributes. So going back to mytabs, you want to enable a way to render children of your mytabs element to define individual tabs. So working with these guys, the child elements. Now this is achieved by adding in the shadow tag inside of your template. These represent something called a shadow DOM insertion point. Now, shadow DOM refers to the ability of the browser to include a subtree of DOM elements into the rendering of a document, but not into the main document DOM tree. This provides CSS and DOM encapsulation. Fantastic. So now we have the final version of the code for our custom tab element. Before we can use our new tab element, you'll want to edit demo.html to add in the relevant markup. So let's highlight them. This is what it looks like with mytabs in place, before we've added any actual tabs to our element. Check that any references to seed element now point to mytabs.html instead. Next, we add in the markup for 3 new tabs inside our tabs element. Here, we're just using some simple spans, so each span represents a new tab. Great, so let's see what we've built. Go and run a new preview server at the command line to preview your new custom element, and boom! There we have the mytabs element. It's beautiful and it's functional. You can now reuse this element across pages with encapsulation and clean markup. I've never seen anything that looks so elegant. Now that we've created our My Tabs element, let's deploy it to GitHub Pages so you can share it with your friends. Elements can be shared, but we'll be working with two branches, Master and GitHub Pages. We want to ensure that our master branch contains the bare minimum of code that needs to be consumed by other apps or elements. Now, your GitHub Pages branch should contain a landing page and checked-in dependencies, demos, and documentation. First, create a new repository on GitHub for your element, and push the source for My Tabs to this repository. Navigate back to your development directory from the terminal, and create a new temporary directory and cd into it. Next, grab a copy of Polymer's official helper tools. You can git clone them using the following one-liner. Great. You should now have the tools on your system. Take note of where they've been cloned to. Finally, run the gp.sh script found in the tools directory, passing in your GitHub username and the name of your element. This will create a GH branch on GitHub containing a landing page for your element and a link to a demo for it. It'll also include all of the dependencies needed to preview your element live. Great. So this is where my landing page is now live. And if you've been following along, yours should be live on a very similar address with your username instead of mine. Let's take a closer look at the page. It's pretty. Our landing page can contain examples and a summary of the attributes and events supported by our element. Now, these are all straight from comments in our code. And if your friends click the demo button at the very top, it'll take them straight to your demo page. And there we go, tabs. Our element is both beautiful, functional, and awesome. Hooray! I feel like a real engineer now. Web components with Polymer present an incredibly exciting step forward for reusability. And there's a whole world of elements out there just waiting to be built. To get started, go check out polymerproject.org. Now, go out and help componentize the web today. Thank you.
Have you ever had one of those moments where you're staring at your phone, waiting for a web page to load? You've got full signal and nothing's happening. This kind of sucks, right? I mean, this site could be the best thing ever, but if it takes too long to load, I'm going to get bored and I'm just going to go do something else. Now get this. You have about 1 second before a user starts to get distracted. 1. So what causes a site to have slow load time, and how do you fix it? My name is Matt Gaunt. I'm a developer advocate, and I wanted to talk to you about PageSpeed Insights, a tool which can be used to find issues affecting your site's load time and give you some tips on how you can fix them. So when you visit PageSpeed Insights, you bash in your URL, and it'll give you a score out of 100 and highlight any problem areas with your site. The focus of this tool is to point out issues which, if fixed, would improve your site's overall load time and make your users happier. The big question is, what do you do with this information? Well, the most common problems fall into 3 buckets. First, problems that can be solved with build tools. For example, JavaScript files where you could minify them and send less bytes down the wire. Or merging multiple files, so rather than make 4 requests, you only make 1. The second set of issues are focused on the structure of your page. For instance, where you link to your JavaScript files. And thirdly, problems which need server-side tweaks to enable things like caching of your page assets. Let's start off with looking at build tools. Many of you may already be using some kind of build tool today, but if you aren't, then I recommend checking out Grunt or Gulp.js. These build tools are picking up a lot of steam within the web development community, and they're fairly easy to get to grips with. The main reason you'd want to use a build tool is to automate any set of tasks you're going to run on your project on a regular basis. And most build tools will allow you to pull in third-party modules, which means you get a lot of stuff for free. So let's look at a basic example like JavaScript minification and concatenation. In other words, take some JavaScript files, strip out any white space, replace variable names with shorter ones, and then just squish all the files together. This way, our JavaScript file is smaller, making it faster to download, but the browser also has fewer files to download. To achieve this, you can use the uglify task. You define which files to minify and merge, and it just takes care of it for you. CSS min and HTML min will do the same thing for CSS and HTML. Another common problem area is image optimization. When you run PageSpeed Insights, it looks at your site and basically checks whether any of the images are larger than they need to be. And in the guidelines, it will recommend JPEG Optim, which is a command line tool which strips out any metadata from the image files and can lead to some really impressive reductions in file size. And when I say it strips out metadata, I mean things like which camera was used to take the photo. It's not needed for a browser to render the image, so just get rid of it. So to add this to your build process, use ImageMin for raster images and SVGmin for vectors. An SVGmin will strip out white space and any unnecessary tags and attributes from your SVG files. The second set of problems falls into the category of page structure. Now, I don't know about you, but I've definitely put a JavaScript file in the head of my page before. The problem with this is that the browser will start to parse the document, and as it reads the HTML tag, the head tag, it'll eventually reach your script tag, and this is where you'll see the screen of bad times. Nothing. The reason the page stops rendering is because JavaScript can manipulate the DOM and CSS. So the browser needs to go and fetch the JavaScript from the server and execute it once it's downloaded. This is just in case the script changes the DOM or CSS. And it's only after the JavaScript has finished executing that the page can continue rendering. So to avoid this delay, simply move your JavaScript to the bottom of the body element. This way the browser can parse and render the page up to this point, and then it will handle fetching the JavaScript at the very end. An alternative and slightly more performant technique is to use the async attribute. Now what async does is it tells the browser to download and execute the JavaScript asynchronously, avoiding the render block. The reason it's slightly more performant is the browser doesn't need to wait on the DOM and CSS to be loaded before it can execute the JavaScript. But you need to be careful, because it means you can't rely on the DOM, CSS, or any other JavaScript file to be loaded by the time your JavaScript actually executes. Essentially, it might require you to think a little differently to how you use JavaScript, depending on what you're doing. The second page structure woe is CSS. When we add a CSS link tag, the rendering of the page will block much like it did with JavaScript. We'll see it step through the HTML tag, into the head, reach the CSS, and boom, we'll hit the sad screen of nothing. The browser has no choice but to do this. It has to download the CSS before it can style anything. Otherwise, the user would see unstyled content followed by just a flash of all the CSS as it's loaded and everything is styled. The fix for this can be quite involved, and there's a lot of caveats, each with their own pros and cons. If you have a relatively small amount of CSS for a page, you can inline it directly into the HTML, removing any request for a CSS file and allowing the page to be rendered as soon as the HTML is loaded. If you have a large amount of CSS, however, you could inline just the above the fold CSS so the browser can render the most important content, and then load the rest of your CSS using JavaScript. The obvious downside of this approach is that it requires JavaScript, meaning if it's switched off, you won't get the additional styles. With both inlining techniques, you also lose the ability to cache the CSS files, which could be a big loss if you have styles shared across multiple pages. In which case, it might be worth splitting out the styles to CSS files so you can cache them and inlining any unique styles for each page. Ultimately, test it and see what works best for your site. The final element of the page load gotchas is server-side tweaks. Jumping straight in, let's look at caching. When the browser makes a request for a file from your server, it should always return a cache control max age header. This is what tells the browser to cache a file and for how long, meaning the next time your user visits your page and it needs a file, it doesn't need to download it again. It's just good to go from the cache. When it comes to caching, there are a few things you need to ask yourself. First, how long can I cache my files for? Second, how do I actually get my server to return this cache control max age header? And thirdly, what do I do when I need to change a file? Answering the first question of how long do I cache my files for, I personally found HTML5 boilerplate to be a good source of guidance. If you look at HTML5 boilerplate's HD access file, there are a number of caching rules defining the caching period depending on the type of file. Here's a snippet of the file. We've got CSS and JavaScript cached for a year, images are cached for a month, and HTML isn't cached at all. Now this is just a guideline. You may want to cache your images for a year, you may want to cache your HTML for 30 minutes to an hour, just so that any user hopping backwards and forwards between pages gets a smooth experience. If you're using Apache to host your site, then you can just use this htaccess file to implement the caching rules. If you're using a different server, then check out the documentation on how you can add these headers. Now chances are you're going to want to change some of these files before the cache expires, in which case consider adding a build step to revision your file names. This way there won't be any issue with older versions of files being used. FileRev is an example task designed specifically for this use case and can even be used with other modules to replace file names in your HTML and CSS, so it's pointing to the revision file. The final thing to enable on your server is gzip. If you've not come across this before, it's supported by all browsers and it's an incredibly powerful tool for compressing any text-based assets. There are some huge wins to be had with compression rates of up to 80%. Now, how you enable this will depend on your server, but the gains are big for a relatively small amount of work. I recently got this working on my Nginx server, and it was as simple as just adding gzip on. So those are the three most common problem areas raised by PageSpeed Insights: build time fixes, page structure, and server-side tweaks. Now these aren't the only tools to help with performance. So if you're looking for more tips or just curious about what other tools exist, I strongly recommend checking out this blog post by Adi Osmani. It includes many of the tools mentioned in this video in much more detail. Hopefully this has been a useful insight into how you can improve your site's load time performance, and I challenge you to get 100 points on your PageSpeed score. Cheers.
Learning to develop on Android is much more than learning APIs or shortcuts. It's training your brain to think like a mobile developer. Android Fundamentals, developed with Google, tells the story of Android's history while you build a real app, exposing you to current APIs and battlefield experience that will help you think and code like a seasoned Android developer. For more information, visit udacity.com/Google.
Hi, I'm Matt Gaunt, a developer advocate here at Google. And in this video, we'll catch a glimpse of an undulating monkey, have some crazy robot talk, and I even get to take a trip to Hawaii, all thanks to the latest web view in Android. When we released KitKat, the web view changed from being based on WebKit to being Chromium based. Initially, this was version M30 of Chrome, and the big win with this release was support for DevTools. In KitKat MR2, we updated the web view from M30 to M33, meaning it came with all the usual security and bug fixes that you'd get in a new version of Chrome. The WebView team also worked on improving the canvas performance and added support for screencasting and DevTools. Now, with the developer preview of L, we're updating the WebView to M36 and enabling some additional web platform features. If you haven't already tried using DevTools to debug your web views, you need to go and add this line of code into your app right now. Calling set web contents debugging enabled to true, you'll actually enable DevTools debugging. And I admit that is quite a mouthful. You can enable this just for debug builds or for release builds. It's entirely up to you. But once you've enabled it, plug your phone into your computer with a USB cable, open up Chrome on your computer, and go to Chrome Inspect. Here you'll see entries for every single web view inside of your app. And clicking on Inspect will open up DevTools. Now, it's worth mentioning that you should have a desktop version of Chrome equal to or newer than the WebView version. So, for the developer preview of L, you're going to need to use Chrome Beta or Chrome Canary. With DevTools open, you'll have access to DOM and the CSS inside of your web views. Here you can make changes and you'll see them immediately take effect inside of your app. The JavaScript console is useful for viewing console.log messages, as well as manually executing JavaScript inside of your web views. Now, one crazy useful trick I realized is if you've got a JavaScript interface that you're adding into the web view, just so that you can communicate from JavaScript to native, you can actually call those native methods directly from the DevTools console, which makes debugging this bridge logic just a tiny bit easier. The Network tab enables you to view whatever network requests are happening inside of your page. Now, this is useful for anyone who's loading a page on a remote server, so a normal URL. But it's also useful for anyone loading a static web app from the APK. Because if they're making XHR calls, you can actually view the requests and the responses as they all show up in the Network tab. And it's just a little bit easier than logging everything. Then there's the timeline. If you ever notice any jank inside of your web app, this is the place you should go to get an insight into what Chrome is spending its time doing for each frame. Generally, you want to look out for long-running tasks or tasks that are happening repeatedly, and see if there's anything you can do to alleviate the issue. The last thing I wanted to mention on DevTools is screencasting. Screencasting was enabled in KitKat MR2 and above, and it allows you to interact with your web app directly from DevTools. It means that you don't need to switch from your computer to your device. You can just do everything from your computer. Now, a nice side effect of this is, let's say you have a web view that's currently off screen and you're going to animate it in later on. You can actually use the screencasting feature to see what the web view is rendering, even though it's not visible on the screen. I mentioned that the WebView team have been working to improve canvas performance. Here we have some stats from the Velamo benchmark suite. And you can see improvements of around 200 to 350% for these tests. Now let's take a look at some of the new web features we've enabled now, starting with the undulating monkey I promised you at the start. In the developer preview eval, we've added support for WebGL. Here you can see a demo from Paul Lewis, and quite frankly, I love this monkey. Next up is the Web Audio. Web Audio API is an important part for any web-based game, but it also enables you to manipulate sounds, create synths, or play with the microphone input, which is why I can have a crazy robot voice. The final new web feature enabled is WebRTC. You can now use data channels for sharing data, or get user media to access the camera. All of this means I can now do things like this. Hey Sam.
Hey Matt, how's it going? You're in Hawaii?
There we go. We've looked at DevTools, seen a WebGL undulating monkey. I've got to talk like a robot and take a green screen trip to Hawaii. For guides and additional info on the Chrome-based WebView, check out this link. Cheers.
Hi, I'm Pete, a developer advocate at Google. We all know that a snappy website is always a great thing. It means happier users and higher conversions. And fast is especially important on mobile, where everybody's always in a hurry. PageSpeed Insights is an awesome tool that you can use to improve the performance of your site. When you profile a page with PageSpeed Insights, it evaluates the page and gives you a score based on performance and user experience, based on a set of criteria and best practices. For a quick, easy analysis, you can just hit the PageSpeed Insights service by clicking the link on screen. But let's give the Web Fundamentals site a try to see how it works. I'll enter a URL and hit the Analyze button. After a few seconds, PageSpeed reports back its findings. On this page, we scored a 70 out of 100 for speed. Not bad, but there's certainly room for improvement here. It gives us a list of criteria that we should fix. On this page, it recommends that we eliminate the render blocking CSS and scripts. In our case, it's our primary CSS file and a CSS file that loads some specialized fonts. It also tells us that we should check the caching headers on some of our files. It looks like a couple of the files are cached for 60 minutes, and we definitely want to up that number. We had 8 rules pass, there are no redirects, and the page weight has been optimized by turning on compression and minifying the JavaScript, HTML, CSS, and images. The above-the-fold content has been properly prioritized, and the servers are responding quickly. Perfect. We're in a good situation. Now, we get a similar report for the user experience rules. It looks like this page was dinged 2 points because some of the tap targets are a little bit too close together. Otherwise, the page is good. It doesn't use any plugins, the viewport is configured properly, and the content is sized to fit, and all the font sizes are large enough to read. This is great as a manual, one-off analysis, but you can go even deeper. You can integrate PageSpeed Insights directly into your development workflow with the PageSpeed Insights API. It uses a simple REST API that takes 3 parameters: the URL that we want to test, the API key that identifies our project, and oh, by the way, not really my API key, so don't bother trying it, and the strategy, either desktop or mobile, that you want to test against. You can learn about some of the other optional parameters in the documentation. Now, if you don't already have an API key, you'll need to enable the PageSpeed Insights API in the Google Developer Console, and you can get your key there. The PageSpeed Insights API returns its results as a JSON object. It includes the server response code, the final URL, and the score. It also includes page stats such as the total number of each resource downloaded, the total number of hosts, and the size of the request. And finally, the results of all the rules tested. Each PageSpeed rule generates an impact number that indicates the importance or priority of implementing that set of suggestions for the rule, relative to the other rules. For instance, if enabling compression would save 1 megabyte, while optimizing images would save 500K, then the enable compression rule would have an impact value that's twice that of the optimize images rule. You can query the URL from the command line, or better yet, just automate it. Grunt makes the command line testing super easy. The Grunt PageSpeed plugin simply tests the deployed pages, reporting the page speed score, page stats, and the individual rule results. If the page speed score falls below the specified threshold, well, then the Grunt task fails. By testing your site regularly with a cron job or other scheduled task and saving the results, you can use PageSpeed Insights to track your site over time. Small changes, when looked at individually, may not make a big difference, but over time, these numbers add up, helping you to spot regressions or see trends that you might have otherwise have missed. By adding PageSpeed Insights to your development workflow today, you can ensure that your pages follow the best practices for performance and user experiences, and you can spot trends before they become a problem. So go, test your pages right now, and then add PageSpeed Insights to your workflow. Thanks for watching, and go build something awesome.
Hi, I'm Adam Glazier, a UX designer on the Google Cast team. If you're new to Cast, Cast is a way for people to get content from your app to their TV. And in this video, I'll show you why Cast works the way it does so that you can be informed while designing your app. Now, for the sake of simplicity, the examples I'll share focus on casting and controlling video. However, it's worth noting that you can also cast other types of media, such as music, games, and photos. Now, when designing for Cast, there are 3 main things to consider. Your app is the remote. So just like a TV remote, your app should make it easy for anyone to control a cast at any time. People need instant control no matter what state their device is in. Second, it's a shared experience. When your app is casting, expect that others are in the room. Some will be watching, some will contribute, and some will need to take control. Third is that it's cross-platform. The living room has many devices in it, and the more devices that can control your cast, the more seamless it will feel. Now, because casting is a new action, its usage depends on people being reminded that it's available. An easy way to do this is to show a one-time cast introduction screen. This intro will help users new to casting and also help experienced users know that your app is now cast enabled. So placing the cast icon at the top right of every screen in your app will allow users to start and control casts at any time. And to be clear, the cast icon should always be visible whenever a cast receiver is available. Now, once users are ready to cast, they can do that in two ways. They can connect to a cast receiver and then play content, or they can start playing content and then connect to a receiver. Either way they start, cast is a mode of the app. So just like Bluetooth, once you're connected, whatever you play in the app should cast to the TV. Now, once content starts streaming to the TV, the phone allows users to browse and control casts, while the TV displays the streaming content. Now, when designing your TV UI, do not make it look touchable, simply reuse the tablet UI. For example, in research I've observed, people attempted to use the physical TV remote when the UI on the TV looked interactive. So with this in mind, when you tap pause on the phone, it changes to a play icon, and the TV shows the pause icon. This is because the TV is showing the state and the phone is providing the action. The second tip is to help the TV UI stay out of the way. For instance, people will sometimes pause a video to examine a frame or read text on the screen like closed captions. So when someone pauses a video, fade the TV UI away after 5 seconds. Keeping the UI within the lower fourth of the TV will also help, since most of the important content is typically above that. The last tip is to provide the ability to control a cast from every state of your app. At any given time, the most critical controls for people are play and pause and volume. Remember, this is super important because your app is the only remote they have. Now on Android, there's 5 places to surface controls. You can provide a full set of controls in your app for the content currently playing, and when navigating elsewhere in your app, provide a persistent controller. This is commonly a control bar at the bottom of every screen. Also, provide controls within the cast menu, because this is where users start and stop casting. And when users exit your app, make sure to provide controls in notifications and the lock screen. Doing all of these together will ensure the most seamless experience, so that your users can relax and use their phone however they like. Now, once something's casting, expect that more users will want to join in. So at a minimum, when multiple users are connected, each user should be able to take control. An example of this is that if you left the room while casting, your friend should be able to take control. Another possibility is that you started a cast and your friends want to add to the queue. So designing your app to work for anyone at any time will help it feel extra natural. Now, from time to time, expect that the phone's connection to a cast may go in and out. This can happen from the Wi-Fi going out of range, the phone battery dying, or your app's processes being stopped by another app. When this happens, automatically reconnect users that dropped off whenever they're in your app. The final step to a cast is disconnecting. Users can disconnect from the cast menu and also from a notification in Android. Now, to prevent users from accidentally stopping a cast, make sure to only stop the cast when the last connected user disconnects. For the complete set of Cast UX guidelines, don't forget to check out the design checklist on the Cast SDK site. Thanks for watching, and I'll see you next time.
At Udacity, we're reimagining education by teaming up with industry leaders like Google to create courses on the cutting edge of technology. Today, we're announcing 4 new courses developed with Google in Android, Cloud, Web Performance, and UX Design. For more information, visit udacity.com/Google.
Testing sites for the multi-device web requires a different set of tools than desktop web development. Hi, I'm Pete, a developer advocate at Google. I'm going to show you my workflow and how you can use it to make sure that your sites look amazing on any device. I always start on my desktop with my browser window sized to about 400 pixels to mimic the narrow viewport of a phone. It also makes it really easy for me to resize the browser window to see how things will look across different viewport sizes. Once I've got the basics down, including my layouts, my primary breakpoints, and so forth, I open up Chrome's built-in emulation tools and the iOS simulator. Emulators and simulators are great tools. While they're not always 100% accurate, they'll almost always get the job done. Chrome's emulation tools allow you to emulate everything from screen size to device pixel ratio to touch, even a few of the hardware inputs like geolocation and the accelerometer. Starting the emulator is easy. Simply open up the DevTools and hit Escape to show the console drawer. Then select the emulation panel. From there, pick the device that you want to emulate and hit the Emulate button. Chrome does the rest automatically. Now, here's a quick tip. Because mobile devices are usually in portrait, dock the DevTools to the side instead of the bottom to better use the space that you've got on screen. For iOS testing, I usually start with the iOS simulator, which can be downloaded from Apple's iOS Developer Center. It gives me a good idea of how my pages are going to look and behave. Using Chrome's emulation features and the iOS simulator, I'm usually able to find and fix about 80% of the issues that I come across. For the other 20%, I almost always have to switch to a real device. Remote debugging allows me to inspect, debug, and analyze the on-device experience with the full suite of tools that I'm used to, but on my desktop computer. To use remote debugging in Safari, go to Safari Settings and check the Show Develop menu in Menu Bar checkbox. Say that 10 times fast. Next, connect your iOS device to your Mac via USB, and then on the iOS device, open the page that you want to debug in Safari. Now on your desktop, find the device in Safari's Develop menu and choose the browser page that you want to debug. At this point, Safari's Web Inspector is ready to go. Sweet! The initial setup for Chrome is a little bit more involved, and it requires that you enable the USB debugging in the Developer Options panel. If you don't see the Developer Options panel, try going to Settings, then About Phone, and hit the build number 7 times. Yeah, seriously, 7 times. Thankfully, you only need to do that once per device. If you're running Windows, you'll probably also need to install the device drivers as well. Once you've done that, the process is much easier. Connect the device to your computer via USB and open the page that you want to debug. Then on your desktop, open Chrome://inspect. You should now see all the tabs open on your device in your desktop browser. If you don't, make sure that the Discover USB devices is checked and that there aren't any pop-ups on the device asking for permission. You can even access files served locally from your computer or from a private network with port forwarding. Chrome Remote Debugging also supports screencasting. Click the screencast icon in the upper right-hand corner, and Chrome brings the experience of your device into your DevTools window, allowing you to keep your attention on one screen instead of having to switch back and forth and back and forth and back and forth between the device and DevTools. Now, keep in mind, screencasting captures screenshots and sends them to your desktop, so there is a small cost overhead involved. Remote debugging is amazing if you've got the devices you need, but what if you get a bug report for a device that you don't have or that isn't available where you live? Or better yet, you want to automate some of your tests. For that, I use one of the remote testing services like BrowserStack, Sauce Labs, or Device Anywhere. These remote testing services offer cloud-based access to real and emulated browsers and devices. Through these services, I can interact with the device as if it were right there in front of me. My interactions are carried through directly to the device or emulator. Some of these services even offer APIs that I can use for automated testing. For example, unit tests, end-to-end tests, or screenshot capturing for visual regression tests. Now that's my web development workflow. I start by using my desktop browser for my initial iteration. Next, I move to emulators and simulators for the bulk of my work. I pull out real devices for polishing and verification, and when I don't have the device I need, I try and find it on one of the remote testing services. Then I'm ready to ship. Woohoo! If you're not making sure that your site works for the multi-device web, why not? I've just shown you 3 easy ways that you can get started today. Thanks for watching.
Good afternoon and welcome to Material Witness. We thought it would be good to write some actual code using some of the new material design APIs and talk about how we did it and also, more interestingly, how some of the stuff works under the covers.
Yeah, so just one little caveat. Chet just mentioned writing code, and since we're both managers now, we don't really write code anymore for a living, so forgive us if the code is weird.
We should have people to write this for us. I don't know if you know who we are. I am Chet Haas. I'm on the Android UI Toolkit team. I don't know who this is.
Romain Guy. I used to be on the Android UI Toolkit until... Thank you.
Are they...
Until Chet decided he wanted my job, and so now I'm working on robots.
Are they clapping because you used to be on the team?
I think so.
Or because you're gone, yeah.
Like, gee, it's finally gone.
Moving on. Oh, those awkward protesters. All right, let's take a look at a couple of demos. So I had an idea for a demo application that we're going to do together. It was going to go out to Flickr. It was going to fetch these images by Romain. We'd get these beautiful images downloading in the background, and then we'd install them in wallpaper, and it would be all lovely. And Romain was like, I don't have time to do all that. How about if we just hack some demos to show the pieces that we actually care about? So that's what we did.
So we will pretend, we have two demos. We will pretend that we have two demos to keep each demo simple so that the code will be easier to understand. But it's really because we didn't have time to merge the two demos.
So I have a very simple demo showing off some of the things we're going to talk about today. I tend to look at my demos as simple things that I can write code for that clearly explain the simple bits that I want to help people understand. And then Romain writes something similar and actually makes it look good, which is really embarrassing. So here's my simple demo. This is showing some of the elements we're going to talk about in terms of animations and cards and some interactivity as you touch these things, some ripples, so we can sort of see some of this in action. Then this stuff is going to be demonstrated in videos as we go, so we can look a little bit closer. So we see a transition. We're sharing a hero element between these activities. We can change and customize the transition and make the elements explode out and move out to the top and bottom in a staggered way instead. OK, so that's my simple demo.
And this is the second demo, so similar idea with images. So we are going to see transitions, reveals, with a live map view. This has nothing to do with material design. It just looks cool. And if we have time, we'll talk about it. If you look at the colors of the UI, you're going to notice that the colors are actually coming from the images themselves. So this is dynamic theming of the app, basically, based on colors we live from the images. And again, we're going to look at the APIs to do this.
So if we can switch back to the slides. So first of all, let's talk about cards, one of the simple elements that you saw in both of those demos. And the cards are the idea. You see it in a lot of the mocks from the design team as they're talking about material design, setting apart the content into these items that are then sitting on top of these cards, this paper representation, elevated a bit off the view hierarchy plane, so they're casting a little bit of shadow. There's padding around the edges, sort of a nice way to separate the content with some nice white space in there. So we implemented that. In my demo, I did it very manually. I just have a group to sort of do all the little bits and pieces that need to be done. You can also use card view in the support library to do this a little more automatically. So in the case of my demo, there's a round Rex shape drawable that I use as a background, and then I clip to that outline. And this is one of the new APIs and capabilities exposed in the L release. So you can clip and get the nice rounded corner there. This is also the shape that is used by the shadow that is then cast onto the view hierarchy plane. So as you elevate this view, then we cast a shadow using the outline that you've told us your view has. So we get the nice rounded shadow, soft shadow effect around the edges of the cards.
And we're going to talk in more details about how elevation works in a few minutes.
So here's how I happen to do it in my codes. In general, views, drawables know what shape they are. So if you have a shape drawable, it knows what outline it exposes, and it can propagate that information to the view. So in general, views should know what shadow the shape should be drawn with or potentially clipped to. Some of that stuff is not yet enabled in the preview L release. So I'm doing it more manually here. The outlines are specified in the coordinate system of the views themselves. So when the view changes size, you need to then update the size of the outline appropriately. So here we override on size changed. We get the size of the view. We create the round rect. We set the outline to shape. And then we tell it to also clip to that shape as well.
And in particular, this trick of creating the outline programmatically in on size changed is very important if your background is a bitmap. Because given the way shadows work right now, the system is not able to generate shadows for bitmap. So if your bitmap contains a circle, the system doesn't know there's a circle. So you have to tell the framework that you want a circle for the shadow.
So a lot of the canonical cases are going to be solved for you if you have a shape. It's going to know what shape to draw that shadow at. But not necessarily all the cases, so it's good to know how to actually do it programmatically as well. And then finally, we set a shadow on the card simply by boosting it up to some value. So we've set an elevation value of 5 here. And as Romain said, we're going to talk more about shadows and elevation later. So you could also just use card view. I didn't happen to, frankly, because it wasn't online when I was writing some of the bits of the demo here, but you could use card view to do this. What I did is actually really simple. The advantage of using card view is twofold. One is that it standardizes your cards with other people that happen to be using that element, so things look a little more consistent across the platform in general. But also, in the card view widget, which is in the support library, when you're sitting on top of the L release, it's going to do the correct thing. It's going to give it an elevation. It's going to clip to the edges. It's going to do all the L correct things. When it's on a previous release, it generates images that look pretty much the same. It's a very good and consistent look. But it's not necessarily it's certainly not using the same capabilities because we didn't have shadows prior to this release. But it at least uses these elements of the different releases to give you a consistent look for your application across releases. And you can see here there's examples of card view previous to L and in the L release, and they look pretty similar, and that's a good thing. So how it works is basically if you're running on one of these previous releases, it generates a PNG file with the shadow baked in, just as you probably would with your assets if you were trying to do something on your own. You can use path clipping if you want to actually clip shapes to a path. It tends to be very expensive, so we don't recommend it as a general solution. If we're actually redrawing your views that are path clips all the time, you're wasting a lot of performance that you would probably rather be spending on other things in the system as well. There's also approaches where you can use bitmap shader to draw and get a similar result. This is the effect used in, I think, search in KitKat. Yeah. When they did a circular reveal, they were using a bitmap shader to get that effect. Again, kind of expensive. You don't want it running full time on the system, but it's OK for a transient effect. In L, it's much simpler. We can actually tell it the outline to clip to and the outline to shadow to, and we can set the elevation to shadow appropriately. I didn't want to put the actual APIs for outlines on here because this is one of the areas that's probably going to be tweaked a little bit in the final release of L. There's a simple way of dealing with outlines right now. That simple way of dealing with outlines is probably going to change to a different simple way of dealing with outlines. So don't get too hung up on the details since it's a preview release. But the general ideas will be the same. Now let's talk about ripples. This is touch feedback. One of the important elements, we talked about this in earlier talks, was to give the user immediate feedback of what's going on in the system. So we have touch feedback on all the standard widgets so that the user knows what they pressed and where they pressed it, and we animate the state change over time. And actually, you probably went to the earlier talk anyway, so I'm going to blow through some of that stuff and get to the more interesting bits of how this stuff actually works. So ripple drawable, it's the new class. You can use it directly. There's other ways that you can opt into this behavior, and the standard widgets have it built in. So you can see the ripple behavior here. Is that coming across on the screen? I think so. And then if you stare at it long enough, maybe you'll have a seizure. And here's some of the code to enable some of this stuff. So from XML, you can create this ripple drawable. So you can optionally set a color for your ripple, and it basically uses that optional color and reveals the content that the ripple is actually wrapping. So in this case, we have a drawable that's simply a color drawable, and that's going to be revealed over time with the ripple that's then wrapping that item. Or similarly, from code, you can create the ripple drawable class, optionally set a color on it. Or the easiest way to do it is actually just to set a selectable item background. And that means when the user presses on that, puts it in a selected state, then it's automatically going to run a ripple. The ripple that we saw in the seizure slide and the previous slide uses that approach. It says, I want my foreground to be this ripple drawable. So then as the item is selected, it automatically emanates that ripple on top of it.
And this is the same exact effect in the second demo. We just wanted to show it to you because here the ripple is pinkish, purple. The color comes from the theme. So if you use the foreground technique that Chet just showed you on the previous slide, you're automatically going to get the ripples with the right color from your theme.
So how they work in general, they wrap the content. So you can think of it as a wrapper around the actual content that you're going to reveal. And it's going to reveal that by emanating the ripple out from what we call the hotspot, the center point of the interaction. If you use selectable item backgrounds, we automatically know where that hotspot is. We know where the user's finger pressed, and we can emanate from that center point. If you're doing it more programmatically, you can set the hotspot. You can set the XY location in the local coordinate system of the view, and that's where the ripple will emanate from. The other interesting detail is about the render threads. This came up in one of the sessions yesterday. This is a performance optimization that we've enabled in this preview release and we'll be continuing to work on, where the drawing system usually consists of, or has always consisted of, in the hardware accelerated model, we create display lists on the UI toolkit thread, and then we issue or execute the display lists also on the UI toolkit thread. And that's when we actually talk to the GPU and send down OpenGL commands. What we've done is broken those out into two separate threads so that we create the display list on the UI toolkit thread, and then the render thread actually talks to the GPU. If that's all we did, it doesn't really bias anything because we still have to create it before we execute it. But now that we've been able to break this out into separate threads, what we can do is start sending over animations as atomic objects to be executed wholly on that other thread. And the first one of those that we're working with is the ripple. So you'll notice if you press on a button that launches some activity, what you would have seen in previous releases is the ripple would stop emanating as soon as you started the new activity because the same toolkit thread is being used to inflate the new activity as is being used to animate the ripple. So what's happening now is we're sending in information about the ripple animation down to the render thread, and that is able to continue running while the toolkit thread is busy inflating the new activity. So that's the main thing that's executing on the render thread right now. Expect more over time as we're able to do this. There's some really tricky details about what we can run on either thread and what the contract with some of the animation APIs are. But we'll do what we can to take advantage of this new performance optimization. Now let's talk about shadows. I'm going on and on, but trust me, he's going to talk for a lot after I'm done. Shadows are the idea of boosting views in 3D, raising them above what is essentially the z equals 0 plane of the view hierarchy. One important detail here is that we're using orthographic projection. So typically, if we had full-on perspective camera world, then as you raise things up, they would also scale up because you get perspective foreshortening. They would get larger as they came closer to the view. That's not the projection system that we're using right now due to some of the details about how we want the UIs to actually interact right now. So as views raise up, they are raising in Z and the shadows are expanding, but they're not actually scaling. Sometimes you actually do want the effect of scaling, in which case you should actually animate the scale X and scale Y property to the view at the same time to get that effect that you're looking for. We also added APIs not just to view for the properties around elevation, but also to view property animators so that you can easily animate these properties. So this question came up a couple of times in a previous session. There's a little bit of confusion about what's an elevation and what's translation Z and what Z is. These map exactly to the existing layout and post-layout properties for X and Y. So if you imagine there's the left property, which is the layout property that says where you're going to position this thing in X when layout runs. And then there's translation X, which is a post-layout property, which you usually use for animations, which is additive on top of that left property. And then there's an X property, which is the sum of those. So it's exactly the same thing in Z. Elevation is basically the permanent location that you want that thing to live at. Translation Z is a kind of a post-layout, if you will, property that is then additive on top of that. This is going to be used for animations. Like if you go into a press state and out of it, then you would probably animate translation Z, which is going to be on top of the elevation parameter. Or you can simply use Z directly, which is additive. It's the combination of elevation plus translation Z. So here's a simple bit of code that I have in my demo, when I pressed on one of those thumbnail images, it raised up under my finger, and then it went back down, and then launched the new activity when it was back down on the view hierarchy plane. The way I did that was simply through an easy touch listener. When I pressed down on it, I would start an animation that scaled in X and Y, because I did want kind of a perspective scaling effect on that. And I would also animate translation Z. When I let go, I get a cancel or an up. Then it would simply animate back down to Z equals 0. Or elevation equals 0, or in this case, translation Z equals 0. And then it would launch the new activity from there. Fairly straightforward. There's other ways to accomplish this, which we'll see later in other code.
Yeah, and now I want to talk a little bit about how the shadows are actually implemented. So this is what the UI designers wanted us to implement. So this is an image I rendered in Blender, and it took 10 minutes on my laptop. So
10,
of course,
10 minutes.
Yes.
10 minutes. 10 times 60 seconds times 60 frames a second. Yeah.
So not possible on a phone, but I tried anyway. You'll see. So let's see what we have here. So there's an area light, and Chet mentioned that in the previous session. The area light is what gives us those nice soft shadows that you see at the bottom. So your occluder is the view, and the area light will cast those nice soft shadows. Now, if we implement shadows in the naive way, you would get something like this, where the umbra, so the umbra is the part of the shadow that's from which you cannot see the light at all. So it's fully in the shadows. And then there's the penumbra. This is the soft edges. So that's what, when we talk about soft shadows, it's just shadows that have an umbra and a penumbra. The problem here is you can see that the shadow is completely dark. And in real life, this doesn't really happen, because what happens in real life is that the light bounces around. If you lock yourself in a room and you close the door, after a few minutes, you will be able to see things. And the reason is, light will go through small holes in the door and just bounce around until it hits your eyes. So really what the effect that the UI designer wanted was this. And this phenomenon is called global illumination. So if you look here, you can see that the shadow is not completely dark. It's a little hard to see on screen, but the color of the view itself, the occluder, the red, is reflected onto the ground. So part of the ground is a little bit red, and the ground itself is light. So to implement this, just before I left the Android team, I wrote the first prototype of soft shadows, and this is what I came up with. It was using ray tracing on the GPU, and it looks pretty good. There's global illumination approximation. This looks fairly similar to what you get in Blender or any expensive 3D rendering package. The only default, the only issue with that approach is that it was running so much code on the GPU that after a few seconds, like 30 seconds, the Nexus 4 would overheat and reboot. It was just trying to not melt.
So we fired him.
So I got fired. So we decided that maybe this was not the right way to do it. So smarter people than me found a different approach. So basically what happens is the system will calculate geometry. It will generate a bunch of triangles to send to the GPU that will represent the shadow. And there are actually two shadows in that system. There's the shadow that's generated by the area light itself. So it just projects the area light through the shape of your view, through the outline. And that would normally, and if you just did that, you would get that really dark shadow that we saw before. So the first trick is to make that shadow semi-translucent. So that simulates global illumination a little bit. The second trick, and it's actually a really nice trick, is to have a second shadow. The idea is that because the light is bouncing around, really the world around you is acting as a light source. So we're casting a second shadow as if the entire world around your device was a light source. This is called the ambient shadow, and it's done a little differently. It just projects your view like straight onto the ground as a secondary translucent shadow. The effect is really subtle, but when it's missing, it doesn't look nearly as good. So this is not grounded in reality. This is not how light works in real life. But as always with graphics, what matters is that it looks good. How it's done doesn't really matter. So like I said, the system computes geometry. So every time you move the view in X, Y, or Z, so if you change the elevation, because the light source itself has a fixed position, the geometry has to be recomputed. The nice thing is most of the work is done by the GPU. It just interpolates colors. So this will show you what the geometry looks like. So this screenshot is taken from another prototype that actually runs on desktops that was implemented just to play with different algorithms. So you have your nice soft shadow. You have your view that's tilted in 3D space. And this is the kind of geometry that the system will actually generate to draw the shadow. So here you're seeing only one of the two shadows I mentioned. And the geometry that's being used is not necessarily the same geometry that's used on the device or that will be used in the final release. But this gives you an idea of how it works. Just one tip when you use the shadows. By default, views have a pivot point in their center that's used to apply rotations. So if you rotate your view on the x-axis or the y-axis, and you leave the default pivot point, your view will intersect with the ground. So visually, like on screen, because it's not a real 3D system, you won't see your view being clipped by the ground because there's actually no real ground at z equals 0. But the shadow system will think the ground is intersecting with your view, and you're going to get a bunch of artifacts. So if you want to apply 3D rotations to your view, make sure that you set an elevation that's high enough that when you rotate the view, it doesn't intersect, it doesn't collide with the view hierarchy plane. You can compute it in it's simple trigonometry, or you can just play with values until it looks good.
This is an important point. It's easy to misconstrue what we've done as, hey, now we have a full-on 3D modeling system. No, what we've done is used a z value to get physically correct information about the view system and shadows as we boost these things into Z, but we don't have a Z buffer. It's not a modeling system. You can't use this as a full-on 3D system for doing games where objects can be self-intersecting and you actually get the correct visual results. It's still a fast 2D rendering system that we've added some Z to. But if you're doing things like these, you're going to run into the edges of that system pretty quickly.
Something else that you should be aware of, if you have several views that are stacked on top of each other, and some of these views are rotated in 3D space, so you use an X or Y rotation, the shadows that are projected by the views above will not be reprojected on those views. So the projection of the shadow is always meant for the ground plane. So the shadows will draw on top of the various cards in your stack, but they won't be applied to the transform planes of those different views. So don't hesitate to play with the 3D rotations. I mean, you can create really nice effects. And Chet, in a previous session this morning, showed like a little tilt animation when you drag a card, and it looks fantastic. Just be aware of those very small limitations. So the shadows, so far we've shown them mostly static. And in Chet's demo, I don't know if you've noticed, we're going to get back to it, the shadows are actually animated. And there are various ways of doing it. It's very useful when you want to create a press state, like an animated press state. So you press on the button, and it feels like the button is raising in 3D space. And there are a couple of ways of doing that. So you can see here, it might be difficult to see on screen, but if you look at the button on the right, when the finger presses the button, you'll see that the shadow grows a little bit. It's actually even harder to see on your own device because your finger is on top of it, but it still looks really cool. And this is how it's done. So you can use a simple stateless animator. So this is the button that we just saw in the video is a simple image button. You specify a stateless animator. It's a resource that lives in the anim directory. And that resource looks like this. If you used selector drawables before, if you've created custom drawables for buttons, this looks very familiar. The difference is that inside the items of the selector, instead of putting drawables, you just put object animators. So here what we're doing in the first item, we say, when the state is pressed, I want you to animate from a certain elevation to another elevation. And when at the bottom the state is not pressed, I want you to animate the other way. And that's all you have to do. It's a very, very easy way to create those nice secondary animations in your UI. And of course, you could animate any property. The only trick is that from XML, you have to tell the system the type of property you want to animate. It won't be able to figure out that the elevation, the translation Z here is a float. So this is how you would use the stateless animators from code. It's easier to do it from XML, but if you want to dynamically load those animations, this is a pattern that you're probably familiar with.
So one of the big new animation capabilities that we enable in the platform is activity transitions, in particular the ability to share elements between separate activities, which before you could do, but it's a little tricky to figure out how it works. We created a dev byte showing how you can do it, so you could certainly take that approach on previous releases. But now we've taken the new transition API that was new in KitKat, and we basically baked that into the ability to have much more rich animations between activities. So now you can think of these 3 separate phases of these activity transitions where we have an animation that's happening in the activity that's going away, where we can animate the items out. And we have items in the new activity that are going to be animating in. And in the meantime, we're passing information about a shared element between these activities so that we can then animate that item to some state in the launching activity and then animate it from that state into its final position in the launched activity. So sort of all these different separate bits, all of which can be customized to whatever extent you want. And the information that we pass about that shared element is the position of that element, the size of that element, and a bitmap that represents that element, as well as the name. And then if the launched activity knows something associated with that, so if you're in a music app and you see a list of albums and then you go into a detail view and you pass over a shared element with the name album, then the launched activity can say, oh, I know where to put an album on this screen. Sure, I'll take that element. Then it's in control of the transition and can animate it appropriately. There's also the ability to customize these transitions, and that's customization in terms of the actual transitions you run. So you can have different kinds of effects. Right here, we see two different transitions happening. This one is an explode. You can see the items animating out to the top and the bottom. And then we toggle that checkbox on top, and we get a crossfade, the default crossfade transition instead. So you can customize things with either the transitions that we ship with a platform or transitions that you write on your own. You can also customize it in terms of which transitions target which items in the UI. So you can say, I want fades to happen on these targets. I want explodes to happen on these other items. And you get a much more choreographed experience as you go from activity to activity. So here's some of the code that you would need to use in enabling the basics. There's a lot more code, a lot more APIs that I won't go into the details of. First of all, right now you need to be using the material theme on the preview release. That requirement may go away. It seems like we should just enable activity transitions in general if you want them. But right now you enable the material theme, and then you would say, I want to use window content transitions. You can either do this in your theme itself, or you can specify this in code by calling the request feature method. And then you can set some optional behaviors. So once you enable transitions, you're going to get some default behavior. It's just going to crossfade between your activities by fading the items in and out as you go between activities. But you can set up custom animations. Here we're going to use an explode on the exit transition. So as I leave my activity, items are going to stagger and animate out to the top and the bottom. You can also specify the overlap behavior. By default, we're going to overlap the animations of the enter and the exit at the same time, or as overlapped as they can be, depending on how long it takes the launched activity to actually inflate and get ready to go. Or if you want to choreograph it more carefully and say, no, I want this animation to finish first, then you can set the overlap property to be false instead. And then you can set up information about shared elements. This one sets up a single element and assigns a name to it. You can also have a set of elements. You're basically passing this map down and saying, this item is going to be used with this name, and then the launched activity gets all that information on the other side. And then you start the activity with that information, and away it goes. So how they work is basically building on the transition capability that we had in KitKat. The big idea with transitions is I want to know where things are at now, and then I want to run layout and figure out where things are at afterwards. And then I want to start the animation based on where things were and then animate them to where they are. It's the same idea, except that was in a single view hierarchy in an activity, but this is applied across activities instead. And it's applied in the following way. We know what's happening to the items in the launched activity. So in the explodes case for a transition, we're going to move all the items out. So we're going to say, OK, I know where everything is now, and I know where everything is when it's animated out. We're going to run that animation. And same thing for the launched activity. We know where things are off screen. We can animate them on screen, all using transitions. And then the final element is the hero element. So once the launched activity gets the information about the elements that you want to share, it says, oh, I know where to put the album on the screen, and I know what size I want it to have, and I know what size and position it had where it started. So I'm going to run a transition that automatically animates those changes over time as well.
So sometimes the default automated transitions are not enough for some types of effects. When you use one of those automated transitions, the framework will look at some specific properties of views, like size, position, alpha, but it doesn't know about all the properties that you can use in the UI toolkit. So here's an example. In the list of thumbnails, you can see that the thumbnails are darkened. So I use the color filter on the image views to darken the thumbnail. So what I want to do is when we transition to the new activity, I want to animate that color filter from dark to clear. And because the automated transition system does not know how to do that, we need to synchronize with that system to run normal view animations when the transition is done. This is actually fairly easy to do. So to run an animation after a transition, you can just get the enter transition from your onCreate method in your activity. You can add a listener. And we just listen for on transition end. So at the end of the transition, I just run my custom animations. So in this case, I just I do the color filter that I'm not showing in the code because it's a little more complicated. I also fade in a couple buttons. It's also important to remove the listener when you're done using it. You also want, if we go back to the video, you can see that when we go back to the list of thumbnails, we will want to, if the video plays. Okay, when we go back to the list of thumbnails, we want to redarken the image, and of course it's not in the video, sorry about that. So you want to be able to run custom animations before the transition. And an easy way to do this is to override on back pressed. You run your normal view animations, you listen for the end of those animations, and at the end you just call this finish after transition method. You used to call finish, but if you call finish after transition, we're gonna run the transitions and then finish the activity. Just be careful if you implement those techniques. The code is a little bit more complicated if you want to deal with the screen rotation correctly. Because if you rely on those listeners, when you rotate the screen, there won't be a transition, and so your animations won't run. So you probably need to set something in your bundle, in your save state, and take a different action based on that. I mentioned animating a color filter. That's a technique we've showed in presentations in the past. It was a little painful before because on every frame, you would have to create a new color filter instance to create your animation. That was generating garbage. That was causing GC pauses. So sometimes you would get a stutter in the animation just because of the extra garbage that was generated. So as of the help preview, you can animate color filters without recreating them on every frame. There's a new set color method. So here we use an object animator, and we animate the color property of the filter directly. The only trick here is that a color filter knows nothing about the view it's associated with. So just changing the properties of the color filter will not change what's drawn on screen. You need to trigger a redraw of the view that uses the color filter. So an easy way to do that, you can see here, is to add an update listener. And on every frame, you set the color filter again on the drawable of the view that you want to animate. And then everything will redraw properly.
So one of the new elements in the preview release is reliance on and more flexibility with colors in general. The assets that we have by default are all grayscale, and this is done on purpose so that it's easier to then tint those as required by your application or by different states of your application or by different activities within it, so that it's easier to brand your application the way that you want, and also to produce less assets. So previously, if you wanted to colorize your application, you could certainly do that by creating images with that color. What we'd like you to do instead is to actually use these neutral colors and then tint them as appropriate to whatever that situation is. So much easier, much more powerful, much more flexible. And one of the elements that's going to make that easier is a new utility in the support library, which is the palette utility, which allows you to then go out. There's another reliance on images as well. You've seen a lot of images in a lot of the material design content so far. Wouldn't it be nice if you could actually figure out information, color information about those images, and then use that information to then colorize your UI, as we saw in Romain's demo so far? So I already explained this, so I'm going to just go on to your stuff. It's more interesting.
So first I will show you how to change the colors of the static theme. So that was the first activity in the demo I showed you. So it uses pink for the action bar, the status bar, and the nav bar. So it was also using purple for the ripples. And this is how it's done. So you create a new theme. You inherit from theme.material or theme.material.light. And there are 5 colors you can override. You can see them here. We have color primary dark, color background, color accent, and color control highlight. And the system will by default use those properties to colorize the theme. So I colorize the different values based on the actual RGB values. You can see, for instance, the color accent and the color control highlight are purple. And that's where the purple in the ripples was coming from, so entirely from the theme. You can see next that I've also colorized the navigation bar, the nav bar at the bottom, and the status bar. So I just use references to reuse the primary dark color from my theme. And I've also changed the background color to one of the colors from my theme. So it's very easy, very simple to do, and certainly beats like creating dozens or hundreds of assets just to change the default color to like green. Now, to generate those different secondary activities that have, all the colors are coming from images, things are a little bit more difficult. There's a new API that Chet mentioned called Palette. It comes with the new support library. So the jar file is android-support-v7-palette. And what it does is you give it a bitmap, and it will generate a series of colors from that bitmap. So by default, it will try to generate 16 colors. You can specify how many colors you want. It will also try to give you 6 named colors, and you'll see what I mean by named colors. You just have to be careful, because those named colors can be null. So if you pass the palette API like an image that only contains blue, it won't be able to generate the 6 colors for you. So you might have to use fallback colors in your application. So this is an example of the output of palette. So given that image on the left, you can see the name colors. So they're called dark muted, dark vibrant, vibrant, light muted, and light vibrant. And on the right, you can see the full palette. So I think it generated something like, I don't know, do the math, 15 colors or something from that image.
14.
14?
That's 14.
Okay.
I got a math.
That's why I was fired. This is how you use that palette API. It's super simple. You call palette.generate. You give it a bitmap. Optionally, you could give the number of colors you want. There's an asynchronous version of palette. So if you give it large images, it's going to take a fair amount of time to generate the palette, because it has to look at all the pixels in the image. So there's a callback system so that you can do something else while you're waiting for the palette to come back. And this is just an example of how you would apply programmatically the colors to your UI. So for instance, I change here the background drawable. I use the dark muted color. So notice that on the palette, when you get a color, you actually get a palette item. You don't get a color directly. So that object can be null. And if it's not null, you can call get RGB to get the RGB color for that item. This is a slightly more involved example. So here, all my buttons used ripples, and the ripples and the background of the buttons the colors come from the palette as well. And here's how you do it. So this is the ripple drawable that I was using from XML. So a ripple drawable is basically a layer drawable. So it can contain a number of other drawables. So here I only have a circle inside, so that gives me that nice round background. And don't look at the color. The colors are here just so that the XML can be compiled. I override those colors from code. And this is how they are overridden. So I have a background color and a tint color that come from my palette. You can call set color on the ripple drawable to change the color of the ripples themselves. But if you want to change the color of the circle, the actual background of the button, since that background is a layer in the ripple drawable, you first have to call get drawable 0, because I only have one item in that list. And then I can set my tint color on that second drawable. Reveal, you've seen that animation earlier. We'll show it again. So this is a new animation that you're going to probably see in a lot of applications that implement the material theme. It's just a circular shape animation that's used to reveal any kind of content. So in L, it's super easy. You just call view animation utils that create circular reveal. And if you want to implement that in prior releases, there are techniques. So it's mostly using textured shapes and bitmap shaders. I wrote an article on my blog that explains how to do it. It's fairly easy, but that means the view itself cannot be dynamic. You cannot change the content of the view during the animation. So this is what the circular reveal looks like. When we press the little button in the bottom right, we just reveal a map view. So this is a fully dynamic map view. That's not an image. It's the actual map view running OpenGIS, and get me 13 in 3D rotated and moved. So the good news about the implementation in L for circular reveal is because the framework is aware of those animations, it's using a new implementation that's shader-based. So it's much more efficient compared to the way you could do it in previous releases. So Chad mentioned that again in a previous session. So you could use the stencil buffer on the GPU if you clip with a path that's extremely expensive. You shouldn't do it. It's also using more memory. It was not anti-aliased. The new solution is, it's still a bit slower than if you are not using a clip or if you're not using a circular reveal, but it's fairly efficient, and it doesn't use memory at all. Just know that there's a slight limitation in the L preview. The circular reveal is not anti-aliased at the moment, and it should be fixed for the final release. This is what the code looks like. So we call create circular reveal to reveal our map view. And you have to pass 4 parameters: the center of the origin of the reveal of the circle animation, the start radius, and the final radius. So here it's pretty easy to do because my button was sitting on top of the map view, so I can just get the coordinates of the button and use that as the center of the reveal. If the view from which the reveal is originating from is not a child of the view you're revealing, you might have to do a bit of math to convert the coordinate systems, but it's fairly simple. And similarly, when you want to hide the map view, you just swap the radius. So you go from the full circle down to 0, and it's going to do the animation correctly. And we have 5 minutes. So we're going to take questions instead of finishing the presentation. So again, that has nothing to do with material design. This is just a cool effect that you can implement all the way back to API level 1. So this is what it looks like. I wrote a full article online using a different demo. So if you want to know how to do that kind of cool visual effects, you can go read it. And we're going to switch to Q&A. Blah, blah. Q&A.
Q&A, and that's it. Thank you.
If you have a question, please walk to the mics. Yeah. No questions.
No running.
Man, we're so good that they understand everything.
All right. Yeah, it's all straightforward. Very easy. Great. Yes.
Memory. How does it deal with memory? I mean, we're already dealing with images. We're already running into memory constraints all over the place, right? So.
Which element are you talking about in particular?
Well, all these animations and so on. I mean, shadows and.
Shadows. So the stuff that we're showing doesn't really put any memory constraints on. We are certainly creating a mesh for the geometry for shadows, but this is trivial in terms of the amount taken up by bitmaps. That's basically just a bunch of vertices that we're going to send down to the GPU and then shader commands. The image effects that we're showing, I mean, obviously if you're using more images, you're using more memory for those images. But the actual animations that we're talking about, not so much. They're kind of data structures. Not really an issue. In the back.
I have a question regarding the selectors with the object animators.
Yes.
So you specify a start and an end values. Is there a way that you can say that the start value of let's say you have a press state and then a normal state, that the animation to return to normal can use the current value?
Yes. In fact, that is the way that it's supposed to work. There is a bug in the preview release where that is not the way it actually works. And so currently in the preview release, you have to give it a start value. That bug should be fixed in the final release.
OK, thank you.
Yep.
Somewhat related to that, just as far as overlapping reveal transitions, does one stop and another take over, or are they able to run at the same time?
So I do not know the answer to that.
Okay, thank you.
Chet, tell us.
I'm thinking if it's on the same view, there might be a conflict. There's nothing to stop you from running different reveals on different views. But yeah, the same view, I'd have to think about that. Let us know what happens. In the back, there's nobody, so go.
For colorizing, is there going to be a non-XML programmatic solution for that?
Yes, Chet, what about it?
Programmatic access
I say yes.
To theme attributes. The person that is working on that is nodding. So either yes or he's falling asleep. Thank you. Or it was a slow nod. It was not a seizure nod. Yeah.
So you mentioned that when you run palette on large images, that it's slow.
Well, it's not that it's slow. It's that
slower.
The larger the image, the slower.
Is there a sweet spot? It seems to me you could shrink the image and still get the same
I was
colors.
thinking the same thing as he was saying that.
Okay.
Yeah.
Is there, if there's some sweet spot to, we can shrink it, and it probably depends on the image. But
the problem is that it really depends on the image.
Okay.
And by default, I looked at the source code of the palette API, and I don't remember it doing any scaling whatsoever. But that's kind of a good thing, because that means you can do it if you know the content of your images. I mean, if they're low frequency, you can certainly scale them down. But if you have high frequency images, you might lose some of the important colors.
Cool. So this question's about the activity transitions. So when we're transitioning between activities and we're sharing a view, the view in the destination activity I guess. What happens if it's like a heavier view, like a map view? Are you able to like if it's not able to initialize in the time that the animation is happening? Is there a way to deal with that?
There's definitely some tricky bits to this interaction. So it's best to view activity transitions as being these bookend animations where you cannot get a seamless animation from one to the other because we really don't know how long the launched activity is going to take to inflate. If it's a really expensive view hierarchy, if it's getting resources from the network, whatever. If it takes 3 seconds to start up, obviously a seamless transition is not going to occur, right? So you'll have to factor that into whatever behavior you want for your animation. But having said that, then you figure out what the choreography should be. In general, you probably want to do something like animate the items out, and then animate your hero elements in the old activity to some sort of standing pattern, right? Just animate it up and have it sit there and wait until it can go in the launched activity.
So we have time for one last question in the back.
I was wondering, since we're going to have a first-class support for path animation, is there going to be any kind of support for decoding SVGs or similar vector formats?
Let's be really clear. His path animation demo was not part of what we were trying to do today. No, so that's, I'm not sure where you got the message from, but that was basically a way to animate paths using Android. That wasn't like first-class support in LAPIs or anything.
Okay.
Right, so if you go to his blog, you can see how he's doing that on current releases of Android. It has nothing
I
to do
used
with
the
the bigger OS.
third-party library to load SVG files.
Yeah, yeah. So
Okay.
you can certainly consume SVG and do stuff with it already. We have a very full and robust path API. All of that stuff is usable, and that's what he was using in his demo.
And we're done. Thank you very much.
Thank you.
All right, thank you.
Mobile developers and designers use different approaches to achieve the same goal: creating 5-star apps that users love. While both development and design approaches are essential, they are usually considered separately. In User Experience Design for Mobile Developers, you'll learn how to integrate design approaches and techniques into your mobile development to build world-class apps. This is a design course for developers who want to give their users a great experience. For more information, visit udacity.com/Google.
Have you ever wondered how some developers build a great product and business on Google Play? My name is Serge Kasarjian. I work on the Google Play team. My focus is on apps and games for our Android ecosystem. I'm going to tell you how to create a successful app in Play and leverage unique Android features to do so. My team works with our partners to build great experiences for Android that get their content distributed to our large installed base of Android users around the world. We want your business and brand to succeed on Google Play. So what will you learn here? I will show you how to create a successful app in Play and leverage unique Android features to do so. There are a lot of great ways to unlock value and succeed as an Android developer, and I will help you get started doing so. I'm going to show you how and why to do this, demonstrating its importance to your brand and business. I will also show you some interesting Android-related facts, as well as product features you may not be aware of. Google Play is a great place to grow your business, especially if you do it the right way. The platform is growing very quickly, as is our engaged audience, interacting with the apps and games in the store. We currently have over 50 billion downloads, with over 2 billion downloads coming every month, and we paid out more than 4x as much money to developers in 2013 as we did compared to 2012. Play also provides a unique iterative environment for our developers that allows them to A/B test using such features as alpha and beta testing and staged rollouts. Further, developers can take advantage of other form factors that will drive engagement through new channels and touchpoints such as tablets, wearables, and others. This is an awesome way to drive new use cases for your app that previously were not available when you were on smartphones only. Play will not only allow you to leverage our gigantic audience, but also take advantage of new functionality using your content. We are living in an increasingly global world, and every business and app is becoming an international one. What is your strategy across the globe? Google Play and Android is an opportunity to unlock this through our distribution and strengths in various markets that are large and growing quickly. As you can see here, partners such as Jack Threads and Noom all use tools to grow international numbers. In fact, 2/3 of all Play purchases actually happen internationally, and we strongly encourage our developers to take advantage of this. This large international community includes 200+ countries that can download from the Play Store and 130+ buyer markets. To take advantage of this big opportunity, use our tools for internationalization and language translation to help make shifting from country to country and language to language very easy. Users will feel a lot more attached to your app if it feels familiar and not so foreign. Further, identify countries that you are not in that potentially are great markets for Android and Play. You can see unexpected spikes of traffic in countries that you have activated and start focusing on those markets, which coincide with the big markets for Android and Play. The next thing to look at is design. I can't express the importance of good visual design and interaction patterns. Design, design, design. Make a strong Android design. It changes everything. People love great looking apps. It's your extension of your brand. Pure Android design makes you speak to the audience in a way that they are used to interacting with their device. It will improve conversion and bring your right content to the front. Great design apps are great performing apps. So why and how does design help? Well, quality wins every time. Our researchers have shown that users are willing to pay more for better quality. By using our Android design guidelines, such as our standard action bar, drawer, and tabs, you can create an environment that people will spend more and feel like it's the primary channel for your content. As you can see here, as your star rating improves, so does consumers' willingness to pay. We see a dramatic increase in monetization per user as ratings move from 1 to 5 stars. Further, tablet optimization emphasizes quality and purchases. Compared to phones, we have seen a 1.7x purchase rate on tablets. Also, we continue to make it much easier for your customers to pay as we increase our forms of payment. For example, direct carrier billing is now available for over 50% of Play users. And don't forget, you can respond to all your reviewers. Talk to your audience to get your ratings up and improve your app. As your audience sees you interacting with them and invested in their needs, they will provide valuable feedback and consider changing their review based on your changes. Not only does this help you improve your app, but ultimately helps improve the community of interacting around your app and their feelings towards your company. And don't forget, sizing correctly makes a big difference. The smaller your app, the less likely people will uninstall it and more likely they will to download it. People look for this stuff. They don't want apps that eat up their memory and drain their battery. There are ways to reduce these uninstalls. Uninstalls will ultimately hurt you in how you appear in the charts and search in the store. Always try to avoid these uninstalls. And don't forget, take advantage of all of our fun, unique Android features and best practices. Standout icons catch everyone's attention, and Android icons have a distinct style that our users look for. The app should be a silhouette on a clear background at a high-definition XXHDP. Make sure yours is optimized for devices and is an effective identifier of your app. Make a great playlisting that is very accurate and includes screenshots of both phone and tablets, as well as creating a great video for this listing. When you are marketing your app, create a Google Play badge on your materials and deep link it to your Play Store listing so your users can find your app easily. And finally, don't forget to have some fun with your app and engage your consumers in new and exciting ways using dynamic notifications, live wallpapers, and creative widgets. Thank you for taking the time to learn more about some of the best practices for apps and games on Google Play. We are excited to see the new version of your app. My name is Serge, and looking forward to working with some great app developers.
Hi, I'm Griff Hazen, an engineer with the Android Wear project. My team has been working on APIs to create rich notification experiences for Android Wear devices. Let's look at 3 aspects of wearable notifications: new display options, new features for notification actions, and advanced customization. This is the notification stream, a great way to get information and interactions in front of users. There is a vertical list of notifications of all shapes and sizes. To access a notification, swipe up from the watch face. Continuing to swipe will reveal additional cards. Notifications in the stream are added using the Android Notifications API. If you're already familiar with this API, you may recognize some of its features. For example, notification actions are available to the right of a notifications card on a separate screen. But just like on phones and tablets, notifications can still be dismissed by pushing the notification card to the side and releasing. Notifications on the phone automatically sync to your watch. This allows many existing Android apps to already provide value on the wearable. This extends to actions and dismissals too. We support many of the existing notification styles, like inbox, big picture, and big text. When content is too long, users can tap the notification to expand it. To make richer experiences, we've also added new APIs to customize notifications. They are part of the new Wearable Extensions classes in the Android SDK and support library. Let's take a look at some of these. First off, we have multi-page notifications. Pages can be used to add further detail to a single notification. They can be accessed by swiping. Indicators at the bottom of the screen show the user which page they are on. Since pages are just notification objects, they can use any of the notification styles. To add pages to a notification, use the Add Page method of the new Wearable Extender class. This code snippet adds 2 additional pages of content, making for a total of 3 cards. Also, as you saw in the previous animation, you can add a page that is just a full screen image with no card. This can be useful for imagery like a map or a photograph. When creating the notification for an image-only page, call Set Background to select a bitmap, and also call Set Hint Show Background Only to hide its card. Pages were useful for adding details to a single notification. Another new feature, Notification Stacks, allows grouping of multiple notifications together. Users can interact with the entire stack, or they can drill into individual items. Actions can be added to the stack itself and to child notifications. This feature can be very handy for messaging apps, where users may want to interact with all of your messages at once, or with just one. To create a notification stack, post 1 or more child notifications, and tag them all with the same group key. You can do this by using the setGroup method of Notification Compat Builder. Notifications posted with the same group key from the same app will be included in the same stack. You can also call setSortKey to arrange your items. If you like to select a background image and actions for a bundle, you can post an optional group summary notification. In this case, the user will see the Archive All action for the bundle. Make sure to select a unique notification ID or tag for each notification, otherwise they will override each other when posted. The notification actions shown so far have all used the default behavior, which is to be appended as additional pages to the right of other cards. The watch on the left shows this behavior. Swiping past the main card reveals the pause action. The watch on the right, however, shows action directly attached to the existing card. It makes the entire card clickable. Use Set Content action of Wearable Extender to place an action on a card. These actions are no longer displayed as separate pages. Remote Input is another new feature of notification actions. It allows the collection of text responses from users when they trigger an action. Users will be prompted to speak a phrase or select from a set of choices. The result of this input is sent along with your action's pending intent. Remote Input is an easy way to add Android Wear voice interactions to apps written for phone, tablet, or wearable. The code snippet shown adds a remote input to the reply action. When a user taps this action in the stream, they will be prompted to provide voice input under the label Quick Reply. Once text is transcribed and the user approves it, your action intent fires and it will contain the results. The recipient of your intent, be it an activity, service, or broadcast receiver, can use the get results from intent function of the remote input API to retrieve the result text. In the code snippet, the variable quick reply text will be set to the user's input. There are a variety of other options available in the remote input API, including support for preset choices, enabling or disabling freeform input, and support for more than one input on the same action. The standard notification templates may not be sufficient for the content you'd like to display in a card, so we've added a new API, setDisplayIntent.
Hello? Hello? Okay, so I'm on. Hello, everybody. Welcome to our session, Innovate with the Glass Platform. My name is Hyun-Young Sung. I also go by HY.
And my name is Pierre-Yves Laligan, but I go by PY.
And we're Google Glass software engineers. So today, we're going to first talk about some of the big changes that happened to our platform, one of which is the GDK, short for Glass Development Kit. And then we're going to talk a little bit about what changes we made to the Android to enable GDK, to explore the wearable form factor of Glass so that developers can take advantage of our platform. Lastly, we're going to show you two demos that highlight some of the GDK API and Android API on Glass. So around last November, we released the GDK to the public. And as of this year, April, GDK entered the preview mode, which means that glassware that was built using GDK can now be submitted to be listed on our My Glass website. Now, GDK is a supplementary library that you can use in addition to Android SDK to build GDK glassware. So we wanted to upgrade our platform so that everybody can use the latest Android API. So last year, when I was giving out a similar talk, our platform was based on Ice Cream Sandwich 4.0.4 API level 15. But as of this year, April, our platform is based on KitKat 4.4.2 API 19. This upgrade brought a new set of APIs available on Glass, some of which will be showcased later on during this talk, during PY and my demo. So SDK Manager inside IDEs such as Eclipse, Android Studio allow you to seamlessly download the GDK jar so that you can create your GDK glassware. And along with it comes some sample apps that you can also download to use as a template to write your own GDK glassware. As a matter of fact, a lot of the screenshots and videos that you're going to see later on in this talk are captured from these sample apps. For those of you who have not checked out the GDK yet, this is the web URL. And for developers who already have a Glass and who have a GDK-based glassware, the first link lists all of the checklists that you should check before your submission. And then the checklist is the second one. The first one is the form itself where you submit your GDK glassware. So enough with the announcement. Let's talk about GDK from a high level. So one of the first things that you can do with the GDK is make your glassware integrate with the timeline. If you use the voice trigger API, you can start your glassware from our clock screen using either voice or the touchpad. Using the live card API, you can draw into the timeline to the left of the clock screen. In this example, our Compass sample app is drawing the user's orientation into the timeline. But if you do not want to use live card and do not want to draw into the timeline, you can use card scroll view to create your own view, a set of views in an immersive mode so that it has exactly the same like swipe and flinging behavior, just like the timeline and glassware system apps. To create cards that goes inside the card scroll view that looks exactly a similar way as the glass system apps, you can use the card API. This API is not public yet. It'll end this API demo. This will be rolled out to you in either next or the following upcoming OTA. Contextual voice menu API will allow you to enable the voice flow within your own app, just like how we support the voice flow from our clock screen. And Gesture Detector API is the one that is optimized to work best on glass touchpad. As a matter of fact, this is the API that is used within our glass system apps and also some of our framework services. So if you want exactly the same touch behavior as the system apps, this is the API that will come in handy. There are some APIs that allows you to listen to the state changes within glass. On-HUD detection is a framework feature that uses the sensor facing toward your eye so that the glass will know whether you're wearing your device or where you took it off. This feature is used to optimize the state of glass. For example, if you're not wearing the device, then it turns off some of the services that doesn't really have to run to conserve power. There is a API within, so this intent API, which is part of GDK, is fired whenever they are on the transition edge so that third-party apps can also listen to it so that they can turn off some of the services that doesn't necessarily have to run when the user is not wearing the device. So there's more to the GDK, but everybody can read it on the website. And what I'm going to talk right now is what are some of the changes that we made to the Android to enable GDK. So this is a rough sketch of what the typical Android vertical stack looks like. On top of Linux kernel runs the Dalvik runtime, native libraries. On top of it is the framework, which is a set of services that support the Android SDK and applications sit on top of it. Now, these are some of the commands that you can execute to inspect each one of these vertical layers on both your glass device and on your mobile phone. As a matter of fact, this is the command that I executed when I first joined Glass to see what was there. So if you execute these, instead of the Android default launcher inside Glass platform, there is Glass something something APKs that represent various features that are already available on Glass. In particular, Glass Home is our version of the launcher that lets you insert your own glassware into our clock screen and also the one that renders the timeline. Boutique is the APK that downloads glassware that you turned on the My Glass website. When you execute that dump-sys -l command, you'll also see all of these standard Android services, activity, window, power, battery, and so forth. Two that we did change in our Glass are the location and account service, because compared to default standard Android, where everything is done on the client, Glass does authentication using the My Glass website, and that GPS information is piped through your companion app for better accuracy. There are some services that we inserted. Head gesture service monitors when you are moving your head around so that when you look up, that screen turns on. The eye gesture is what I just talked about when I was describing on-head detection card that monitors the movement of your eye, that also enables wink feature for wink to photo feature. And lastly, this timeline manager is the service that runs in the background so that you can draw into the timeline from your remote glassware app using the live card API. But for the rest, like we changed a little bit of native libraries, we changed a little bit of kernel, but we didn't touch Dalvik virtual machine at all. All in all, we didn't touch any part that a vendor building a mobile phone or tablet would have kept untouched. So at this point, I would like a quick show of hands. How many of you sitting in the audience have modified Android OSP? How many of you are Android developers? OK. So now PY is going to further your understanding of what we did on Glass platform. PY?
Thank you, HY. So I wanted to give you a little more perspective on all the work we've done on Android. So the graph you see here shows the relative size of the Android SDK versus the GDK. And as you can see, the former really dwarfs the latter. And I think that illustrates very well what we're trying to achieve with the GDK, which is we're trying to build a complement to the Android SDK so that you guys can continue building on a platform that you know and hopefully love, while at the same time taking advantage of what makes a Glass such a specific device. And a lot of it has to do with user interaction. And as you can see by comparing the first two columns, UI widgets make for a very small part of the SDK. So to replace those, we've added our own widgets to the GDK, but you can still very much take advantage of the vast majority of the Android SDK. So under the hood, same story. We haven't added all that much to the system server, just enough to support the services that HY talked about earlier. So all in all, at its core, Glass is very much a standard Android device. I think we really believe in the potential of this platform, and especially for wearable devices. So under those circumstances, what does it really mean to innovate on Glass? So first, I'd like to take a very short trip down memory lane. So not long ago, the rise of mobile devices has opened up a lot of new opportunities. Touchscreens, mobile data, sensors for location, acceleration, sound, paved the way for new experiences that were previously unfeasible on older computing platform. Well, we think that a similar wave is coming with wearable device, with Glass at its forefront. And it's very important to understand what makes those devices different. So in the case of Glass, the location of the device on the user's head greatly reduces the amount of time between user intent and action. And likewise, the availability of a heads-up display makes it so that you can very quickly serve information to the user. And all in all the hands-free features such as voice recognition, eye gesture, hand gestures enable the use of the device in situations that require the user's full attention and full skills. But that's not all there is to Glass. As you can see on this slide, there's a wealth of features packed in this small and light device. You could just as well take advantage of the BCT, that's the bone conducting transducer, the little speaker in the back of the frame, to notify the user instantly, without even turning the screen on. Or you could repurpose the button at the top of the frame to let the user give your app a very clear and fast signal. And I think there lies one of the big principles for designing and innovating with Glass. Really understand what makes the device different, its form factor and all its components, and learn to use all these features and combine them smartly using all the platform APIs. This is very important, not only to create new, compelling experiences, but also to overcome some of the challenges that inevitably come with new devices. And to illustrate that last point, I'd like to walk you through an example that's taken straight out of your devices. I'd like to talk to you about our web browser. So with a mobile device, a touchscreen makes it very easy to interact with the web. You can directly manipulate content. It feels very natural. On glass, of course, no touch screen, no such luck. But still, web browsing is very important to us in the context of search. So on glass, you can perform a search by saying, OK, glass, search, and then your search query. And sometimes you get a result whose snippet is, it's good enough, but you need to dig a little deeper. And that's where the web browser comes into play. So the first thing we did is actually really focus on that use case and get rid of things like tab browsing, bookmarks, et cetera. And it so happens that really narrowing down your use cases is about 50% of the work. And for the remaining 50%, let me show you what we did. So the context is you just run a search query, you have the result snippet, you tap twice to actually open the link, and you're directed to a web page. So at this point, if you put 2 fingers on the touchpad, you're entering browse mode, whereby moving your head around will pan around the page, and sliding the fingers up and down the touchpad will control the zoom level. If you let go of the 2 fingers and you're centered on a link, you're just 2 taps away from actually navigating that link. So there it is, getting to a page, navigating, finding some information, and optionally following a link. That's exactly what we want to do. And it turns out the experience, I invite you to try it, is pretty cool. It works well. So now I'd like to show you how we could build this if we were to replicate it. So the first thing you need to do is to monitor the movement of the head. So this is done through a standard Android SDK API, the sensor manager. So you want to get a hold of the rotation vector sensor and register for updates. So that's the first snippet. And as you can see in the second snippet, whenever the orientation of the device and so of the user's head changes, you get an update with 3 angles describing the position of the device. So that's how you would track the user's movements. The second step is the touchpad interaction. So for this, we created an API in the GDK, as HY mentioned, the gesture detector. So first, you want to add a finger listener, which will allow you to get in and out of browse mode depending on the number of fingers that land on the touchpad. The second step is to install a scroll listener so that if you so happen to be in browse mode, you just control the zoom level based on the delta. Very simple. Oh, and there's one last thing, too. You need to pass touch events to this gesture detector, and that's done by overriding this method in your activity and just passing the events to the detector. Very simple. So what we've seen is a way to combine some of Glass's very unique features together to overcome a challenge that's really specific to Glass. And we've used a mixture of Android APIs, so Activity Sensor Manager, as well as GDK APIs, the gesture detector. So I think we've talked enough right now, and it's time for some demos. Just one thing, though. So this session is meant to be very technical, and we're going to be showing more code. But if you're more interested in the design aspects of innovating on glass, I invite you to check out the talk that happened yesterday called Design for Wearables, I think. It will probably be online very soon, if not already. So for our first demo, you'll find it's very topical. You might have heard of this little sporting event that's grabbing the attention about half of the planet these days, and that's the FIFA World Cup. And if you so happen to be among the other half of the planet, that's soccer we're talking about. So it so happens that on the Glass team, we have a lot of avid soccer fans. And recently, a device has grabbed our attention, too. Oops. So this is the Adidas MyCoach Smart Ball. This is Adidas' latest entry in their line of personal coaching devices. This is not your average soccer ball. It packs a lot of sensors to give you feedback on your dead ball kicks so that you can understand and ultimately improve your technique. So we got a couple of these balls, and we had a lot of fun at practice, competing over who can kick the ball the hardest. Finished second. But very soon, the engineering cog started spinning, and realized, how cool would this be to actually integrate this with Glass for a totally hands-free experience, like not having to carry a phone or a tablet to get the results. So we met with a couple of Adidas engineers. We brainstormed for a while, and we decided to build a quick prototype over the course of not even a week. So let me show you what we did. All right. So first, we're going to switch to like a little program called Screencast that we showed last year that will allow me to share with you what I'm seeing on my glass device. Maybe. Drum roll. All right, let me try unplugging it, replugging it. The old recipes. Oh yeah, we have two devices, that may be why. So this is how you would use ADB, in case you're not familiar. You can use it over Wi-Fi. We're trying to use it over this cable. It's not working so well. All right, fingers crossed. Yay. And this is the demo. No, I'm kidding. All right, so the first step, what I'm going to do is actually start the app. OK, Glass? Start practicing. And so what this does is it actually tries to connect to the ball using Bluetooth LE. That's an API that became available on Glass with the XE16 update. And it looks like we're connected. That's truly a miracle. All right, so now we're ready. How about we take a kick? No? Nobody? All right, I'll still do it. So I just have to tap and tell that I'm ready to kick, and now. All right, let's see how I did. So now, basically, what the app is doing, it's communicating with the ball to fetch some data. If you use this ball with the provided app, what it does, it gives you feedback on your speed, your point of impact on the ball, the trajectory, launch angle, rotation, a lot of very useful data. So we'll see if it worked in that case. Oh my God, yeah, it was a lame kick. So as I mentioned, this is something we built like over a couple of days, and especially the mathematics part is not that solid, and it really needs like a clean trajectory to work. And unfortunately, like the stage is a little too small. But unfortunately, what we did is we built a demo mode inside the demo. So let's try it again. Start. That was a kick. All right, and let's see how it does. Hopefully, it won't be as lame as the previous one. All right. It takes a little while because it's pretty slow. Oh my God. Yeah, it's 51 miles per hour. So I get immediate feedback, and I can keep going, just trying another kick, and like all the results will accumulate, so I can keep track of my performance so far. And that's pretty much it. Very simple demo. So let's go back to the slide. So again. So again, I wanted to walk you through how you would go about building something like this. And reading this slide, I realized I forgot a part of the demo, which is, so it's fine to start a kick by tapping the touchpad, but when you're at practice, you've been running for a while, you're sweaty and everything, you don't want to have to reach for the touchpad at every turn. And so what we did is we just hacked the wing feature so that you could actually start kicking every time you wink, and that's pretty cool. I wish I had demoed that. Anyways, moving on. So let's see how we build that under the hood. So the first API we used, I won't go into too much details because that's a very well documented JDK API, which allows you to add an entry into the voice menu, like HY showed you earlier. So it's manifest-based, just like the launcher API. It's very simple. You can check out the documentation for this. Second step is to connect to a Bluetooth LE device. So this is done through the standard Bluetooth Manager Android API. So first step is to actually discover devices. So that's the purpose of the start LE scan method there. It takes an optional argument, which is a list of services, UIDs, if you want to filter your devices. But it turns out, so it's a bit buggy in 4.4.2, but there are other ways to work around this that are fairly well documented on the web. So we're searching for devices, and you found one. So then what you need to do is actually connect to that device. That's the role of the connect-get method in the first snippet. The third argument is a callback through which pretty much everything will flow from that point on. This is a very asynchronous API. So OK, so you start connecting, and then, if you're lucky, you get connected. And the next step is to discover services. So essentially discover the API that's available on the remote device. And again, as I mentioned, this is an asynchronous process. And you get a callback, and once you have discovered services, what you need to do is grab a hold of characteristics. So very simply put, characteristics are attributes of the remote device that you can read and write, and that's basically how you interact with the device. The second part of the slide shows how you read data, for example, from a device using a characteristic. You just issue a read command, and a little while later, you get data back. So that's more of a pull model, but the Bluetooth LE API also has a push model where you can request notifications to be sent to you on a given characteristic. So that's what this pretty complicated first snippet does for you. And then later on, if something like the state of the device, the remote device changes, you get a callback and with the values you're interested in. So for that particular demo, we used a mix of both push and pull, but that really depends on like the protocol that this remote device chose to implement. So next up is showing some UIs. We've seen examples of that shown by HY. The first API I want to use is the card scroll view. So this is a very standard adapter view. If you've ever used the likes of list view or grid view, you'll feel right at home. It's extremely similar. It extends adapter view, essentially. And will give you this nice card flipping and flinging behavior. The second API we use to create those nice little cards is the card API that HY also talked about. This is more of a, you can view that as a view builder. So you put your data in there, and then you request a view, and all of a sudden you have this nice little formatted view hierarchy. I invite you to use the two together because we've optimized them like memory-wise and speed-wise, and they work quite well together, as you can see in the last snippet that shows how in your adapter you can defer to your card object and not have to worry about things like recycling and such. So lastly, how do we intercept winks? As you can see, this is based on a broadcast intent. So the only thing you need to do is register a broadcast receiver. It's that simple. However, there are two things that you shouldn't miss. The first one is on the second line. You want to set the priority to a very, very high number so that your app gets a first shot at the event, because this broadcast is an ordered broadcast. And the second thing is when you receive the event and you've decided, OK, I'm going to handle it, don't forget to actually abort the broadcast event. Otherwise, it's going to get passed along to other apps. And you'll probably end up taking a picture, which is probably not what you want. I now would like to direct your attention to the little passive-aggressive message at the bottom right of the slide that says that this is a hack. So this is a very experimental feature. If you try to use it in an app that you submit to MyGlass, I'm afraid it won't go through the review process. It's not like we don't want you to use it, but it's still very much a work in progress. We have tons of work to do on the detection side to make it way more reliable. The second part also is that the API is not final at all. Right now, we're using broadcast intents, but we have several ideas to improve that. So we really don't want to pull the rug from under your feet. As a rule of thumb, if you stick with the GDK, you'll be in a good spot. All right, so that's it for the Adidas Smart Ball demo. So again, making use of several components of Glass to provide that experience. And again, a mixture of both Android APIs, Bluetooth managers, and such, as well as GDK APIs, such as card scroll view, card, and whatnot. So now we're going to show you the second demo. And it looks like HY is going to have some explaining to do.
OK. Thank you, PY. So the second demo that I'm going to show you also showcases how like the hands-free nature of Glass can improve outdoor activities, and in this case, cycling. That's the back of my head, actually using this device. So for the longest time, what I wanted to have while cycling was I wanted a rear view camera. And as of last December, we started rolling out some like kernel features, and one of them is OTG mode, that is USB host mode. And so, can you help me? Yes, we're trying to start my demo as I speak. Give me a second. OK. That is connected. This is a miracle. You're an amazing audience. Everything is working. And so what I did, OK, low sampling rate. Low sampling, yes. Okay, so what I did is I got a webcam and then I connected to my glass device so that I can see the video stream on my glass device. And right now we're using a little bit different mode than PY's demo because as you can see, my USB port is taken by my OTG cable. So we're doing an ADB over Wi-Fi. So now this, okay. Why are we not getting a screen?
They told us not to use any wireless technology for this demo.
So yes, I can actually like see all of you from the back of my head, but this is really unfortunate. Yes, I think the 2.4 gigahertz Wi-Fi spectrum is really maxed out. This worked like 5 times, but because doing a demo with a Wi-Fi is really has always this trickiness. I did record a video yesterday using this device while I was cycling through our Google main campus, and this was recorded using the screen record, which was another goodness that we inherited by upgrading to KitKat. And so as you can see, I am riding my bike, and this is what I capture from my rear view camera. And to demonstrate how easy it is to switch between cameras, this is the camera feed that is coming from the internal camera. And yes, there's a little bit of lag, but and then I'm going to switch to my rear view camera again, and using the options menu. And then the second options menu is, oh yes, I can see a shadow of myself riding my bike over there with this gigantic head. Oh, a big disclaimer here is that like this I built over over the course of a week, and this is really ugly and big, and wouldn't have never seen the light of a public camera if this was not an engineering or developing session. But the idea is that I wanted to show you that everybody in here can make this themselves too. Okay. So what did I do? So what is exactly on top of this helmet? So in an ideal world, all you would really need is a USB host mode enabled glass device and an OTG cable and a low power webcam. But life is not that simple, and so most of the webcam that you get from Fry's or your local electronics store requires 500 milliamps when glass can only provide 300 milliamps on a host mode. So that's why I introduced this USB hub. This USB hub serves 2 purposes. First one, so that it connects to the battery pack to charge the webcam, so that I can record as long as possible. And then the second important reason is that the USB device driver will not establish the connection if your peripheral device says, oh, I need more power than what you can provide me. So this USB powered hub tells the glass device, I don't need any power from you, and hence the glass is okay with it, and then establish the connection. So some of the commands that you can execute yourself to verify that everything has been properly set up is, the first one is ls-USB. It'll list 2 additional peripheral, well, it lists 2 additional peripheral devices for my case because I have the USB hub and also the webcam. And if everything worked correctly, we also modified the camera hell layer, hardware abstraction layer, so that you don't have to root your device. And all this change will be part of your upcoming OTA. So if everything is correctly mounted, you'll see that video 0 node mounted on the dev partition. But what you should look out for is that you should look at the kernel logs, and if the kernel logs say, oh, there's insufficient power available on this bus, then it means that that webcam that you purchased that you thought was a low power is not actually a low power one. So get a new one, or get a USB hub. So the beauty of the glassware that I built over the week is that it's less than 300 lines of Java code because the webcam can be accessed using standard Android camera API. So that get a number of cameras method it'll return to camera index 0 will be the internal camera and 1 will be the webcam. And after you set proper size and frames per second and pixel format, and then attach a surface holder to it, you can start a preview, which what you just saw. The direct rendering callback that you're going to attach to the live card, it is a subclass of the surface holder callback. It has one specific glass callback method, which is rendering paused. And this is what made this, partially what made this demo work, is that this responds to the visibility state of the live card. So when live card is no longer visible, that paused Boolean variable return true. And so at that point, release the expensive resources such as camera, which is what I'm doing here. So the 2 code snippet that I showed you earlier on is part of that my camera renderer class, which I pass on to the card surface holder as a callback. And if you remember from the demo, I used the options menu. But in typical Android world, you start your own activity and you draw a menu using it. But live card is a remote activity. So the way that this works is that, but thankfully, when you initiate a live card, you can assign a pending intent. And in my case, I assign an activity whose sole purpose is to draw the menu activity, and then so that when the live card is tapped, that pending intent gets fired, and my own activity starts my own menu logic. So to put this demo into perspective, all of other demos and PY's demo, it uses the USB port and some of Android default APIs, such as camera and the menu, and the live card GDK API to create this glassware. And I believe that this setup doesn't stop here, but it can be used in other application domains, such as medical, as an endoscope, or for car mechanics, they can create a borescope out of it. And for computer vision people, folks out here, they can use the second camera to do their stereoscopic analysis. And the sky is the limit, basically. So in summary, today we covered some of the APIs and tools that are part of the GDK, and that what we did on Android to enable all this. And we showed you two demos and one existing feature that explores the hardware components, GDK APIs, and Android APIs. And that's it. Thank you for coming to our talk. So if you want to, if you have any questions, line up behind the microphones. Yes, I think it's mine. Whoa, this is brightening. I'm going to go to a spot where I can see you. OK, hello.
Hello, Michael Prentice from GGG Space Coast. Last year's demo showed using a keyboard or other Bluetooth HID device. Right now, that's not working so well. Is there any plans in the immediate time frame to solve that, and also support for Bluetooth headset devices?
Do you want to take this one?
Sure. Yes, so right now we're aware this doesn't work anymore. I don't know if you remember, but last year the talk was void your warranty, like more of the hacking version, so it came with no guarantee that this stuff would stick. But actually, we are obviously interested in remote peripheral, especially with Bluetooth. So unfortunately, right now it's not a priority. When we get time to fix that, we'll probably fix that. And same thing with Bluetooth headsets. I think that's one of the top requested features. So.
But it's one of those things that I'm really working hard to bring it back as well. So yes, it'll come.
And by the way, there's a workaround for this, right? If you really need a keyboard, you can, over ADB, you can just use the ADB shell input key event command. And
61, I think, is a tab, yes.
Whatever, then it's the whatever key code you can send to the app. So you don't really need the keyboard.
So we'll take one from, oh yes, the screen.
Go ahead.
Yes, one from the back.
The back.
Are there any plans to bring back static card generation in the timeline in the GDK?
Not at the moment.
Okay, I have one quick question. Are you guys working in line with Android to work with the L release?
With
the L release?
Yes. As a
Yes.
matter of fact, I think during the wearable session, Timothy sort of like described what we were working on, which is we're already working with them to bring even Android Wear API to Glass, so that from your phone, when you get a notification, it doesn't only send it to your watch, but also on Glass. And a lot of that has to be done with the needs support from L release.
Matt Kaufman, GDG LA. In the past, there's been a lot of conflicts with Google Apps device policies. Is that something that's going to be worked on and making this more of a corporate tool than just a personal one?
Yes. So I believe we recently announced our at work program, and we have a couple of partners, and I think that's also one of the top requested features. So it's still a very early effort, but I believe device admin policies are among the top things we need to fix and make work on Glass.
Okay, thank you. Also, side question: did you try 2 cameras?
2 cameras?
Yeah, with the USB hub.
I did not, but
you will, I'm sure.
Yes, yes,
Okay.
I will.
Yes.
Hi. So I saw y'all recently added the contextual voice commands, which is really cool. But I was wondering if y'all are going to expand upon that, where like something like keyword spotting, where a user can sort of say something like next or like back or something, and they can navigate the app without having to change the UI and actually give them options to speak.
So just to check if I understand correctly, you would want something where you don't necessarily have to say OK Glass or provide a visual cue, but you just say next and
Right, like very lightweight keyword spotting that can navigate through an application.
It is definitely something that we are basically figuring out what kind of voice sections are within regular conversation is something that we are we're actively working on. But then all of these there can be a lot of false positives to enable this feature. So there's
that's why actually in the first place we added that keyword OK Glass, is to make sure that the user intent is clear, that you want to issue a command, because otherwise this is super noisy, really noisy.
Okay, thanks.
So one gentleman in the back.
Hello. I'm interested in the screencast viewer app you are using on your demo. Do you think you could make this available to Glass Explorers? It would be really helpful.
So.
Okay, I think we'll take that request back to the team. I think it's a fair request. I mean, we're obviously making heavy use of it, so let's see what we can do.
But for now, there's an Android screen monitor that you can download.
Yeah, I know, but it's much more laggy than your software.
Oh, okay. So yes, feature request accepted.
Thanks.
So with USB on the go, just over the horizon, are you planning to offer any other USB devices besides just the earpiece?
I
have no idea.
Yes.
We're the software people.
How about a boom mic?
About what?
A boom mic. A boom mic.
A blue mic. Yes, that's a great idea.
I don't even know what that is. One in the back.
In the back.
Could you provide some timelines for this L release support on Glass? I have had a lot of trouble making Bluetooth LE work properly, and I'm very much interested in knowing when the notifications would just work, basically.
Well, actually, they do. It requires some tricky bits, but I mean, they work certainly with that ball. I mean, I believe it depends on what device you're working with too, because it's fairly tricky. But as for the initial question on the timeline for the L release, I mean, the short answer is no. And not because we don't really want, but I don't think we know at this point for sure.
Okay, thank you.
Hi,
Raul at Pristine. Just wanted to hear your guys' thoughts on, have you guys done any like hardware, like video hardware acceleration using the H.264 hardware accelerator in Glass? If so, can you guys provide examples at some point?
264, so I think like overall Google is moving away from 264, and I believe the latest encoder that we have are VP8. So
Right, but VP8 isn't hardware. There's no hardware accelerator for Glass.
Right.
So
yes.
To get is there any way to get a hardware accelerated video then from a Glass unit?
Not that I know of. For this kind of stuff, I invite you to go to the Glass community and try to get answers there, because I know more people monitor that than people who actually come on stage at I/O.
Okay. All right. Thanks.
Yes.
In the back.
Okay, thanks. I may have missed this in the very beginning because I was late, but have you guys given any kind of time frame for updating Google Play services on Glass to be relatively standard and offer the same APIs as everywhere else?
Yeah, that's also something for which we have a lot of requests. We're working on it. Same thing. We can't really provide timelines, and I think, like in general, in the program, we prefer, in the words of our software director, walk the walk, then talk the talk, meaning that we announce things when they're ready, and we're not trying to anticipate too much.
Yeah, so like all of these things, bringing the default gesture detector, Google Play services is like features that we would like to have it on ourselves too. But then one of the priority was, because bringing up the KitKat was utmost priority, we like spent 4 months upgrading, and that was a lot of work. So there's a lot of things that is kind of behind that we want to get onto as soon as possible.
Okay, fortunately, thanks. I think we're running out of time, so we wanted to thank you again for coming to our talk. We'll maybe hang out a little bit outside if you have more questions. So, thank you.
Thank you.
It's undeniable. Website speed is a feature. Web performance optimization, developed with Google, explores performance patterns for world-class site speed. Dive into the critical rendering path, uncovering how browsers convert HTML, CSS, and JavaScript into actual pixels on the screen. You'll learn how to leverage recommendations from PageSpeed Insights and data from Google Chrome's developer tools to immediately boost website performance. For more information, visit udacity.com/Google.
Are you building apps for business customer? If yes, I'm going to tell you how to take your app to more than 5 million businesses by publishing on the Google Apps Marketplace. Hi, I'm Apurv Saxena. I'm the product manager of Google Apps Marketplace. You're going to learn 3 things on this video. First, what is the marketplace? Why should you publish on the marketplace? And how to publish on the marketplace. So let's get into the details. Google Apps Marketplace is the #1 preferred destination for over 5 million businesses that use Google Apps for Business. Admins come to the marketplace to discover high-quality, trusted apps that they can install for your domain. These are apps such as FlashPanel that have done great integration with the Google Apps Suite. FlashPanel is an admin tool that allows customers to manage and secure their domains. Another example is Mavenlink, which has done a great integration with Google Drive, Gmail, and Calendar. It's a project management app where once a task is completed, you get a notification in the email where you can understand the status of the task. You can share documents within Drive using the project management app, and also set reminders within Google Calendar. Admins can discover your app by going to the website or by going to the admin console. Once an app is discovered, the admin can install your app to a specific set of users or all users within their domain. So what happens when an app is installed in a domain? Once an app is installed, the app is accessible by the users in the domain through various touchpoints within the Google Apps Suite. For example, here, a Gmail user can access your app by clicking on the App Launcher drop-down menu. Here, for example, if the user clicks on Insightly, he is single signed on into Insightly right there from the app launcher. User can also access their app from the Drive Create menu. Here, an app such as LucidPress, a document and design and layout app, has done an integration with Drive. Once the app is installed, users can directly launch LucidPress from Drive and also store design document in Drive. They can even open Gmail attachment using LucidPress. You might say, all this sounds great, but how big is the marketplace? And what's its reach? How about 200 million? That's the number of seats that our customers have installed since the launch of Marketplace, and this number is increasing rapidly. But that's not all. Developers who have been successful on the Marketplace tell us Marketplace offers a truly differentiated experience than any other distribution channel. It drives 4x more paid conversion than any other distribution channel. It drives 2x more engagement than other channels, and also drives 1.5x in some cases of customer lifetime value for our customers. So let's look into how to publish on the Marketplace. To publish on the Marketplace, you need to first prepare your app. You need to create a project in the Google Apps Developer Console. In this project, you need to configure the Google Apps SDK and other associated Google Apps SDK that you need to build your integration. For example, if you are building a Drive integration, you need to enable Drive SDK and also ask for the Drive API access. Once you have done these two things, your app is ready for publishing. Publishing involves three main steps. You have to prepare your app, manifest and associated assets. Then you have to configure in the Chrome Web Store the publishing settings, and then you have to submit a app review form. Let's go into the details of each of these steps briefly. Publishing the app manifest tells us a little more information about your app. This app manifest should look very similar to the Chrome Web Store app manifest if you have published on the Chrome Web Store. Its only difference is the domain installable container, as you see highlighted in this slide. This tells us that you are ready to publish your app to the Google Apps for Business customers. Once you have built this app manifest and uploaded the corresponding app icons, you now need to go to the Chrome Web Store Developer Console, upload this information, also add other details like app description, screenshots, URLs, and also select the necessary category where you want this app to be listed, the region and the language. Once you have done that, you're now ready for the last step, which is filling out the app review form. We use this form to understand what integrations you are building and to make sure you're following the best practices as listed on the Marketplace documentation page. We also test out the integration to make sure the user experience is seamless. We also use this step to prevent any abuse and spam of the publishing process. This step usually takes no more than 2 weeks for us since the time of you submitting the review form. Once the app is published, your app is now visible to more than 5 million businesses, as I mentioned. But that's not all. There's one more step. You can also drive more installs for your app right from your website by clicking on the Integrate with Google button. This is a button that we launched 2 months back. It helps admins directly start an install process from your website without ever going to the Google Apps Marketplace. For more information on how to do Integrate with Google, please visit the Marketplace documentation web page. The web page also provides you more details about how to be successful on the Marketplace. In summary, Marketplace is the preferred destination for more than 5 million businesses that are using Google Apps for Business for finding business apps. It is also driving great high-quality installs for your app. And also, we have done a great job of providing 3 easy steps to publish on the Marketplace. So if you are a business app developer and if you haven't published on the Marketplace, what are you waiting for? Go out there, code, and we would love to see you on the Google Apps Marketplace. Thank you.
Hey guys, what's up? It's Rob Dodson here from the Google Developer Relations team, and today I want to talk to you about how you can create your own responsive UI elements using Polymer. Now, Polymer is a new kind of library for creating custom HTML tags, and with that comes the ability to do things like bake responsiveness in by default. That's a really awesome feature. As recent studies have shown, the average person is interacting with about 3 different devices a day, oftentimes beginning a task on one device and later finishing it on another one. Now, as web developers, it's our responsibility to make sure the experiences that we create work well in this new multi-device world. But HTML and CSS don't always give us the best tools for completing that job. That's where a library like Polymer can actually jump in and really help us out. Now, as I mentioned, Polymer is for creating custom HTML elements. Under the hood, it's actually using a new set of emerging standards called web components, which basically give developers access to the same low-level APIs that the browser makers use when they implement their own elements. Now, from a high level, that means we actually have the ability to create a whole new ecosystem of shared, responsive, performant HTML elements. And when the tools we use are performant by default, it makes the whole process of supporting the multi-screen web that much easier. So in this video, I'm going to show you how to create a responsive Polymer element. We're actually going to make a little collapsing toolbar tag that's going to take all of its anchors and put them into a little menu button. But most importantly, every technique that we cover here can be applied to any responsive element that we build using Polymer. Now, as we're working, we're going to be building something that's got to be shared with other developers. So we've got to constantly ask ourselves, how can I make this flexible for others to use? The first part in this process is figuring out when we want to change the appearance of our element. Every site is going to have different amounts of content and layout, and in particular, at different screen sizes, it's going to need to know when to update its appearance. Let me show you an example of what I'm talking about. So over here, I've got about 9 items in my toolbar, meaning my toolbar can only be about 900 pixels before it needs to collapse. But over here, I've got 4 items in my toolbar, so my toolbar can be as small as 500 pixels before it needs to collapse. Now, every site's going to have this same issue of having different amounts of content, so how can I create a responsive element that doesn't bake in all of its breakpoints? One option is to allow the developer to actually pass in a breakpoint, to actually configure my element from the outside and tell me when they want it to collapse. Now, to make this happen, the Polymer team has created the core media query element. Under the hood, the core media query element is going to check the size of the viewport and see when it matches a developer-provided breakpoint. Let me show you how that works. So over here, I've got a core media query element, and I've gone ahead and configured its query attribute to have a maximum width of 500 pixels, meaning when the screen size is less than 500 pixels, it's going to go ahead and set its query matches attribute to true. Now this means we can actually create our own binding called small screen and set it to the value of query matches. When the screen is less than 500 pixels, it's going to set small screen to true, and now any element that's watching small screen will know that it's time to update its appearance. So let's actually put this into our collapse toolbar tag. I've got a very simple Polymer definition here to get us started. And the first thing we're going to do is we're going to import that core media query element. Then we can drop the media query element into the template for our Polymer element. And lastly, we're going to publish that query attribute to the outside world by adding it to our attributes list. Then we can bind that value back to the query property on the core media query element. This allows a developer to actually pass in a breakpoint and have it reflected inside of our tag. So that lets us know when it's time to update the appearance of our element, but that brings us to the next point, which is how do we actually update the appearance of our element? Now, to do this, we're going to use one more feature of Polymer called conditional template bindings. As we know, from the top level of a Polymer element, there's a template for rendering content into the shadow DOM. But what's really cool is that this top-level template can actually contain additional nested templates which support data bindings. So if we use an if condition inside of one of our nested templates, we can actually bind to the value of small screen and only display content on smaller screen sizes. Now, as an example, I'm going to actually try to grab all of the links out of my toolbar using a content element, which I've placed inside of a menu button, which is inside of our template that's only going to render on smaller screen sizes. Now, from the user's perspective, the developer who's actually using our tag, their code is going to remain the exact same. They don't need to change anything. They just pass in a few anchor tags. They set the query attribute to max width 500 pixels, and now the toolbar just does the right thing. And I'll show you an example of what that looks like. So over here, as we start to reach that 500 pixel breakpoint, you'll see that all the anchor tags are going to jump out of the toolbar and into that menu button. And this is really awesome because if the developer using our element doesn't have to stress out about supporting all these different screen sizes, it means they can spend more time doing the things they enjoy, like adding really awesome features to their app.
Good afternoon, everybody. Thank you for joining us for all of these sessions. This is the last of the material design ones, and we've saved the best for last. Motion is a key part of everything that we're doing, and it deeply integrates into many of the other disciplines that we're thinking about. I'm Nicholas, and I'm here with a bunch of motion designers from across Google. To start with, Ari and I are going to talk about some foundational aspects of motion design, and then Helen, Manuel, and Gus are going to talk about actually applying motion design to different form factors we've got. It's only recently that motion has become deeply considered in user interfaces, despite a long history in other media. In film, movement has always been used for storytelling, and UIs that appear in film sort of reflect this. They support an overall story arc, but often lack substance. Video games have a similar problem in that they have these very immersive, stylized UIs, but they're very specialized to a specific kind of task. Traditionally, UIs are more versatile, and we see motion applied there, but it's often like a superficial layer applied very late in the process. So when we were thinking about all this, we asked ourselves, how can we use motion to truly improve UX? In the session yesterday, we talked about using motion to provide meaning, particularly taking user actions and connecting them to the events that follow. And this is sort of the nature of stories that show up in our UIs. Every app and feature and action tell a fragment of a story that propagate throughout the day and explain everything that has happened. Interaction design is also sort of informed by motion. In this album example, you can sort of see the sliding up and down of the album, and the ability to pull on it affords the pull gestures that can show or dismiss it. For this reason, like we like to try to consider motion as we're trying to do the interaction design to say, like, how can motion be used to indicate what is possible in these places and refine it down so it doesn't have to be as complicated. There's one other variable we like to consider when we do this is the user. In all of our stories, the user is the driver. And for that reason, we base as many transitions as we can on the user's touch, giving custom responses to every single gesture. This is why we liked the notion of an advanced material as the thing that we build all our UIs out of. The touch ripples and this sort of magnetic attraction of it to your finger reinforce the fact that the user is causing these changes. We want it to feel like you were the one giving life to the UI. This doesn't relate only to a single control, but actually to transitions that happen elsewhere. In this slowed down version, you can sort of see that the touch can affect other controls on the screen in a cascade of different delays that makes it feel like they're all tied to that original event. And the purpose of this is actually simplification. By hiding things inside of this energy wave, you actually can have a lot more detail in something that feels very simple and has a very clear cause. This combination of meaningful motion and user-initiated change are two core principles in our work. And they represent a continual dialogue between the user and the system and a way of teaching and training. It's really hard to get this right. And we really want sort of the essence of realism, but without all the extra baggage that's associated with it. Ari is going to go into a little bit more detail about how we accomplish this, taking elements of traditional animation and building upon them.
So Nicholas talked about telling stories and the dialogue between the system and the user. And there are really three main areas that drive the motion language for material design. And the first is familiarity. So we all live in the physical world and are grounded in reality for the most part. And motion in our UI is really key to support that material metaphor and bring that familiarity to our user experiences. So our environment is a shared stage, and all of the action takes place there. And there are visually consistent shadows across platforms that provide a visual indicator of the layering as well as the separation between surfaces. And this environment is proportional and bound to the device that you have. So for example, the thickness of your phone. And to that end, we want to make sure that we avoid extreme motions like camera zooms or large rotations that break that environment and take us out of the experience. We also represent surfaces as solid objects that can be directly manipulated. So we use motion to express material special properties. It can split apart or join back together without tape and dynamically transform and rescale. We can also use changes in opacity when transitioning to or from high speeds to imply motion blur and avoid fading in or out in static states to maintain the feeling that the paper is solid. We also really want to use motion as an affordance and express the transfer of energy from the user into the system, and use this motion to tell the story of how that input propagates and resolves across the system, whether there are hard constraints or forgiving boundaries. All of these are familiar indicators that help us understand how objects can be manipulated. Motion should also be responsive and fast. There's no need to bounce because the material is precise and arrives precisely and smoothly at the target. We have a set of animation curves that you've seen across many of the examples, and those are incorporated directly into the framework. And you can also customize those curves with the new path interpolator in Android L. Choreography is how we guide our users through the experience with thoughtful and consistent motion. When transitioning between spaces or activities, we want to use motion to complement the spatial model of your app, and consider motion and the articulation of these surfaces in the first place when designing how your app is put together in space. Beyond the acceleration and deceleration of objects, we can also express character by the path that move along and moving using curved paths. And natural motion tends to follow an arc, for example, throwing a baseball through the air or the path of a skier down the mountain. And we can apply these ideas into our transitions to make them feel less mechanical than when they are constrained along a straight path. And here you can see this dynamic arc can create fun paths to or from any position on the screen. And you can do similar things in Android L by now supplying a path into the object animator. So in addition to the path objects take and the character of their acceleration, thoughtful timing of actions is critical to building meaningful transitions. We want to sequence actions to guide users' attention around the screen or draw their attention to promoted actions, build understanding of the changes that are occurring, and indicate individuality or grouping of elements through synchronized motion. And in addition to familiar surfaces and coordinated motion, craftsmanship is really the manner in which all these principles come together to create a really compelling experience. And attention to detail and a well-considered motion at all scales can bring delight and clarity to your users. So at the largest scales, we want to create transitions that connect the user's action to the resulting change. Motion can bring clarity to the changes in context and improve the understanding of the relationship between different spaces. And animation at smaller scales can tell a story when space is limited. For example, these micro transitions can give cues about the changes in state or reinforce functionality through motion or drive discoverability. And these principles around familiarity, choreography, and craftsmanship have really been the foundation of a lot of the design work we've been doing recently. And now Helen, Manuel, and Gus are going to talk a little bit more about how we've put these to practice in desktop, handsets, and wearables.
I'll be diving into detail about the ways we've been exploring the loading experience in ways that alleviate the wait time. So loading, an often overlooked but an extremely common occurrence, is an opportunity for consistent control across different contexts. We started off by combining a refresh icon and a loading spinner for a seamless and simple correlation. Spinner is the original activity indicator crafted in detail with an organic pattern. playing with how dynamic colors can complement the whole system and framework. And in this scrolling instance, the spinner is paired with an ink splash inspired by the touch ripple effect to indicate an initiation. Our suite of progress and activity indicators, circular or linear, are designed with synchronized cadence. Whether it's a swipe down to refresh on mobile or opening a message on tablet, acceleration curves and rotational rhythm are choreographed to follow the same organic pattern. We've also thought about how these can be tailored to a variety of uses. In this Chrome OS update instance, we thought about how the indicators can behave like bookends for distinct beginning and end. A field of color marks an initiation, and an equally dramatic ink splash punctuates a marker of completion. On top of all this, we thought about how an image would load, and we were inspired by the way photographs are exposed onto paper and developed in a darkroom for a natural and familiar process. We've broken it down to 3 basic phases: opacity, exposure, and saturation. The image would fade in at a low contrast exposure, followed by a full color saturation. Form factors with larger surface areas are the ideal places to pronounce this type of image treatment, such as logging into Chrome OS.
Thank you. Hello. So Ellen showed you a Chrome OS example, and I'm going to talk to you about some of the way we use motion on Chrome across desktop and mobile. OK, so in the case of a desktop or laptop OS, we're dealing with many windows on the screen. And depth is key to ensuring users feel in control of their experience as they change applications and kind of manage their experience. So here, we're using material shadows to communicate quite a bit of depth there. Now see what's happening. The UI is actually not being scaled up, even though it looks like it's coming closer to you. Simply by using the right curves and the appropriate durations and the right properties on that shadow, you create this nice, crafted, smooth transition. We've all seen shadows like this. The fact that it's nicely transitioning like this creates a great continuity between the states. Moving on, this is Chrome OS. You guys know Chrome OS, Chromebooks. In Chrome OS, we have an app launcher. And this app launcher has this feature now that allows you to group applications. On Android, you can do that too. Now, on Chrome OS, the app launcher is already a floating box. OK, folder usually opens up as a popping box as well. We don't want to do that. We don't want to open a floating box on top of a floating box. So in this case, we're using material ink and material response, where ink is shrinking and growing and creating this nice ink bubble metaphor for a folder. And so you see the same bubble kind of appearing, disappearing, and throughout the different states that you're going through as a user. It creates this familiar thing there. It's really nice. Next, let's take a look at a Chrome for mobile prototype. Here, we're looking at finding a way to transition from very different states. See this right here? That's a very different state from this one. All these icons are there, and then they're not there anymore. And if you just flip a bit in your code, you hide, show, and it's not going to look very good. In this case, imagine the person's touching the screen. Boom. A circle of energy flies out of there and pushes items out of the way, back into the scene. It feels like you're creating the story for the user through choreography and motion. Finally, let's look at the Chrome OS again. Large screens present quite a bit of a challenge. You've seen a lot of examples of smaller mobile screens. Now, making something fly up and down that screen may not be a huge issue. Imagine you're looking at a screen that's much bigger, like 20-inch, for example, or 17-inch, even a 13-inch laptop. You want to avoid forcing your users to scan around, like, is my window coming to the left, to the right, to the left, and it's just crazy. So one way to do this is exploration. We're looking at ways to go whoops, have very short animations to show, hey, the window just went toward the close button, or the window just flew from the button on the taskbar, therefore probably opened the application, things like that. So even though those animations are really short, because we're using the right curves and material, and we're very thoughtful about the way things are moving on the screen, you create tangibility and familiarity to animations and communicate those states really well. Now, you've seen really large screen now, and challenges and solutions we're exploring. Gus is going to show you similar challenges and solutions for tiny screens like this.
Thank you, Manuel. You know, I just love motion design. I think it's a powerful design tool, and still it can be subtle. And we use that a lot when designing for wearables. So because of its small screen, we don't have space for multiple panels or different buttons for every action that we can take in every screen. And nor we have space for white space. So in order to fully express the material design language on such a small screen, we needed to use a lot of motion design to cover for all those functions and also to make the device fun and easy to use. So right from the start, even before you start interacting with the device, we have added a simple animation that explains the structure navigation of the wearable device. It's a pretty simple one. You scroll up and down to navigate through different pieces of content, and you swipe right to dismiss a content. So even though it's pretty simple, it's just enough to get you started, so you feel comfortable using the device. As you start using the device and you face situations you have never encountered before, motion design is there to suggest how to interact with it. So in this case, incoming call, you swipe one side to accept the call, or the other side to reject a call. We then end up with a very simple stream of cards where we show one content at a time. And so we quickly realized that it was very important to work on the transitions between those contents. So we orchestrated all elements present on both screens. And for example, the acceleration of the card, the crossfade of the background, and the parallax movement in order to make these transitions feel smooth. And actually, we want to feel invisible, because you're going to interact with it a lot of times. We have also brought animations that we are used to in other devices to wearables, not before making some tweaks and improvements. Let's take, for example, the nod animation. So nodding is something that we do every day when interacting with other people. When we are talking to them, we just nod to acknowledge their presence, to give a non-verbal feedback. And it helps to create a friendly environment for a conversation to take place. So we wanted to take this environment and bring it to our UI, and we use that with a nod using a very simple motion design. We have also created a full set of animations that they all cover a very specific function in the UI, but we have crafted those animations in such detail in order to make every micro interaction feel rewarding. So let's take the sending a message, for example. So you have just sent a message using your new wearable, using your voice, without even touching your phone. So that's a pretty amazing task you have just accomplished. So we wanted the confirmation animation for this task to be as awesome as the task you have just done. So we crafted every animation with a lot of detail. And the boot sequence. So we have done a boot sequence that when you start looking at it, as soon as you turn the device on and you see it running at this high frame rate in such a small device, it immediately suggests how powerful the device is. And it sets the tone of how you're going to interact with it from that moment on. Nicholas?
So these guys gave you a good idea of a lot of different applications of motion, and each is tailored to the specific form factor. I wanted to go into a couple opportunities that we saw while doing all this work. First, use motion to tell your product story. As Gus showed in that, like sending an email confirmation, it was a moment for a lot of personality and had sort of a celebration for an action that was itself pretty impressive. We want you to find moments to make your apps truly shine and focus on those. Beyond that, use the frameworks. The elements will cover many, many of the use cases you're going to have with animation, with a standard set of behaviors. You want to build on those, but then also pick moments to enhance. So using things like the shared element transitions, which allow you to persist an element from a state to a state or even between apps, or refining an existing component using theming or just building upon it, is a much better approach to doing this stuff, where you are spending your time on the most impactful portions of your app. And last, make motion part of the process from the beginning. There's so much stuff that has emerged from us working between motion and visual, motion and interaction, and seeing how those disciplines can build off of each other and enhance each other. It's really critical to get a polished result. Many of you have probably already looked at the spec. The motion portion of the spec is probably the richest and most complicated. It's definitely worth looking at. Ari and the others have put a lot of thought into sort of the underlying physics and behavior of these materials, and there's a lot of detail in there. You're also, please visit our design site and also get in touch with us at the Plus Google Design page. This has been a really exciting project for us, and we've been really excited to share it with you, but really this is the first step, and we have a lot of distance to go before this is finalized, and we really want to see how it applies to all of your apps. Thank you very much. So we're happy to take QA now. We'll also be up here afterwards if you want to come chat with us.
I had just a really brief question. Your little refresh icon spinner thing was awesome, and is there any way we can have it? Like, is that like just something you guys designed for this stuff, or is it somewhere in Android hiding in a folder?
That is the standard Android progress indicator, so it should pick up theming like any other element.
Sweet, I hadn't seen the arrow part on it. So.
The arrow transition is a customization of it. I'm not familiar with how we actually go about doing those things, but.
All right, well, it's sweet, so thank you.
Thank you.
Hi. We've seen all those animations, and they look really amazing. When I look at that and try to think how I would do that with the current Android API, I feel like shooting myself. I've seen some of the presentations for the new APIs that are coming out, and I assume that all that animation is going to be much easier to do now with the new APIs.
Yes. Yeah, we're making a lot of progress in that direction. So for example, like moving things along curved paths, the object animator. I'm a designer, so I may not get it totally right, but the object animator can accept a path, so you can animate X and Y concurrently, create on a spline path, as well as the path interpolator. So you can apply customized acceleration, deceleration curves with cubic Bezier, and pretty much the same format as you would with the CSS.
OK, thank you.
Hi. In the beginning of your talk, you showed how elements don't need to bounce because they just arrive at the destination perfectly on time. But in the Android Wear, you showed how the red circle G kind of bounced down then out, like in its not animation. So how do you balance those different animations and when to use them or not?
Okay, so I think the bounce animation is a different and specific animation to make the user feel that the feedback is a visual feedback for the user input. So for all other animations, we do not encourage a bouncy animation. I would not count the nod animation as a bouncy animation. It's simply a movement, a natural human movement that we incorporated into the UI as a feedback.
Gotcha, thanks.
I'll just add on to that for a lot of the transitions that we're doing, we're really perceptive to motion. So having secondary motion or really kind of like bouncy stuff sometimes can draw your attention to things that you don't really want people to look at.
this is a personal obsession of mine, so I'm going to go into a little more detail. We like to think of this like technologically advanced material as something that is driven by the system, and the system understands physics, and it can understand how to place something exactly where it needs to be and not like wobble as it hits there. But at the same time, it needs to be very responsive to the user. So if a user is pulling something past the bounds where it needs to be, to just simply stop would be almost hostile. We want it to accommodate the user, but in the times that it's moving things, to also land them perfectly. And so it's balancing the two of those things to get the right feel, as well as the right amount of sort of forgiveness when you pull past bounds.
I'm a UX designer. When I saw your motion design talk on the schedule, I was so happy. Not many conferences have a motion design talk, so I'm so glad you had it. So I have two questions. One question is, what tools do you use for prototyping motion? The second question is, your decks are amazing. And I'm curious to know what tools you're using for presentations.
Yeah, I think, well, a lot of our motion designers use After Effects for just some initial studies, but of course that can only get so far when so much of this motion is tied to the interaction and how it feels. So there's kind of that diminishing return as you go past the point to get an idea of like, okay, this is a direction that feels good, and then we really try and start working with engineers and prototyping to kind of like start seeing it on a device and feeling it to know if that's actually a right decision.
Yeah, I'll jump in and just, can you hear me? I'm going to add one more point. So all the examples I showed, I'm a UX designer, but I like to code things to try them out. I love to kind of push the browser, see how fast I can render stuff. Right. In any case, all the stuff I showed were actually video, QuickTime, like screen recordings of interactive prototypes I built using just HTML stuff, also Polymer. I really enjoy doing that. So like the window control that's coming in now, that was custom element in Polymer I built. But yeah, HTML is, I found great because then when you communicate these animations to engineers, like they can look at your code, or you can just copy and paste your variables, and they're like, oh, yeah, that's the curve. You know, like it talks to them really well. So, but different designers work differently. The After Effects tool is really awesome for doing a lot of things too. So, yeah.
And even basic blocking of motion, I think, is very effective, particularly if people are using sort of the standard curves. As long as you're sort of explaining how things move from state to state, it's more than enough to understand. It's just think about state to state rather than just sort of assume that it's gotten there on its own.
Yeah. Cool. I'll also add that motion design has been a really interesting point in the process of developing the system and apps where it really forces UX designers to work with engineers to kind of like get these ideas and make sure that those kind of concepts are carried over into the final product. So it's a great opportunity to increase collaboration and also help build some understanding on each side. So as a designer, I'm starting learning more about XML, so that way I can tweak stuff myself and make sure I pass along the right kind of information, also take the right kind of considerations when I'm making designs.
Thanks.
Hi, you guys mentioned using the frameworks. And so my question is, if we're trying to design an app that works in HTML and on Android and trying to make the look and feel be obviously as close as we can, say loading an image or progress like the examples you guys used, how much of a framework is there? I mean, are you guys focusing on trying to put the same look and feel for motion into these different frameworks, or are we still at the stage of sort of wireframing it and handing something over to our HTML guy and our Java guy and saying, figure this out? Or are the frameworks working on giving us more common tools between this so that our image loading looks exactly the same between an Android app and an HTML app?
We are doing our best to coordinate the appearance and the behaviors across the platforms to be highly consistent, if not identical. Things like the standard controls, like stuff like the ripples that you see on stuff, or on elements as you tap them. Like we've been very concerned with making sure that the same formula or logic is used for the way they move, so that they are as close as possible.
And we're talking about Polymer framework
Polymer
here? Okay. All right. Great. Thanks.
So you guys talked about the continuous motion and things not stopping immediately and things like that. Have you taken a look, or has it changed anything? Android's list view, for example, when you reach the top, it's always just stopped. Is that something that you're looking at changing, or how do you look at that from a motion perspective?
We're continually iterating on that class of animation. Like, we're looking at how refreshing works and how the ends of controls work with loading more content. That's something that we're still working on for the final L and trying to get that all nailed down.
Cool, thanks.
Hi, my question is about the process. I'm just curious, what kind of decisions do you have to make while finalizing the design, and how difficult is that, and what are the possibilities you're looking at, and how do you finally narrow down the details of the motion that you're creating?
Well, I think I can answer part of that, but Nicholas talked a bit about how motion design, really trying to promote that as a peer to visual and interaction design, and really integrate that throughout the whole development process. And I'm sure you've found, many of us have been in situations where you go from, you get some wireframes or you get some visual designs, and these things have been done in sort of a sequential process, and then you say, okay, we need to make a transition from this state to this state. And you're like, well, that might not actually work because this certain transition or this kind of motion wasn't really considered at the point, so you kind of get a bit of churn there. So that's why we're really trying to kind of make sure that when you're thinking about interaction, and it really helps with the whole material metaphor, because sometimes you can actually just take some paper and think about how would these surfaces actually articulate against each other, and how would I get from one place to another, very, very lo-fi prototyping ways. So trying to just make sure that you're thinking about the motion if that's part of the transition or part of your app throughout the whole process.
And engaging with engineering early too. That's one of the things we realized. Is just, you need to sanity check many of these things. These guys make some crazy aspirational stuff that, like motion blurs and other things that are just not feasible. So just getting a sense of what is actually possible, and then refining those animations, like within the bounds of what is possible.
Regarding the part of your question of how to select the best motion, sometimes we make different versions of every animation, and you might think a lot about it, but once you see it, usually on the device, it starts to feel right, and there's a lot of decisions that you simply feel that it's the correct and more fluid and faster way to make a transition.
Okay, so a lot of testing involved, I guess. Yeah.
Yeah, if you do have user testing going on in your team, everybody can look at that, the numbers, and see how it improves as you iterate stuff. But I like the point of starting early. It's very important, like the Chrome stuff I was showing, like the visual layout. Everybody was talking together on the team, and very early on, like, stuff started moving around, and this is too much, this is too little, and we got a chance to look at it early on, and just iterating a lot, and that communication flow between the different people on the UX team as well as engineering is super important. So they feel included too, and you don't dump something on their lap that's like super outrageous. It may be the right design, but and that's more like team dynamic kind of strategy stuff, not really UX. But
and also kind of to when Gus was talking about the nod, and even in the visual design talk about thinking about the brand and your color story, think about the character and maybe the personality of your app. And if you kind of understand that app is like a person or a personality, then that's a really good bar to kind of keep your motion tied to. So if it's fun or familiar or serious or quick or assertive, whatever it might be, that's something to help keep it consistent across.
Okay, so there is some logic to it, the way you come to decisions.
Yeah.
Hello. You show examples of this material design being applied like to phones, watch, laptops. Have you also considered auto, and what could potentially be different there, given the fact that the user just glances at the screen of the car and could potentially miss some of the animations, or maybe it's actually better to highlight what are the most important actions? Have you given any thought to that?
I don't think any of us have worked on car.
No, I think, well, no, none of us have worked directly on the auto stuff, but I think what what we're trying to express with the principles is that there's a real range of possibilities, and really understanding your target audience. Just like the personality of, for example, on a car, you don't want to have lots of motion that could be distracting. You want things to be really concise. Same way on the wearable, where you don't maybe have a lot of real estate. Motion is really an affordance to indicate what options there are, how to manipulate the interface. So there's. Sorry, go ahead.
These are very focused on sort of active, attentive interfaces. I think on car, the tools you'll see used are going to be more focused on like using change blindness to actually have animations that deliberately hide change so people's attention isn't drawn, or rarely are used to explain hierarchy when you actually are engaged. But there's a whole separate set of things that are probably warrant their own talk.
Yep. You've seen back there the projections that have all these motion of the UI for the Android Auto. It's pretty neat stuff. Maybe you can talk to people there. They would answer your questions. The one thing I would say, having worked on car stuff before, is like, not only there's a problem of like not distracting the user, which is very important, but also the screens they use in cars. The reason why they're not as fancy as tablets, because they're really rugged devices that are automotive grade, and so they have to deal with a lower frame rate often, and the touch response may be a little slower. So there's a lot of challenges there. The animations have to be designed a little differently. Although what they show there is pretty cool on the big screen, so go talk to them.
Thank you.
Hi. When it comes to actually practically implementing a lot of these animations, how well? Two questions. One is, how well do they gracefully degrade down to something like gingerbread device, and then how backwards compatible are they with something down as far as like ICS or something?
Yeah, I don't. I wish we had one of our engineers to talk really about the full backward compatibility story. But I think there's a lot of new APIs in L specifically to enable this kind of stuff. For example, like the native shadows and the the object animator with paths and the path interpolator. I think there's a similar story to the visual design, that if you design for kind of the high end, it's easy to kind of pare back and start thinking about, okay, what elements of this transition can we degrade for devices that don't have some of those features.
And I think one other important point is to be conscious of the things that are only indicated or afforded by motion. Like it's often better to have additional affordances. We generally couple like the dimensionality with motion to indicate that this thing is movable. Allow it to be capable of falling back on something that's a little bit more static.
Cool. Thanks.
I'm going to ask a somewhat antagonistic question just for the sake of discussion. In the last, I don't know, since the 1970s, people have been talking about escaping the metaphor of paper on the internet and using more dynamically generated content and not being limited by the real world. What are the weaknesses of the paper metaphor? What are the weaknesses of material design as people are trying to push other ideas forward?
I think the things that we have run into is when we over-apply elements. Like I think one of the examples from visual design was like when everything's on a card. It's too easy to fall into the trap of like, I want a great deal of contrast between different elements. This is also true of motion. It's pretty easy to try to animate things that aren't the right thing. One of the key drivers of the motion we've been doing was deciding how you're going to manage the user attention. Like you want to move things in such a way that your eye catches the last or the first thing, but very deliberately chosen. And that we avoid having things moving counter to that or creating sort of disturbances. Yep. She asked about how the system itself might hold back other ideas. I'm trying to think. Generally, we've been trying to be so flexible about the amount of theming and structure in this stuff that it is actually looser than many other systems, even though there's a lot of baseline elements you could use. The thing is that generally when you run into a problem with the system, like these are intended to be guidelines. They're not intended to be end-all be-alls of what it should be. They're starting points. And part of what we're trying to do with Polymer and with Android is establish a baseline level of quality that you start with and then can build upon. And as we see people applying their brands to apps or just sort of building them out, we want and encourage them to take this and build on it and make something a little bit more extreme or tailored to whatever their specific use case is. But this is sort of the baseline set of elements you start with.
And also, we've tried to really be considerate in how broadly they can be applied, because as you saw in the keynote, there's a lot of different platforms being announced, a lot of different form factors, and each one of them has their kind of their own nuances for what kind of depth and what kind of surfaces that we want to represent. So I think as we continue to evolve those platforms, I feel like we've set up a system that has enough kind of flexibility and dynamic range that we can grow on it and expand it to accommodate those.
I thought of something. If the illusion gets broken, it's a big problem, and this can happen in many, many ways. Like dropped frames due to if an animation should lose frames, or the perception of this thing as being realistic is violated. That is one of the ways that you recognize these as failings in the UI, and that's why we're trying to avoid things like jump cuts, or trying to focus on very specific tailored animations that aren't part of a larger system that's not totally resolved. Having people's sort of primal understanding of dimensionality and shape relies on it being internally consistent and not overbearing. And so trying to balance how much to do and avoid the times when it's too much or it falls down.
And we'll hang around if you want to chat some more.
Any other questions? We'll be up here if you have anything else. It was good to see you all. Thank you very much. Thank you.
Developing Scalable Apps, developed with Google, is your guide to the most efficient way to build scalable applications on Google App Engine. Learn how to architect and build highly scalable, reliable apps by leveraging Google Cloud Platform. This class covers concepts like platform as a service, infrastructure as a service, data storage, caching, cloud endpoints, and more to help you develop a highly scalable backend that works seamlessly with both web and native mobile apps. For more information, visit udacity.com/Google.
Hello.
Hi.
Oh, hi. Today we are talking about YouTube and design. YouTube's grown tremendously over the last 9 years and now has a global community of users. And that is a really interesting design problem.
I mean, if you're going to have a problem, that's a good kind of problem to have, right?
Oh, yes, but it presents a challenge. And that challenge is, how do you design a product that looks and feels consistent when it means something different to everyone who uses it? Most brands have a pretty clear idea of how they want to be represented. But at YouTube, our challenge is that YouTube represents everything from delightful and silly content to serious and sensitive stuff.
That sounds like a pretty crazy challenge.
Exactly, exactly.
So why don't we share the story of how we took on that challenge and captured YouTube's brand?
Yes, sounds good to me. Everybody, this is Josh, and he's a product designer at YouTube.
Hi, and this is Michael. He's a marketing designer.
Yes. We work together on YouTube's user experience team. And Josh, let's tell these folks what they can expect in this video.
Sounds like a good plan. So in the next few minutes, we're going to cover a few things. The first is how a traditional style guide can actually be something much, much more than a style guide. The second is understanding your brand's identity through its community of users.
And then we can wrap up with some tips and tricks for how you can use this in your own work.
Cool. So we represent a collaboration between UX design and marketing, and we actually started building a traditional style guide, and then we kind of decided that we needed to do something different, and we ended up with something much, much more useful to our team. So here's just one page from what the style guide looks like.
Right. The guide we created lets teams at YouTube jam together on product design and content creation by speaking a common language. We can't go through the entire resource in this video, but we're going to share some of the content and process that went into turning YouTube Style Guide into a thought guide.
A thought guide? What's a thought guide?
Well, what do you think I'm thinking right now?
What are you thinking right now?
Yeah.
I think you're thinking that when YouTube first started, it was a video dating site. Am I right?
Yes, you are right, and
All
that
right.
blows my mind every time. I love it. Good job.
Yeah, so since then, the site has evolved into an entire service, a huge service, and the video content on the service has grown up too.
YouTube is a platform for community movements like It Gets Better Project, memes like the Harlem Shake, and serious subjects like political uprisings captured on mobile phones.
And obviously YouTube gets all of its content from its users, so that means that our users are kind of designing our product with us. So why wouldn't our style guide actually reflect that?
Exactly what I was thinking. So we think it's way cooler to design with our community than for our community. I mean, not that we're not designing for our users, we are, but I mean, you know, like with them, like we feel like family, like the Brady Bunch.
Yeah, but that kind of presents a second question, doesn't it? Like, who makes up YouTube's community?
Well, you might think it's just people watching videos, but it's more complex than that.
So complex, actually, that we spent about a year doing research with users to learn how they interact with and relate to YouTube's brand.
Yes, here's some of that research. Here's a page from a diary study, and that looks like somebody using their tablet on the toilet. Is that accurate?
I'm afraid it is.
Well, that's fantastic, because we can use that. We like data. You know, sometimes research and analytics are used to solve a really specific problem, like how to improve task completion or click-through rates.
We were actually curious about larger communities and their needs on our platform, not just a specific persona and not just the people that are watching videos. So going back to that question, like, who really is everyone on YouTube?
Right. The YouTube community is really complex and diverse. There's a lot of people viewing videos, but that's not everyone. You know, there's also people making really interesting content, creating original videos, vlogs, shows, music, all of that stuff.
Yeah, and actually another thing that we found interesting is that advertisers were uploading amazing content and collaborating with our creators to make commercials and ads that people really loved to watch and actually wanted to share.
Right, so the research and digging into experiments, data, and YouTube's history revealed that there's real tribes of people collaborating on the platform. And that information is so much more interesting and valuable than it is for us to invent personas or to design for just one kind of user.
Yeah, so a style guide is usually there to document a brand in one direction. It's like a photo from one perspective. And we wanted something a little bit more dynamic, something that was more like a mirror that reflected principles back on the community.
Right, so if we had a mirror like that, we could use it to determine the success of our design solutions or campaign creative, the new metric being authenticity.
And it was that idea that started to turn our style guide into more of a thought guide. And it began by curating words that described our brand that would reflect the personality of YouTube's tribes. And then it actually guided product design. And it also helped craft marketing efforts.
Yes, the words. The words are connected, human, spirited, and simple.
Awesome, words!
Woohoo!
Words!
Words.
So we have these words. What do we do with these words?
Right. Okay, so words are good. Words are good. They're well-meaning words. But we need actionable principles, right, that we can actually work with. So let's take connected as an example. We've identified our tribes, right? Creators, advertisers, viewers. And individually on connected, they're just floating out there in space like little stars. But say we do something, right? We create a product or an experience, and we try to solve two of their needs and connect those groups. Well, that's great, because now we've got a line, and that's good, right? But you've still got one kind of floating out there.
But what if we actually connected all three and we made a constellation, which conveniently looks like a play button, right? Gorgeous. Whenever you have 3 points connected, connecting your community together, you can actually triangulate your position, you know where you are, you know who you are, and you kind of know where you're going to go next.
Yes, exactly. And you know, chances are if you've done all those and you've connected them, you're probably making work that meets the needs of more user tribes, and that's a good thing. So we shifted the way that we evaluate our work by adding the metric of connectedness too. So we aim for beautiful constellations, not just solutions that serve one group, you know? The
Yeah.
more the merrier.
Yeah, and I think if we look back, this principle is actually happening already on YouTube. We had lots of advertisers that were already working with creators to create great commercials and ads for users. So a lot of this was already happening, and all we did on our end was we started observing this, and then we assembled a team of designers from product and marketing all together, and we started to think about the brand voice end to end on YouTube and came up with those words.
Yes, and those words, again, connected, human, spirited, simple, they became principles that helped us create a common language. That was the real thing that evolved, a common language for product and marketing to collaborate together.
Yeah.
So let's look at some of the ways we work to deliver on those attributes and principles. What comes to mind is the YouTube Music Awards. That's in a way that we ran with the idea of connected, right? So we streamed a live event from Seoul, Moscow, London, Rio, New York, so that the entire world could celebrate music on YouTube at the same time.
Very cool. And actually on the product side, I think I have a good example of connected.
Oh, all right, let me hear it.
So we discovered that creators really wanted to connect more with their viewers, and we built this tool that lets those creators see who their top fans are, and now they can actually reach out to their most engaged subscribers and start a conversation with them, or just say thanks.
I love that, like humans connecting with other humans.
Yeah,
Speaking of human, let's talk about LGBT creators on YouTube who made it a safe space to come out and speak their minds. We thought that was so awesome that we wanted to make a video celebrating their work in those moments, so we did, and then we asked people in that video to upload their own and join in using the hashtag #ProudToLove, and they did. It was an awesome response, and so nice to connect with the community in that way.
And now there's Proud to Play, right?
Yes, there's Proud to Play too. You can search for that video on YouTube. It's lovely.
Cool.
You know what? Tell them about that secret Harlem Shake Easter egg, because that is a good example of spirited, I think.
Yeah, it's very spirited. So if you go to YouTube and you type in "do the Harlem Shake" into the search field, the site actually does the Harlem Shake. It's pretty cool.
I love that. So this is the still image. You really have to go to the site to try it and see it for yourself. It's awesome. But you know, we wanted to express our spirit just like the original creators of the Harlem Shake and everybody who joined in with them.
Cool. So we also want YouTube to feel simple and easy to use. It's one of our biggest ongoing efforts.
Yep, that is true, and it's one of the hardest. One of the ways we tried to solve that was with an app called YouTube Capture, and it made it a lot simpler to upload videos to YouTube from your iPhone.
I think the original flow took almost a dozen steps, and we were able to reduce it down to just 2 steps and also include editing and enhancement capabilities. That's pretty simple.
Love that. Amazing. So I think, you know, when we look back at all these things, one of the things we learned was that no matter what we're doing, whether it's an app or a campaign creative, we can find ways to embody the brand attributes in our work.
And depending on the specific user tribe or the context, we can dial those attributes up or down. So they're really flexible. And I think now is a good time that we show a chart so this presentation actually feels official, right? You have to have a chart.
Yes, that would make this very official. All right, I think we've got a chart and it's called Find the Right Balance. Here it is.
So for a product feature, we look for solutions that feel connected and simple predominantly, and that's the blue and the purple on this chart. And then we throw in a dash of spirited and human. We always have all 4 attributes present.
Yes. So take the marketing campaign. All 4 are present again, but we want like a supersized helping of spirited and human. That's the yellow and the red pieces of the pie. And then connected and simple are there, but they might be side dishes, but they're still at the table.
Right. So these are actionable brand principles. That's awesome. Now, how about, what do you think we should do next?
I think we should wrap this video up with a bulleted list of takeaways.
Oh my gosh, you read my mind. I love bulleted lists, the best way to wrap up a presentation.
Okay.
So when you're designing your own thought guide, here's some things that we learned that we wanted to share with you. The first thing is it's hard to make good decisions with incomplete data or just one kind of persona. So if you can research real users and especially think about entire tribes of users, dig into that and identify your community.
Nice. Love that. All right, so once you've got your community identified, you know, those people are full of passion and personality. So why not look to them to help define your product and your brand?
And next, if you've identified your community, it's way, way, way more fun to design with them instead of just for them. So engage with the tribes on your platform as often as you can. Talk to your users and communities.
Okay,
Love that. And when it comes to brand attributes, I got a tip for you. You ready?
Yes.
Okay, so it's flex and fit. So choose words that are flexible in their definition, yet specific enough to actually work and be useful. And then once you get them, you can dial them up or dial them down depending on the context of your project or your work or the problem you're trying to solve.
Cool. And last but not least, think principles before pixels. Stay true to your community by turning those brand attributes into actionable principles that you measure all of your design work against. A thought guide can actually help any size company, large or small, with any type of community make better decisions. It's been a huge change for us in how we design and work.
Yeah, definitely. So thank you guys for watching. Thank you for your time. Check out some of the videos we went over and shared today on youtube.com. That's the website. And we hope you have a great, great I/O.
Hi, my name is Mark Renoff, and I'm an engineer with the Android Wear team. Today, I'm going to talk to you about how you can create apps that look and feel right at home on Android Wear. The home screen is the primary user interface. You can think of it as the launcher for Android Wear. It provides quick access to the information you need in the form of a stream of cards. Navigation is done by paging through them one at a time. Each row represents a single piece of content, and additional details and actions are available at pages to the side. By customizing notifications provided by your app, you can control the look and features of the cards that appear. This is the first step you should take, and you'll find details about this from our other team members. Now I'm going to show you how to take it to the next level. Wearable apps are standard Android apps designed with a small screen in mind. They run full screen with no system UI or status bar. The development process is similar to a standard app, but does require some slightly different approaches to UI. The biggest thing to keep in mind is that your interface shouldn't require touches to small points or precise dragging. For example, in the Wear system UI, you'll notice frequent use of swipe gestures and scrolling which snaps into place. This works well because it doesn't require close attention to exactly where to touch on the screen. To help you out with all of this, we're providing a UI library for Wear apps. It provides components which have been designed to maximize usability. In this talk, I'm going to cover Grid View Pager. This is what you'll want to use to provide an interface similar to the home stream. It's like a view pager, except it moves both horizontally and vertically. You'll find the latest details on downloading and configuring the library for your app at developer.android.com/wear. The first step is to create a layout. These few lines are all you'll need for your main activity. Here, the pager is configured to expand to fill the screen. Next up, we need an adapter. This provides the content for each page as the user navigates around. For this example, I'm extending from a base class with fragment support. Only these three methods are needed to create a working adapter. The first two provide the size of the content available in terms of rows and pages. Notice that the column count depends on a row parameter. The reason for this is that each row may have a different number of columns. One special feature is the option to control where in each row the pager is positioned. Instead of a fixed grid layout, it's possible to change columns while scrolling vertically between rows. We play some tricks in the layout to accomplish this, but the result feels seamless. Why do we do this? Well, recall that each row is a single piece of content. In the home stream, these are notifications or Google Now cards. When the user moves up or down from one of the action pages to the right, it would be confusing to land on an action for a different item. To solve this, paging up or down always moves back to the first column. This is also the default mode for Grid View Pager. To adjust this, you can override one additional method. This method is called whenever the pager needs to know what should be shown above or below the current position. The current column position is also supplied. To return to fixed movement system, you could choose to return current column. You might even want to save the last column viewed for that row and return to it the next time the row is selected. Finally, the most important method here is getItem. This is where you'll provide a fragment to be displayed for a page. Here you'll just return your fragment and the pager handles everything else. Fragments will be kept as long as needed and detached and reattached as appropriate. Again, this is very similar to a view pager, just with an added vertical dimension. To help with creating your page content, we've provided Card Fragment. Using this will automatically apply styles, which match the system cards. All you'll need to do is provide your content. This fragment will also give several additional features. First, if your content is larger than a single page, it allows for scrolling in place. You can also have it start out as a single page, which can be expanded with a tap. In this case, the content overflow fade is handled automatically. You'll find more details in the sample code and documentation. Some things to keep in mind: try to have only a single action per page. If possible, the entire card should be the tap target, and the action to perform should be clearly indicated. Now, all that's left to do is wire everything up. The adapter class handles all of the fragment operations, so it'll need a reference to the fragment manager. Assign your adapter to the pager, and you're done. Now you have a paging card stream style UI. It's that simple. We've provided a full example app using Grid View Pager along with the library, which I recommend you investigate further. In it, you'll learn some of the more advanced features of Grid View Pager that I didn't cover here. And don't forget, there are other useful UI elements that are part of the wearable UI library. Visit developer.android.com/wear for the latest on all of this. We hope these components make writing great Android Wear apps easy and fun. And as always, we'd love to hear your feedback. We can't wait to see what you build. Thanks.
You started an online store and the customers are rolling in. Your website is functional art, your ad campaign's gone viral, and the shopping carts are filling up. Your products have universal appeal. And you notice, hey, I'm huge in Japan. You're getting lots of international traffic, but it's not converting into sales. Why is that? After examining your analytics data, you see a lot of items getting abandoned during checkout. Do your international users just have a shorter attention span? Or is there something suboptimal about the user experience that is frustrating their urge to consume? We're going to address these questions and elucidate some of the famous question marks that beget profit. Have you ever seen an address in Japan? Let's start with something easy for me as an American. Here's where I work in Los Angeles. But here's where Googlers work in Japan. Let's remove the language barrier for a second. As you might notice, we're not in Kansas anymore. The order of this address is almost completely reversed from Western conventions. But you're smart. You can handle this. You whip out some JavaScript and manipulate that DOM. After a careful reading of Wikipedia, you are pretty confident. You can deal with users coming from Japan, shuffle your address around to make sure they feel right at home. Remove any impediments that might prevent them from obtaining the latest in wearable tech for their pets. But wait a second, every country does things a little differently. How many countries are there in the world? I don't know, a bunch. You're going to be up pretty late tonight, scouring the web for this sort of information for every country that likes cats. That's problem one. Now, here's problem two. Here's that address again, but this time it contains a typo. Can you spot it? I can't either. But users love typos, almost more than their cats. So you better figure out how to verify the address as it's being entered. Yo. Okay, I will end this rant. I hope you're convinced. Addresses are hard, and you just want to go shopping. But it's okay. Chrome's Request Autocomplete gives you all this and more for free. Request Autocomplete is a brand spanking new member of the HTML standard. And today, you can find it on Chrome for desktop, Chrome OS, Android, and iOS. And It's super easy to integrate into your site, which is nice. Request autocomplete remembers your address, so in practice, most of the time you won't need to enter a new one, but when you do, here's what it looks like on your phone. It's native UI. So this is straightforward to use as an American. You can put in your name, my city, all that stuff. That's well and good, but here's the hard part, Russia. As you might have expected, the address fields look quite different from the United States. For example, you see the postal code and the city fields on top of the street address and the name fields. What about validation, you ask? No problem. Request autocomplete can do that as well. Fantastic. Best of all, next time my address is ready and waiting for me. So, Chrome handles address input, data validation, and more while you focus on your product. Want to add request autocomplete to your site? Check it out here, or point your browser here. Easier internationalization is just one reason why request autocomplete rocks. The team is working hard to improve the checkout process for your users. Our goal is to help you maximize conversions and optimize the payments experience for the web, especially the mobile web, because let's face it, this resource is occupied. Until next time, I'm Ruslan Salamakin, and I'm huge in Japan.
Hello, I'm Dan. I'm a games developer advocate here at Google.
And I'm Crispy, also developer advocate at Google, focused on games.
In this video, we will discuss the high-level aspects of building games for the big screen.
Not that big screen. TVs, more like this one. We're going to talk about what to avoid, what to strive towards, and how Google APIs can help support bringing your apps to the really big screen.
Much of what we are about to show you will apply in the broader context of the Android ecosystem surrounding games. In particular, when you consider how many Android devices are able to connect to large displays using Miracast, DisplayPort, docking hardware, as well as TVs with Android built in, you have at your disposal a full suite of technology that can put you in front of an engaged and growing audience. There are a lot of mobile gamers in the world, and they're looking to expand their gaming experience onto the biggest screen in their home. We hope that after watching this, you will be inspired to make sure your users get the best gaming experience on the big screen. Android TVs are going to be coming soon to a family room near you, and you better make sure your games look good on it.
With Android TV, you get to build on your existing mobile development experience. You can now take full advantage of modern Android, including NDK support, to craft your gaming worlds in unimaginable ways. It's even possible to extend the gaming experience through second screen interactions.
TV game development might seem to be overwhelming at first, considering how many different aspects are involved. In practice, though, it's not very different from what you are already doing with your mobile game development. Your projects can be managed in the same way. You just need to factor in a few additional considerations.
Let's start with my personal favorite, game controllers. Many mobile games use gestures whereby the user touches the sleek glass screen in front of them to interact with it. This works fine on a phone, but not so much for TV screens.
My arms certainly aren't long enough to reach across my living room.
Mine either. On TV, mobile on-screen controls become useless.
And even if my arms were long enough, touching most TVs would just result in a messy screen.
Yeah, not many people have touchscreen TVs, which is why you need to add touchscreen required equal false in your application manifest. It's implicit, which means you need to make the distinction.
Luckily, every Android TV will have a controller capable of producing directional pad input, thus allowing the user to interact with the TV.
Yep. The Android reference controller is definitely a developer's best friend. It has exactly what you would expect a game controller to have. 2 analog sticks, D-pad, B, A, X, Y buttons, left and right triggers, left and right bumpers, back button, home button.
It can also be paired with any Bluetooth-capable Android device, which means you can play controller-enabled games on your phone or tablet as well.
That's a very useful thing to do in general. I'm always a little surprised and saddened when I find a game that would be great to play with a paired controller, only to discover it doesn't accept the controller as valid input. Even worse, some of these games have on-screen simulated game controllers.
Yeah, it makes me sad too, because the developers have already done the work of mapping to the same kinds of input, but did not include the button mappings to the hardware.
With all the game controller support that exists with Android now, I don't feel there's an excuse for that.
Maybe they just don't know about it.
Fair point, but, you know, if you're watching this, you know about it.
And knowing is half the battle.
Yeah, there's a few other things to know too, though. For instance, Android KitKat now supports the enumeration of controllers, and the game controllers that support this will light up accordingly.
In your application, you make a call to get controller number to determine the controller driving the input event being dealt with. You can use this feature to make sure your little brother or sister is playing as player 2.
You can now tell Google Play that your game requires a game controller. This could be used to stand out in the Android TV Play Store.
You add the details to the application's manifest. This example indicates that your game must be used with a controller. You can also list all the supported types of controls for your game. If you require either a multi-touch touchscreen and gyro, or will work with the game controller, then you can use feature groups to define it in the manifest.
Now that you've added support in the manifest and in gameplay, you aren't finished yet. You need to think about how the players will make menu selections and provide non-gameplay input.
One of the hardest things that game developers have to deal with is focus and selection. Many games designed for touch just don't yet have that concept.
You know, one place to start would be to change the color of the selected text. This alone is not enough though. In this example, you really can't tell whether the start game or settings is currently selected.
This is a bit better.
It would be even better if it were animated. You know, use motion to convey context.
Done!
You know, a lot of games have buttons to connect to social services, etc. These buttons are often in non-obvious places for navigation.
So, this is easier to follow, right?
Yeah, but you're clearly not a UX designer.
Remember, hire a good designer. One of my favorite recent games did a great job with bringing their game to the TV and navigating menus, except that it was near impossible to actually purchase anything in the game without touching the screen.
It fell down when it came to purchases?
No one had tried buying anything with a controller. Google Play in-app payments supports D-pad navigation out of the box with a UI that looks great on TV. But you have to make sure the user can get there. Making your navigation clear and understandable is just as important outside of your main menu. Make sure that your TV players aren't missing out.
Okay. Let's shift gears now and discuss another essential item on the TV development checklist, networking.
So, you're probably thinking that you know about network detection on Android. However, many developers forget to consider the possibility of Ethernet network connectivity when building for TV.
Android TVs have wired Ethernet ports to allow fast networking. This means that Wi-Fi may be turned off, but it's still connected to the internet. Mobile developers have not had to worry much about fixed stationary devices. It's not been common for developers to build their network checking code to consider connectivity beyond cellular and Wi-Fi.
The good news is that it's really easy to test for network connectivity without caring about the type using this snippet of code. But if you really want to test whether wired networking is active, you can check to see if the active network is of type Ethernet. Understanding the active hardware allows your game to make good decisions about using bandwidth. Speaking of hardware, Android TVs have graphics hardware exposed to the power of OpenGL-ES. You can draw at the full resolution of your TV.
With many pixels comes fill rate responsibility. Use your pixel power wisely.
Right. It turns out that we're not quite ready to draw graphically intense 4K scenes with mobile GPUs. Yet. But there's an easy way to tell Android that you want to render at a lower resolution. If you're using Java, you can call surfaceholder.setFixedSize, and that will tell our compositing engine to scale your smaller window to the size of the screen.
And if you're like almost every game developer out there and not implementing your graphics in Java, you can change the size attribute of the target window.
Hey, you can still use GL Surface View with the native renderer. The context are shared. The key thing is you want to make sure your games look beautiful on a large screen. Many of the shortcuts taken in mobile look glaring on a large screen.
Low-res textures, low poly count models, geometry rounding errors, poor bit mappings. Look, you know what I'm talking about here.
Oh, amen, brother.
So with all this cool rendering, there's another thing you have to consider when developing for the TV screen.
Other than epic sizeness?
Well, overscan. It's something that still inexplicably exists on modern TVs. Effectively, this means that some of your content may be pushed beyond the visible edge of the display.
So people should letterbox content and have borders?
No, just make sure you fill the screen, but keep the important information out of the outer 3% of the display.
Like what kind of important information?
HUDs, for example. It's kind of important for people to see those. It can become very annoying for the user to fiddle with their TV settings, trying to see the full UI of your game, only to discover that no matter what settings they play with, they still can't see the whole thing. Keep the edges of your game free of critical information.
I wish every developer knew about Overscan and didn't have to know about Overscan. Let's move on to what developers can do with Google Play Game Services.
Google Play Game Services have been optimized for Android TV with easy navigation and a great new look and feel.
You can also utilize achievements, leaderboards, quests, and more.
More being multiplayer support.
Yes, you can utilize turn-based multiplayer and real-time multiplayer from Play Services. There's even C++ support for turn-based multiplayer.
I want to see some awesome multiplayer experiences with people playing on their tablets in the same room so I can hear them groan. Second screen experiences in the living room are growing in number. Game saves can be a great tool for keeping your users engaged. Part of extending the mobile experiences to the TV means being able to continue playing on the biggest, baddest, most overscan prone screen in my house.
Cooperative multiplayer is also worthwhile. Play Games has a great API for peer-to-peer multiplayer with up to 8 players. It's so much cooler if some of them can be on TVs.
Everything's better on TV. You know, you can unlock the RTFM achievement.
Wait, what achievement was that?
Read the full manual. It's not exactly a manual, but rather a website. We're always trying to make it better.
And on that note, help us make TV games better. In this short talk, we covered a lot of ground, but there is always more to explore.
In summary, we looked at game controllers and the importance of navigation, focus, and selection. Networking and why it's not sufficient to just look for Wi-Fi. Graphics rendering on the TV and the challenges that Overscan can present. And finally, Google Play Services and how it can help bring about the best gaming experiences for your users on TV.
More details about how to get your game ready for TV can be found on the new developer site for Android TV, including important manifest changes to work with our new lean-back experience. You can get in touch with us at +Dan and at @DAGalpin.
And +Kristen Uccello or at @crispy_.
Now go build something fun, engaging, and big for us to play on TV.